have gathered here today to discuss a pivotal initiative that holds great significance of our nation's climate resilience and sustainable development. India Meteorological Department, under Ministry of Earth Science, Government of India is taking a proactive step towards the implementation of National Framework of Climate Services or NFCS. This forward-looking endeavor is aligned with Global Framework for Climate Services or GFCS, a global effort spearheaded by World Meteorological Organization. The NFCS concept is a collaborative platform designed to unite climate service stakeholders at both the national and state levels. Through mutually collaborative working arrangements, this initiative aims to collectively pursue the common goal of creating a climate smart society. With great pride and pleasure, I, Dr. Divya Surendran,
and I, Dr. Asha Latwal,
extend our warm welcome to each and every one of you to the picturesque campus of Christ University, Lavasa.
The NFCS is not yet formally established in India, but central and state level agencies access the climate services through bilateral arrangements. A more systematic approach for effective use of climate information is much needed to overcome some gaps and limitations. To address this, NFCS India proposes a flexible multilateral network for regular and well-informed decision-making in 5 priority sectors, namely disaster risk reduction, agriculture and food security, water resources, public health, and energy. In response to this, IMD planned to conduct a 2-day stakeholder consultation workshop on NFCS India during 5th and 6th October 2023. The resounding response we have received from various central and state agencies has been nothing short of astonishing. The overwhelming enthusiasm and eagerness displayed by these institutes and agencies to participate in this event is a powerful testament to our shared commitment towards climate resilience. This workshop is not just a gathering of stakeholders, it is a convergence of expertise, a symphony of ideas, and a commitment to a more resilient and sustainable future. So, thank you all, and let us begin this beautiful dialogue.
Now, I request today's distinguished guests to kindly come forward and take their place on the dais. Let us welcome them with a Tulsi plant. Dr. M. Ravichandran, Secretary, Ministry of Earth Science. Dr. Rupa Kumar Kolli, Vice Chair, WMO Standing Committee on Climate Services. Dr. Father Lijo Thomas, Director, Christ University. Sri K.S. Hosalikar, Head CRS, IMD Pune. Thank you all. No situation is so dark that there is not a ray of light. Keep your face forward, keep your face towards the sunshine, and shadows will fall behind you. With these words, I request the dignitaries to light the traditional lamp to mark the commencement of this beautiful journey.
Thank you so much, everyone. As tradition dictates, we commence our proceedings with a sacred ritual, the Saraswati Vandana. This beautiful invocation marks the beginning of our gathering, seeking blessings from the Ma Saraswati for a harmonious and successful event. I am honored to invite the talented students of this university, Ms. Malvika M. Nair and Mr. Ankit S. Nair, to grace us with their rendition of the Vandana.
कुन्देन्दु तुषारहार धवला या शुभ्र वस्त्रावृता या वीणा वरदण्ड मण्डितकरा या श्वेत पद्मासना या ब्रह्माच्युत शङ्कर प्रभृतिभिः देवै सदा पूजिता सा पातु सरस्वती भगवती निश्लेष जाड्यापः लोका समस्ता सुखिनो भवन्तु लोका समस्ता सुखिनो भवन्तु लोका समस्ता सुखिनो भवन्तु.
Thank you so much, Ms. Malvika and Mr. Ankit, for this melodious start of our program. So, moving forward for this inaugural session, now I request Shri K.S. Hosalikar, Head Climate Research and Services, IMD Pune, to deliver a welcome address to our gathering.
Namaskar and very good morning to all of you. It's been a wonderful place that we are visiting, Lavasa, and most of us yesterday evening or maybe from late afternoon we started coming and we are enjoying, breathing the scenic beauty of this campus and the around. So first of all, thank you, Karachi University, for providing this opportunity for us to have more closeness to the nature and enjoying, where the city life is so tight packed and so much of other things. This hill station stay is something very special for all of us. So, as a head of the Climate Research and Services Offices at Pune, India Meteorological Department, I take this pride to welcome today's chief guest, Dr. M. Ravichandran, Secretary, Ministry of Earth Science, Government of India. I'm very much thankful to you, sir, India Meteorological Department, and myself personally very much thankful to you that the time when we spoke to sir about this particular idea of having the national framework for climate, probably I feel that sir was waiting for this type of things coming from IMD, and he immediately agreed and he said, yes, we must do. This is something which is very much essential, and it is not one office that India Meteorological Department of Ministry of Earth Science that it can do. he suggested that, this would be like all India. It will not be one ministry. It will be interministerial. Many agencies, in fact, all the ministries, all the stakeholders, all the users who depend upon or who wants to have the type of exchange of climate data and climate resources and the information and the updates. Not that it's not happening, but in a very structured manner, when it happens, the results are totally different. And he said, yes, we must go. And he gave me an example that, the blue economy, sir, you were talking about many times to us, that he said that probably this could be, another type of, a big program that, the country like India can do. So I'm very much thankful to you, sir, for all your support throughout and ministry also. And really, I'm looking forward, we'll try to keep that momentum and what are the expectations that Ministry of Earth Science and the society is expecting from us. I welcome you. Then I have my friend, Dr. Rupa Kumar Kolli. He's a very senior person. He's a vice chair, WMO SC. Though he's so senior, but I still call him as my friend because he's really a more than friend, rather, I can say. And I welcome you, sir. He's the one who was involved in GFCS, that global framework of the climate services at WMO. And most of his services have been at WMO. And he was meticulously, working out, with us, helping us, guiding us for how to go ahead, how to write the scoping document, what could be, the scenarios, what could be the deliverables, how we should go and all about that. So really, we are blessed, to have this type of resources and, the people who are ready to deliver and help us. So I'm very much thankful to you, Rup Kumar sir. Thank you. And yes, Dr. I also welcome my friend, Father Lijo Thomas. And yes, this is the first interaction with you, sir. But I think sometimes, you just require a glimpse of the moment or, maybe a short moment to understand, what people are about. And I think we just had a meeting with Father, myself, Secretary Sahab was there, Rup Kumar Sahab was there. And we had a very short, brief meeting. Dr. Beki was also there, Anshul was there, and Dr. Beki, thanks for everything. So, and he gave out, in just a couple of minutes, he narrated that what Christ University is doing about, the community help and, the taking the weather messages to the farmers in the Lavasa campus and all that. And I'm sure I'm very thankful to him, for accepting our proposal that, when I approached Christ University, I said that, is it possible? I think less than 24 hours, I got the message that, yes, we can do it together. And really, this is something great. I'm looking forward for such type of more interaction in the coming time. And lot of faculty members from your university, as well as a lot of students, rather, helping us in entire this program before. And now next 2 days also, we are looking forward for that. So I'm very much thankful to you and the Christ University. And yes, the great audience who is sitting in front of me, I think almost everyone is 10 times better than, the expertise that I am having. They are coming from so many different organizations, ministries. I cannot take names of all of them, but I really see a very good response. In fact, from all the state governments, from all the central ministries, ISRO, power sector, water sector, I think all the sectors that are required in national framework for the climate services that I'm going to talk later on. So this is something, very overwhelming response from everybody. And this has probably given us a sort of momentum. When we were planning this program, we were slightly having one apprehension what would be the response. And sir, yesterday evening up to 5 o'clock also, there were responses from the people that they want to come. They said, okay, hotel book hai to bhi chalega, but we will come. hotels are full, but we will come. So this type of response, today also some people are coming. So this is something very nice, and I'm really very thankful, and I welcome all my senior delegates, colleagues, media people, everybody who is available, and my CRS team also who has been working, day and night for this program. This is something very nice initiative that Indian Meteorological Department is taking under the guidance of Ministry of Earth Sciences. This is something very important event. It is just a beginning, I should say. This is just a humble beginning. Probably the way forward is, something very big, and we will require, and we will definitely, work together, by which, there will be a sort of path breaking, scenario coming ahead. We had some incidents day before yesterday in Sikkim, so that highlights, what type of climate and weather, is kept in front of us in the coming time. The climate change, global warming, I think they have become very, very often used words, and sometimes they lose the sensitivity. That could be one problem here. But I'm sure this NFCS that we are planning, that national framework under the guidance of the WMO, under the guidance of Ministry of Earth Science, IMD, and all of you, probably everybody of you, are equal and maybe the same level member in this NFCS program. And I welcome all my colleagues here, all my friends here, all my senior experts here for this program. And I thank the Crash University, a very nice Vandana, and for very nice ambience you have given for us to conduct this. So thank you very much. And I welcome all of you once again. Thank you. Jai Hind, Jai Maharashtra.
Thank you, sir, for a very warm welcome address. Now I request Dr. Father Lijo Thomas, Director, Christ University, to give his address.
Namaskar. Good morning, everyone. Honorable Secretary, MOES, Dr. Ravichandran, Dr. Rupa Kumar, Vice Chair, WMO SCCS, Sri Hosalikar, Head CRS, all the respected and honorable delegates of different offices who are participating and presenting at this workshop. It's truly an honor for Christ University, especially the university, the Lavasa campus, that all of you are here who are committed and give their life for one of the most important, the hot topic, which is very closely associated to our life, which is most important than anything else, and life on Earth. The climate resilience and climate action. All of us, we talk, we do presentations. You give your life and do the real action for impacting the whole world, not only for the country, the whole world. And we are truly humbled with your presence. And we extremely grateful for each and every one of you for coming over this far. We always say that, I'm coming from the Bangalore campus. When somebody comes on that campus, they just stop by on campus. But, for they come for something for Bangalore, they may come inside to the campus, that's all. But if somebody comes in Lavasa, it means a lot for us because they can't come just stop by on campus. They are coming to the campus. And we are extremely grateful for each and every one of you for being here. And another reason why it is very significant for us, this is an educational space, it's a learning space. And we are holding more than 2,000 young people in our hands. And with your presence, because the whole directly around the 100+ students we have been working on or for the preparation of this one. Last night around 2 a.m. they were all still working and setting up everything and preparing. And directly these 100 students plus more than 10 faculty members are directly involved with this action is actually that transform their mindset. We Christ University don't believe in the transactional mode of education. We truly believe in transformational learning, which is truly happening after the classroom, outside of the classroom. So that's why the campus is built as a residential campus in the lap of nature. When everybody left from Lavasa, we are the only one here. And everybody asked, why are you still here? But we said, it's community. Because this is not for the advantageous situation we are coming in. Because our motto is excellence and service. So we believe that service, we know that when we go out of the way, when we do that extra mile is what service is. So we believe that but only through that extra mile, you get that excellence. The word excellence is when you do outside of your job description, outside of your commitment, which is grit, which is passion driven. That is actually making everybody truly excellent. So we communicate that. That's why this is a residential campus. That's why this is a 24/7 campus. All the students that can study and be here and on this campus and learn, interact with the teachers all the time. It's not just 9 to 4 or 9 to 5. It's like the round the clock we work and we learn. So, and it's very special that you come and stay with us. It's not just a one day, half day you come, this morning you come and leaving evening is not. You're staying for 2 days with us. It's very, very special for us. Our students, 2,000 students are watching you and learning from, wow, these people are not really preachers or teachers or talkers, pep talkers. They are truly live their life for this impacting the world. And we are so happy, and I wanted to take this opportunity to welcome you again as a representative of 2,500 members of this family. And on behalf of all of them, I just welcome each and every one of you to this space of experience where we can make and true learning and true actions from here. So from most of the time, the mountains are the space where we can really reflect deeply and stay away from all the crowds. And I encourage and invite, and it's an open invitation to all and each and every one of you, unofficially, please come by with your family, with your friends, and just come and stay with us. And because you are creating a vibe on this campus, and that is a true learning. Otherwise, our youngsters will stuck with that small screen. I want you to disseminate that legacy, that the values that you're holding to the next generation. Otherwise, it's a big gap and between our next generation, who are the real true torch bearers of who has to take up this action for tomorrow's. Thank you again. Thank you very much, and wish you all the best for this wonderful 2 days of experience.
Thank you so much, sir, for your encouraging words and your kind support in hosting this workshop at your esteemed campus. With this, I invite Dr. Rupa Kumar Kolli, Vice Chair, WMO, Standing Committee on Climate Services, and Honorary Scientist at International Monsoon Project Office, IITM, to give his remarks on NFCS. Dr. Kolli has made significant contributions to the implementation of GFCS during his tenure with WMO. Your presence is warmly welcome, sir.
Honorable Secretary of Ministry of Earth Sciences, Dr. Ravichandran, Father Thomas, my friend, Dr. Hosalikar, and friends. It's a privilege and honor to stand in front of you and share my thoughts on this very important event. And in fact, I consider this almost like a dream come true. because we have been thinking about this for such a long time, and finally this is happening. And this happened mainly because of the strong support provided by the Ministry of Earth Sciences and the India Meteorological Department, which actually helped us to actually realize this. And as already highlighted by my friend, Dr. Hosalikar, so I had the opportunity to play a significant role in the development of the Global Framework for Climate Services, and the logo that you see here. And for those who are not familiar with this development of this idea, way back in the 70s, WMO started a series of World Climate Conferences. The first World Climate Conference that was held actually led to the establishment of the IPCC that you all know, you must be knowing, the Intergovernmental Panel on Climate Change. And the second World Climate Conference in the 90s led to the establishment of the UN Framework for Climate, UN Framework Convention on Climate Change, UNFCCC they call it. And when the World Climate Conference 3 was being planned in 2009, there was a kind of a look for an equally landmark event in the climate arena. And WMO was looking for an idea where this can be put forth as the overarching outcome of World Climate Conference 3 in 2009. So in our group, in fact, we had many Indians as part who played a significant role. My friend Avinash Tyagi, who was supposed to be here, but unfortunately was not here. And a number of colleagues, even in the Indian mission, they actually helped us to flesh out the idea of providing climate information for the society to make decisions in climate-sensitive contexts with science-based information rather than doing it by qualitative understanding of the atmosphere or environment. And in fact, when you say climate services, this is not a kind of new concept. Climate services has been there ever since the human civilization has evolved, because humans were always observing their surroundings and taking decisions that best fit into the environmental context. But with the scientific advances in climate science and progress that we have made in recent decades, it's very important that we transfer this knowledge to the community. Otherwise, if somebody hears about global warming or monsoon forecast, it's not to satisfy the curiosity of individuals or academic curiosity, but to use this information to take decisions in all climate-sensitive contexts to either minimize the negative consequences or to maximize the advantages that it offers. So this is where the climate information actually has a great role in almost everything that we do, where climate is has an important role to play. So in that, I had the opportunity to help WMO programs in implementing GFCS. And when we actually came with this idea to India in those days, the very idea of the National Framework for Climate Services as a complementary aspect of GFCS was actually proposed here in India, mainly because India is such a large country with such diverse climatic contexts and diverse cultures, languages, etc. We actually needed a framework even within the country. You can't have a single solution for the entire country. So that is where the national framework idea was proposed as part of the discussions in India. And it took so long for us to actually reach here. And I'm happy that there is so much of encouraging response from all stakeholders. And I hope it will grow over a period of time. And more importantly, the very setting in Christ University actually brought us the bonus of the younger generation actually being part of this exercise, which is actually really good, which gives us some future that we can look forward to. And I also bring my continued interaction with WMO as part of the Standing Committee on Climate Services, which I still support WMO activities. So I've seen the implementation of the National Framework being set up in several countries with remarkable progress. And in fact, in many countries, the national framework actually is led by the highest level in the governance. Sometimes they are even part of the president's or prime minister's office. So that is the kind of level that the climate services need to reach, mainly to make sure that all the stakeholders work together in a complementary fashion, because each of us have our own strengths and understanding of the climate issues. But at the same time, we need to work together to make sure that we provide a comprehensive approach to deal with climate-related risks and manage them in a better way. And I also would like to mention another aspect that is in which I am also closely involved, that is the Indian Meteorological Society, of which I am currently the president. We have an Indian Meteorological Society where you have excellent climate science experts, both serving and also those who have retired, still willing to provide their expertise and help in dealing with many of the climate-related aspects. I think we have these resources. We have also Ocean Society of India, which Dr. Ravichandran is closely involved in. So these professional societies also can play a big role in helping us with the development of the national framework. So these are the ingredients that we have now. I think now our job is to actually to make sure that we prepare a good dish for us to actually enjoy in the coming years. So I am really looking forward to the National Framework for Climate Services to be fleshed out and come into practice. We are still at the beginning. We still don't actually know. Actually, it's better not to prescribe any particular way. You are here to actually discuss all the related issues and come to a conclusion and agree to implement the national framework in the country. And I'm 100% sure that this will lead to a better application of climate information, available climate information in the country to deal with all climate-related risks. And in particular, I think we have some additional work that needs to be done to involve state governments, especially in this area, because we have so many languages. It's very important that all the stakeholders actually understand and translate this information into the local languages so that all the end users are able to understand the issues and take better decisions based on the information provided. So I really look forward to further deliberations on this, and I'm very happy to support in whatever way that I can to help with many of these issues. And I compliment IMD for taking up this initiative, and I look forward to a successful conclusion of this workshop. Thank you.
Thank you, sir, for sharing your insightful remarks on NFCS. It greatly enriched our understanding and also solved the intricacies surrounding NFCS. Today, we are privileged to be joined by the esteemed Secretary of Ministry of Earth Science, Dr. M. Ravichandran. His expertise across various domains of earth science is truly commendable. His wisdom will undoubtedly deepen our comprehension. Now I welcome Sir to deliver his inaugural address.
Dr. Rupa Kumar, Father Thomas, Dr. Hosalikar, Dr. M. Rajivan, former Secretary, Ministry of Earth Sciences, Dr. Ajit Yahi, former DG, IMD, and my colleagues from Ministry of Earth Sciences and from various ministries and state and other delegates and invitees. A very good morning to all of you. Indeed, it is a great pleasure for me to be here in this occasion. And of course, we were talking about this climate services very long time, but we are not able to make it beginning. I think for that beginning, I first congratulate and I thank IMD, Dr. Hosalikar and his team for making this to happen. And especially I'm thankful to Dr. Rupa Kumar for initiating and nurturing this theme, and it is the value of these important services. And secondly, I also thank Christ University for hosting this particular workshop, because this is the ideal platform to demonstrate this is what the atmosphere, or this is what the climate, but how it has changed everywhere. So this is the typical or ideal site where it should be climate. So to demonstrate that, I think it is a right place to host this at this place, and it is a very, very apt location to discuss about the what are the services are required. As pointed out by many others, this all 5 services is very important. Maybe right from the beginning we can start. When you talk about agriculture, and the weather patterns have changed a lot, quite a lot in the last few decades. So it is imperative for us to change our traditional patterns, how to move forward with the changing weather patterns, either precipitation or drought or extreme rainfall, all these things, how to take care. Take care means how to mitigate, how to have a preparedness. For that, we need to have a better services. What are the services is needed, or what are the information is needed? It is imperative we have to look for various in the long-term climate-related services. Similarly, when you talk about energy, I think the energy sector is very in need of the weather and climate services. Maybe they want to have the wind energy to harness. What are the wind patterns is going to change? And there are many other energy sector. They are looking at hydrology and other things. What are they going to change? And I think the main thing is we have to have a better preparedness, and also we have to adapt the changing environment. How to do that? For that, what are the services is required? Similarly, all other 6 things, various services we need to have or provide services. What I understand is basically we have large amount of data collected over the period. I think India Meteorological Department has collected large amount of data, and they can produce a lot of services. Basically, the objective is we need to translate the whatever the science we learn, and we have to translate into services for the society. So that for that, what are the things are required? So they have ingredients. Maybe for making the lovely food, they have a lot of vegetables and maybe so many ingredients they have. But they are confused with what service to give or what food I have to make for the people, needy people. So the needy people is the various stakeholders. What are the things are required? Maybe somebody is required, maybe South Indian thali, or maybe North Indian are required something different. So each state is requirement of climate services is different. So we need to take various stakeholders concern or what is their need. We have to understand. Once you understand, so what is available resources in terms of data and information, we need to translate to their needy. Otherwise, it will be very difficult, or we have to, maybe it is a complicated process. I think for that sense, I think various stakeholders, those who are present here or maybe in your colleagues, I think we need to get more and more information about what you need in your state. Maybe if you are in a coastal state, you need different services. Maybe if you are in the hilly terrain, you need different services. So for that, what are the services is required? I think it has to come from input in the climate related things. It has to come here. We need this. This is what changing. We need this information. Then they have to look at it, whether it is possible to provide with the available resources or what are the things they have to think about it. But then they have to try to cater. So I think it is a giant endeavor, and we need to look at the what are the ways to provide that services. We have to collectively look at it and do that. I think, and the third point I want to stress upon this, though we have various services and other things, we need to develop, make awareness about the people. What are the changing things are happening? For that, we need to take what is called, along with this, the youngsters. So what are the changing patterns happening, and what are the ways and means to understand, monitor, and model, and to get more science, and what are the changing patterns happening. So we need to involve them youngsters, and also we should have a complete training module for that. Maybe the various climate services, what are the services we can provide different groups. And youngsters also we have to keep on board for making awareness about the future scenario and other things. I think it is imperative we should have a separate model for capacity building and training in this aspect, apart from making various services. I think the Ministry of Earth Sciences will definitely support various, whatever the format. We would be very happy, and I think this is not the one ministry's endeavor, as we pointed out. I think maybe the government of India's initiative of Gati Shakti. So similarly, we have started a blue economy policy. This is our multi-ministries endeavor. Similarly, this climate services also, we need to start a multi-ministry endeavor so that we can have a what is called better services to the needy people. I think government of India will definitely look forward various input from these people. Even I think last week I was in PMO, they were asking about they want to go for some economic negotiation, business negotiation with country. So first one, other countries, they are talking about the climate. And our people, when they are going for business negotiation or any other negotiations, they are not aware. So they are all going for policy makers or economic advisors. They are not aware about the climate. So they also want a separate training model for how to negotiate with the other government and other things, especially related to the climate services and negotiations also. It is mainly the services they are talking about. There is a what is called economic advisor in PMO. His main interest is to develop a climate services for India, as well as we should be lead role for not only for India but also global South. So that is the way we have to look at it. I think it is a good initiative. I think we have to demonstrate these services, importance of the services and need of the services, and how to demonstrate to the reality, not only for India, but also entire global South and the global community. I think with this, I am sure that today's workshop will bring out some of the recommendation, so that what are the services we can provide. Then later on, how we can evolve over, because it is a dynamic things. It is not that today we fix these services. It is not true for every time. So we need to go for evolving nature of services, the climate related services. For that, I think we need to make a mechanism how to evolve, or maybe if it is required, even some country, I understand some country, each climate services is a separate institute, like a drought institute. So how to translate or how to provide the information about the drought. So that particular institute only looking at for that is drought. And some country they are maybe for extreme rainfall, another institute like that. Whether we can have a separate entity or collectively together all the climate services, whether we can go for it. So that we need to discuss internally, and maybe we can make a forum, or maybe we can have some body, then maybe institutional mechanism we should have for providing these services. For this, I very much I'm looking forward various state department and other people to come forward to ask for what services you need. Of course, we need to demonstrate what are the service we can provide. So both together we have to match, so that we can have a respective, people will have a respective state or whatever the thing, we can have our needy food for the betterment of our life. With this, I once again thank you for inviting me, and also it is a good initiative. I am sure that this will pay for definitely a good service for the country which we need. Thank you very much. Thank you.
Thank you so much, sir, for your inspiring inaugural address, and also highlighting the sector-specific challenges and requirements of the users, and also stressed upon the collaboration between different stakeholders in view of the changing climatic patterns. Now it's time to felicitate our guest present on the dais with a memento. So for this, I request Head CRS, Sri K. Hosalikar sir, first felicitate our Honorable Secretary, MOES Dr. M. Ravichandran. Now I request sir to please felicitate our director and father, Dr. Lizo Thomas of Christ University. Now I request to please felicitate Dr. Rupa Kumar Kolli, Vice Chair WMO Standing Committee on Climate Services. Now I Now I request Dr. Rajiv Chattopadhyay, Scientist, IMD Pune, to please felicitate Head CRS Sri K. Hosalikar. Thank you so much, sir.
Thank you all. It was a pleasure that these dignitaries joined this event and bestowed us by being our guest. Now I invite Dr. Satyaban B. Ratna to please come forward and propose the vote of thanks.
Good morning, ladies and gentlemen. At the very outset of this program, I thank Secretary Dr. M. Ravichandran sir for his presence in this workshop and his valuable guidance right from the beginning. Although this program is planned for many years in IMD, and we are working for the last 2 years very seriously to make it is a successful event. And whenever last year even Secretary sir visited our office, whenever we proposed all our plans to organize this workshop, he wholeheartedly supported and guided us how to move forward. Not only that, any things required at a higher level in the central level, he supported that everything can be done. So he asked us to go ahead. That helped us to come to this stage. Today, our DGM sir could not present, but he also continuously supporting and guiding us to organize this program. Probably he'll be here to make his remarks tomorrow, but we are also continuously getting the support or guidance from our headquarters to organize this program. I also thank Rupa Kumar sir. By his speech, you must have understand that how the NFCS started and how deeply he is involved. And as this NFCS, the climate services as such, it is okay, and climate research is as okay, but national framework for climate services is something different. It is not very easy concept, but we are also struggling how to take it forward. So luckily, those Rupa Kumar sir is here, who was involved with NFCS beginning, right from the beginning at the WMO. That actually really helped us. In fact, we can call him as actually our NFCS guru, because in every steps, we continuously taking his suggestions and how to make various steps to move forward in this NFCS. I also thanks Head CRS to take this leadership in our CRS office and guiding us to all our office colleagues to make plan and how to bring everybody together so that we are here all in the Lavasa. And we thank our host, Dr. Father Lizo Thomas, for hosting this event in the Lavasa. So whenever our officer, Hosalikar sir, proposed to host this program at this beautiful campus of this Christ University, then Father Thomas immediately said, it is a climate-related event, so we are very much looking forward to it. And from that time onwards, we are getting continuously support, and we are coordination wherever, whatever required. We got all support from the Christ University. Thank you, sir. I also thanks for all these participants, especially various senior scientists or officers from the various central ministries and state governments. Although we know they are very busy with their own ministries and their own sectors in the different offices, by understanding the importance of this NFCS meeting, they are all here together. That is, thank you very much. And especially we around for the timing 10 to 12 state government represented from various states, they are here. At the last moment, we also received many requests. Within last 2 days, we received many nominations, because initially this program was planned for 60, and the last 10 days it reached 70. By the day we started the program, it is almost 90, sir, actually. So this shows how much people are very much positive to come together. That is the climate challenge we are facing, and how to find a solution for it. Not only that, apart from this various central ministers and state government, many professional bodies, NGOs, media, and academic institutes are here. Even similarly, many, because India is such a huge geographical region and huge population, we received requests from many academic institutes to be part of this program. But as you know, it is very difficult to accommodate all. But this is the actually, we are calling it the National Framework Climate Services for India. But we are sure that by seeing that huge responses, there will be a series of NFCS meeting. It will start, we hope that with all your support, NFCS 2, NFCS 3, it will go on like that. That is what we are looking forward. And as a host university, we would like to thank the dedicated support from our Christ University's faculties and the wonderful students. They are standing here, you see, they are really working hard everywhere. Last 2 days we are here, we see every corner of the campus, just they are here to make this program a grand success. Thank you, all the faculty members and my dear students here. And apart from that, I would like to also thanks our IMD office colleagues, those who are working for last several months or several years, and even last few days within this campus to make this program a grand success. Thank you very much, everyone, for your whole support, and we are looking forward to a strong debate and discussion during the next 2 days. Thank you very much.
As we are moving forward for our first presentation, so for this, I would like to request all the dignitaries present in the dais to please have a seat in the front row. And meanwhile, we will make the arrangement for the presentation. Thank you to all the students who made this arrangement so quick. So, for the first presentation of the session, I would like to invite HCRS Sri K.S. Hosalikar on the topic Climate Services in India.
Yeah, good morning to all of you once again. I've been given a task to make a presentation on climate services in India, an overview. This presentation I am making on behalf of our Director General, Dr. Mahapatra, TG IMD, Vice President at WMO. Dr. Mahapatra will be coming today evening because there was yesterday night some urgent cabinet meeting was there, so he could not come today, but definitely he'll be available with all of us for tomorrow's from morning session onward. So that is one point. And yes, there is one small announcement that I want to make here, that it's a great privilege for me to announce this and to submit it here, that India Meteorological Department and Crash University are going to sign a scientific MOU tomorrow in presence of Dr. Mahapatra, and I think we can have a round of, yeah. So what Secretary Ravichandran Sahab mentioned, that, this type of collaboration with the academic universities, students will further strengthen, because the students are the ambassador for the climate services in the coming time. So we are going to sign this MOU, sir, tomorrow morning when Dr. Mahapatra will be available. I also thankful here to Rajivan Saab, Dr. Tage Saab, who have come here on our request. And then there are so many other senior scientist delegates who are here. In front of him, I have to make a presentation. I'm sure about my limitations. And I'm going to make this presentation in front of all experts like you. So if there are any mistakes or if there are any errors in my presentation, kindly excuse me, or definitely you can correct me also. So with these few words, I'll make the presentation, climate services and overview. So what is the bottom line of the, when we talk about the framework? Framework means, we want to design a sort of house where what will be at what corner, where will be the kitchen, where will be the hall, where will be the windows, what will be the ventilation, from where the sunrise will come, what time, the lights will be available and what not. And so like when we design our house, probably this is also like a designing house, but on a larger scale, a climate scale. And climate framework, when you're talking, I thought I'll pick up this line, which all of you are reading, that owing to lack of understanding and data being unavailable, these are the facts: unusable, unsuitable, weather and climate information is currently underutilized in sustainable development goal implementation, that is SDGs. Improvements are essential in knowledge brokering, clarifying responsibilities, multi-institutional and multi-stakeholder governance arrangements, and research on a systematic risk decisions. So this by Greeks, and this was recently I've taken from one of his paper, 2021. So the second line, the first line tells about the status. The second line speaks about the action that is planned, and probably NFCS is the line that we are going to address it today. As we are in the state of Maharashtra, so I just thought, I'll make one small presentation, because Lavasa being a hill station, the temperatures are really very nice. But if you compare the state of Maharashtra, I thought I'll just present one data from 1875 to 2022. So you will see all those red lines which are here are indicating that something is happening related to the temperature. The anomaly is going positive. It means the temperatures are on rise. Of course, this type of graphs you must have seen in many forums, in many workshops, and probably all the places in the country and outside also you'll find that something happened after 1970, 1980. And then there's a beautiful picture I posted. It's again one of the hill station, not Lavasa, but this is something which I took a photograph sometimes from the Google. I think it's Bombay-Pune Super Express Highway. Again, a beautiful scenic travel. People are traveling from Mumbai to Pune. They can witness. So there's a line from Padma Purana. These very old scriptures, ancient scriptures, Bhumi Kanda. It says that a person who engaged in killing creatures, polluting wells, ponds, and tanks, and destroying gardens certainly goes to hell. I don't know whether the hell or a heaven exists or not, but I'm sure we all will agree that if we are doing that, if the society is doing that, then the place where this beautiful planet Earth will no longer become a hospitable place. It will no longer remain a place where to have a sustainable development and the life on the earth. So the very old scriptures, they were also knowing that that lot of disengagements with the nature and not respecting the nature or the climate or the weather probably is not going to help us for the sustainable development in the country as well as globally. All these pictures you must have seen very frequently. Nowadays, this type of videos, images are many times, you'll be able to see it on social media, television, news channels, and whatnot. 2 days back, one incident occurred in Sikkim also, and we all understand that there are a lot of deaths also, a lot of human deaths are also there, loss of property is of course there, but something that is something which is beyond certain predictionable levels. So what we see, the landslides, mudslides, entire villages are washed away in overnight. Floods. Recently, 2022, we saw historic floods in Pakistan. We saw historic heat waves in India last year. So many things are happening frequently. And there is one danger here, that when things start happening frequently, sometimes we start getting used to see that, having a cup of tea and saying that, yes, I saw it. And then probably we don't pay much attention to it. But maybe people like we all who are working in the sectors who are closely associated with the climate and the weather, we understand that what we see is just a trailer, the promo of the bigger movie that is going to come in the next decades or maybe a couple of decades. And that's why this necessity of the climate framework is something very, very essential. And we were really working on that, seriously working on that for last 2 years. And we found that, we started with the scratch. We referred a lot of documents available. We referred, I remember Dr. Tage is here, Rajivan Saab is here. We took a lot of inputs from them. We took a lot of inputs that are available from various WMO people who have been working here. Tage Saab was there, Avinash Tage, and so many other people. And then we could come out with some scoping document that how this could be related. And then we understood one thing, that this program, what NFCS we are talking, this cannot be centering to India Meteorological Department, as already Secretary Saab has mentioned. This is much more than that. Again, Secretary Saab was very humble to submit that even this will not be centering to Ministry of Earth Science. It is outside Ministry of Earth Science. Probably the highest leadership in the country, Government of India, probably at some stage will take over this, so that all the interministerial collaboration and cooperation that we are expecting in this type of national framework will be possible. And with that only, this type of NFCS is being planned. So coming to the weather science, weather and the climate services for the self-reliant India. So the goal is, we should be self-reliant. So I call it as a SRI. So this is a quantum jump in the economy. And so how this economic quantum jump is possible? It is possible mainly because of the meteorological observations and the forecast for optimum operation of weather and the weather-sensitive services. Weather-sensitive services, I think all delegates who are present here, representing different ministries, different states, different positions, very senior IS officers, and very key stakeholders who are present here. Everyone is definitely having certain position, responsibilities, domain. So we all understand that what is the meaning of that sensitive activities. And hence, to enable the enhancement in the economy, this will be very useful. So contribution to economy through this is, that we want to have the predictions not only over the land, but over the ocean also. So we have in India Meteorological Department, Dr. Mahapatra, we all know that he's a cyclone man. We have Dr. Ravichandran. With his permission, I can say he's an ocean man. He is saying no, that is his humbleness, but probably I think a lot of things, because it's just not the land, but the oceans are also very important. And that's why the atmospheric observations, oceanic observations are also very important. And we give forecast at different scales, temporal scale. Temporal means time scales that we are giving. So I just want to, because there are many people who are coming outside IMD, so I thought, of course, they may be knowing about it. But we give forecast from few hours to 1 to 2 days, 1 week, more than a week, 1 month forecast we give. And the seasonal forecast and the climate scales forecast also is given by, not by IMD, but MOS institutes like we have, IITM and NCMRW who are developing this type of potential to give the climate scale forecast also. I remember when the August rainfall monsoon was deficit by 36% in the country, and in state of Maharashtra it was more than 45 to 50%. We were looking at, what would be the scenario in the September, and the seasonal forecast and the extended range forecast which came on the 1st September. We clearly mentioned that probably the first week of September, the rains will start. And it so happened that entire country's figures, they changed in the month of September. And with the deficit, we came up to the 96%. The state rainfall for the Maharashtra also became normal. So entire September, from 3rd September to almost 29th, 30th September, I think people started asking whether this rainfall will stop or not. And there were a lot of rainfalls in the places like UP and Bihar and Uttarakhand places where entire June, July, August rainfall was not there. So the extended range forecast, the capabilities and the confidence level has gone to a very good level by which we are able to do it. And of course, when I'm talking of the time scale, I'm talking of the spatial scale also, that, we are able to give, what can happen at a particular location, a block, a district level forecast, block level agreement forecast, district level agreement forecast, and of course, meteorological subdivisions. When we say meteorological subdivisions, it's a combination of number of number of districts. Like we have, suppose in the place like Maharashtra, we have, the Konkan subdivision, and then we have Madhya Maharashtra, Marathwada, and Vidarbha. Like that, there are subdivisions, and these subdivisions will have more or less a sort of common weather pattern. That's how the subdivisions are divided for the addressing the weather scenario. And of course, the homogeneous region that we define in our IMD, like Southern Peninsula, Northwest of India, Central India, and of course, the Northeastern states, etc. So there are different scales, temporal and the spatial scale, on which we give the weather forecast and the climate forecast also. So over the past few years, with your permission, I can make this statement that there has been definitely improvement in the weather, climate, and the ocean services provided by Ministry of Earth Science. And this has just not happened overnight. There are a lot of efforts taken by the entire fraternity of Ministry of Earth Science, all the involved institutes, organization, including India Meteorological Department. It's not just one man's show. It's an entire team, and the government of India has huge support to come out to a level where, there are certain things that can be addressed. And how we did it? Yes, we thought of, first of all, augmenting or putting up the atmospheric and the ocean observations to the best possible way. I remember that earlier, just to give an example, that since we are in Pune, so Pune had only 2 or 3 weather observing stations in Pune. In last 2-3 years, I'm happy to share with you that almost we have got 40 observation stations functioning around the clock. And I thank Dr. Beki and Christ University that when I approached them, that to have one automatic weather station in Lavasa, because this is very important. Ghat areas, rainfall data is very important to provide, the alerts and, the red alerts, especially in the Ghat areas. And then Christ University agreed, and we have one functional AWS for last 3-4 years. It's providing a lot of very important data, not only for IMD Pune office, but entire Maharashtra state and the country-wise also. Something very important. And then developing adequate modeling strategy. We have the institutes like NCMRWF, IITM, they and NCOIS also. They do a lot of work on the modeling, atmospheric modeling and the ocean modeling, etc. And of course, the cutting edge research and investing the human resource development. Of course, we need a lot of people to do this type of work. A lot of new ideas, a lot of things are coming. AI ML is coming, big data science is coming. So to do all that, you need huge resources, you need huge computing facilities, a very big computing facility, as I understand that it is coming up very soon in the place of IITM also. We're going to bring one radar also in Pune. For that also, one radar is going to come in Pune very soon. That has also been there. I'm also happy to share here that, India Meteorological Department is entering into 150 years of their services from the December onward. So there's a big plan. I'm sure Christ also will take part. We'll collaborate with them also to have some program as a 150-year celebration in this. Of course, I'm talking in between so many other things other than this topic which I've given. Kindly excuse me. Yes, and then there are various sectors where we give. It's not only, the forecast, but, the sectoral applications. So there are so many sectors, we have mentioned here, but still, I would say that, there are only few sectors I've mentioned here. In one of the interview, Doordarshan asked me, what are the sectors where IMD provides the weather service? I said answering that question is very big. If you ask me a question that what are the sectors where IMD is not giving the service, probably that I can answer, and the answer is nil. And new sectors are coming up very fast. IMD didn't thought of certain sectors. They are coming up very fast. They are approaching IMD that whether you can provide weather service, whether IMD can become, the commodity, the share market commodity, whether we can put weather as a commodity in that. We don't know anything about it. At least I don't know anything about it. We are working on that, how we can address this type of issues which are related to the finance and, the economy of the country. So there are various sectors in which, India Meteorological Department, under the guidance of Ministry of Earth Science, is providing the services. And then there are specialized climate services, which I don't want to read it here, but we all know that. Of course, again, there are a couple of them, I can say. These are all specialized services like hydrometeorological, information, regional, RSMC. RSMC means, the cyclone services, satellite meteorology. I have a friend here, Dr. Thomas is here from ISRO ISTRAC. So, we are dependent on so many agencies for the space observations also, the remote sensing observation also, and definitely, as NFCS, one of the pillars is, the observational network. That is very important. And this type of specialized services are at the 3 levels. One is national level, regional level, state level, district level. The demand is narrowing down to the city level, and probably now people want that Har Ghar Mausam. Ghar Ghar Mausam is, something that India Meteorological Department is, trying to, go to that granularity that by which, the weather forecast is available at this type of information, where the capacity recently for Delhi, less than 400-meter resolution model guidance is now made available by NCMRWF. And then, yes, weather climate services for SRI, as I was talking, that what we need, probably what we need, the number one of the objective is weather hazard should not go undetected and unpredicted. That is the first bottom line that, India Meteorological Department is looking at it. That nothing should go undetected or unpredicted. Yes, we may we may fail sometimes. It may get deviated than what we have predicted, but at least we must know about it. But then, really, I'm telling you that this is something, a very big challenge in front of us. That since a vast country with a huge different terrain, you have dry deserts, you have warm deserts, you have the tropical scenarios, you have the coastal islands, you have the hills, and I mean every state, every place is different. And then early warning, which even WMO has taken up last year, that we want to have the early warning system. The dangerous scenario in NFCS is, as I was discussing with Dr. Rupa Kumar, that more than 50% of the countries in the world, they don't have early warning system. This has been statement by the WMO. And if they don't have early warning system, imagine that you don't know the cyclone is coming to you, or heat waves are going to happen, or cold waves are going to happen. What could be the scenario? Probably this early warnings, this type of system, which is there. So when I say early warning system, many people ask me that whether early warning system means whether your instrument. I say no. Instrument will only give the trigger. IMD will give the forecast. But the society has to receive, the stakeholders has to receive in a way by which they understand what actions are required by them. Otherwise, it's something like, I cook something and I speak in Greek and Roman, you don't understand it. So I have information, but I am not able to communicate to you. So the early warning system is, a sort of package in which, along with the Indian Meteorological Department, the early warning system agency, we must also have, the stakeholders who are the part and parcel of it, who understand what IMD says. And then according to the actions are being, the created or the plan. So that's what, we are expecting. And of course, the technical support in different preparedness, planning, and management of the natural resources, etc. So whenever this multi-hazard is new word which is coming, there are a lot of new, jargons of the words which are coming in the climate scenario. If we open the WMO website, probably there are 99% of the abbreviations. Currently, I am still to understand that what are they. But still, I feel that, MHU must say the multi-hazard early warning system. So there are, we can classify them as maybe, if you see on the left-hand side, this left-hand side and right-hand side. So what is there on the disaster side? So whenever the disaster happen, what is my response time? So whenever the disaster happen, what is the response time? The lesser is the response time, the better, is the, the solution. I was attending one workshop at Uttarakhand, and somebody presented about seismology. And they said that, in China, in Japan, they are able to give early warning system for the earthquake also. Then suddenly somebody asked, sir, what is the response? What is the lead time that you have? They said only 15 seconds. Everyone laughed as you did it. Then he said, yes, these 15 seconds are very crucial. When it comes to your life, you have to just jump out of, your house. That 15 seconds is sufficient enough, by which you can leave your place and you can leave your office and you can just come out and come on the main road in that 10 to 15 seconds. You don't have to save your TV, fridge, and wallets and mobiles and everything. You have to just jump. The moment warning comes. Of course, for that, the self-disciplined society is also required. Kai bar aise hota hai, when I say early warning, as I made in the first statement of my slide, warnings are given. Sometimes people tend to take it lightly, and then they, enter into a sort of scenario where, it's a, no U-turn is possible in that. So this type of, in 15 seconds, I'm talking, the lead time for type of seismic activity or early warning system for the earthquake. I'm sure whatever warnings the Indian Meteorological Department is giving, probably, 3 hours are sufficient, quite sufficient, to take a lot of actions, mitigation action for them. And of course, there are different forecasts that we give on 3 days, 10 days warnings also. So that is what I'm talking of, the response. And then this is called as, how do we recover after the post disaster? On the left-hand side, when you say the pre-disaster, that is, the peace time. That is the time when we plan. That's the time when we sit and plan what we can do. So preparedness, and of course, then we plan certain strategies. We bring the resources into the picture, how quickly we can do it. There are a lot of exercises that have been done. I was working at Mumbai airport. I remember suddenly they told me that you have to vacate this place within a couple of minutes. There is a bomb threat. I was not knowing. I just left my computer and I just ran out of the airport. We stood somewhere outside the airport, Mumbai airport, and then one van came and one man, wearing the space suit. I remember, that BDX, bomb disposal squad is there, and they came and they did something and then they went. Later on, I came to know that it was a sort of mock drill. They want to count, how much time we take, when such type of scenarios take place. And then they, based upon that, they keep, the infrastructure available, whether the doors were available to come out very soon, whether the lifts were working, or whether the people were, sufficiently sensitive about to understand what is the meaning of that. And of course, this is something called as, the mock drills, which are very important. So these are all things we need to do while we are making the preparation, especially in the peacetime. So similarly for the climate also, we need to have this type of course, this slide, many of you must have seen that what we do. So as far as the forecast is concerned, so when we talk about the forecast here, so we have the initial conditions. So any time when a model is run or a forecast is given, we as a forecaster want to know what is the initial conditions, and the better the initial condition, probably the model, the data which will go into the model, that will prove, the best ability. And getting this initial condition to the best of its truthness is something very challenging. It's not very easy. And then based on that, the models are run, not one model are run, many models are run, and there are different runs are there, and consecutive runs are also there. And based on the products is generated, and based on that, the decisions are taken. This is just a small flow chart in which, the Met department works, that, it's not like, the parrot comes out of the cage and gives a forecast. It's something different than that. One forecast generation, that it takes a lot of time. And there is something which I want to share it here with you, that in all good forecast, everything is not good. And at the same time, in a bad forecast, everything is not bad. This tells, a lot of things. When you repeat this line, probably you'll understand what I want to convey, that it's not every time that, in a good forecast, everything will be good. The vice versa, in a bad forecast, everything will not be bad. So something might not have addressed by which the things got deviated. So, I'm sorry. So these are the observational network that we have. So initial conditions, what I was talking about for the requirement of to give the forecast. So we have got the all India presence for the observational network. We have radars, we have the ocean observations, we have the coastal radars, we have departmental surface observatories, upper air observations, everything. What we see looks very pretty, but I still feel that, this requires maybe 10 times more improvement in the observational network. That's what, the ministry is expecting, and as a forecaster or as a weatherman, I also understand that as many as, the observations are available, and they should be consistent, they should be accurate also, and they should be in real time available to the forecaster desk, by which, we should be able to, give or get the more better forecast that can be generated. And yes, there are a lot of other observations that I was talking about. Currently, we are using INSAT 3D and 3DR. If you go to India Meteorological Department page, there are a bunch of, a rainbow of products which are available for the satellite products also. Of course, I don't want to spend time here. There will be somebody who is going to talk more about this. And so we have this type of capabilities where even the satellite images, because a lot of weather happens over the oceans where, the observation is one of the big challenge. Of course, we have buoys and we have ship observation, but otherwise, to have the global observations, especially the systems like low pressure system, depressions, or the cyclones, or maybe the remotest areas, in the Himalayan region, to have the satellite observation, a high resolution satellite observation is something very important. And these are the different models which are run at a different time scale, which I was mentioning. So nowcast means, what's going to happen in next 3 hours. That's very important. And accuracy of the nowcast, India Meteorological Department has come out with a figure of more than 85%. It's something very astonishing. So the ability to give this type of at least 3 hour lead time severe weather alert, that what's going to happen next 3 to 4 hours, the accuracies are more than 85%. It's very useful. For that, of course, we need certain equipment like radars and satellite, and of course, the model guidance also helps us. So there are different types of scales at which, this type of forecast is generated. And when we started using the forecast, I remember Rajivan Saab was there leading the Ministry of Earth Science at that time. He came out with a statement that, India Meteorological Department needs to come out with this type of impact-based forecast also. So what is impact-based forecast means? When I say that extremely heavy rainfall is going to occur in Pune or maybe in Delhi or maybe in Uttarakhand, I should be able to tell what impact it will have. So the moment I'm able to take the impact, probably the stakeholder for that particular impact, will come into the action, and he will understand that what action is expected from them. Of course, we started this couple of years back. We are not master into it. Still, a lot of information is needed. A lot of developments are going on, and we need a lot of GIS information, and real-time information is also required. But this is the need of the society, that they want to know what could be the impact, whether the traffic will get affected, the roads will get inundated, what type of inundation will occur. For example, in Mumbai, we devised a system called as the flood warning system in Mumbai, and that was done with the India Meteorological Department, MOES, and NCCR played a very important role. So by which we are able to give what would be the inundation on a extremely heavy rainfall at what level. So thereupon the people can take action, the municipal authorities can take action on that. And then reaching out to the people is very big challenge in the country like India. I mean, city places like Bombay, Pune, and other places, very big places, mobile network, everything is fine. But reaching out to the hilly terrain, the remotest terrains in the Himalayas and the deserts, is something very challenging. And so India Meteorological Department recently took up with this common alert protocol system, in which so the moment we know that a particular area is going to get affected, we are able to map that area, and based on that, location-specific SMSs can be sent to that area. Of course, India Meteorological only provide the trigger, but the other agencies are involved who would be able to provide this type of the collaborative efforts. I would like to take one example here. We all remember a historic cyclone, super cyclone of 1999, Orissa. 10,000 people died. After that, 2013, similar intensity cyclone came to Orissa. Less than 45 people died. What happened from 10,000 to 45? Is it a victory of IMD? Is it a victory of India Meteorological Department? I think the answer I will humbly share with everybody's permission here. Yes, we contributed partly. We were just part of it. The technological development, the advancements made by the ministry, of course, they played a very important role. But what happened? There was an NDMA Act, National Disaster Management Act, which came in 2005, we all remember. So the process was set that when this type of disasters happen, what could be the mechanism? NFCS is probably took birth somewhere there only, I can say, where the district collector knew that if this type of disaster happened, what he has to do. And when the trigger comes from Met Department, what the actions are required. And the cyclones are such that they don't affect one state, they can affect multiple states. For example, remember the recent one, Biparjoy. It went right from the Arabian coast, went to Gujarat, Rajasthan, and then it further went up also. And so many 2-3 states, Rajasthan, Gujarat, flooded before the onset of the monsoon. So this type of capability we are having. More than 3 crores SMSs were sent during the Biparjoy in Gujarat. I think that figures are mentioned there. I cannot see that, but I can. Yeah, there are cyclones where this type of information was sent in Gujarat, Rajasthan, etc. And this is what we have the capability. And of course, the advancements in the communication system. I don't want to take much time on this. We have so many apps here, and when I'm talking about the climate information and the decision making, agriculture, food security. So climate information is increasingly critical for so many users, and most of the users, I'm really happy that all of you are here, like energy production, transport, finance, water quality, health, transport, tourism, urban development, recreation, sports, and so many. I have mentioned few, but the list is very long, and that all of these sectors, they require the climate information for sustainable development. And disseminating them, again, as I told you, that this is being planned under GFCS also and NFCS also. At NFCS, of course, the priority sectors, as I see here, if you see, the sectors are disaster management, agriculture, water, and the health. And then, we are going to the different scenarios, like crop advisories in agriculture, water, as sir mentioned about the drought indicators, rainfall, health, pollution, vector-borne diseases, India Meteorological Department gives the health advisories also, for which, some more talks will be there in the coming time. And of course, these are the functional architecture of the 5 subsystem. So any system of climate will have, the 5 subsystem that, one will be the first one will be the database that will have the metadata, means what type of information is coming from what place, data acquisition that should be in real time, and it can be in non-real time also. And then this metadata management system, that is what type of station is there, whether it is hill station, coastal station, what's the altitude, lat, long, areas, and whatnot information that's available, data management. And of course, last one is the production of the data summaries and the tables, graph, etc. So this type of system, 5 subsets, I can call it as, which are required. And when I'm talking of the components, this is a big list of the climate component that I'm talking about. So right from the data collection to the data supply. I want to make one statement here that in the Meteorological Department, IMD Pune, we developed the capability of providing online data. Any user, any academic user, or any government, semi-government, state government student who need the climate data of any station anywhere in the country, the data is online. You don't have to write anything to us. You have to just register on their website, get the data. Data is free of cost. This is what, a big policy that Ministry of Earth Science and Government of India took. And then this cost of the data, when you evaluate indirectly, it's in crores of rupees. This data is available freely to all the students, for all the academicians, researchers in the country, nation building activities, and of course, if there are any specialized projects also. And for that, you don't have to write any mail, just register yourself on the IMD Pune website and get this data. And it's like going to an ATM and drawing the money. Sometimes the data will be available within half an hour also. So that type of capability we have made. And of course, the demand supply chain is our power. We should use it at full potential. So like, for example, agriculture, food security. This is one of the SDG also, Sustainable Development Goal. Food security is there. So what they require? They require, monsoon, active and break cycle. For example, in August this year, there was a very big break in the monsoon. In the central India, monsoon was, almost not there, but it was raining in the foothills of the Himalayas. So this IMD needs to give the better forecast in early stages. And of course, the heat waves and the cold waves for the water, energy, what could be the maximum temperature or minimum temperature, disaster risk reductions, human health, vector-borne diseases experimentally. So whenever, I was discussing with POSOCO and WRLDC, Western Load Dispatch Center, they have a very big office in Pune also, and of course, all regions they have. So whenever the temperature, heat waves warnings are given, so they find that, the power consumption increases in certain areas, and then they have to arrange accordingly what could be the demand and supply ratio. And this, this is a very big market. Probably it has a lot of economic impact. If the forecast goes wrong, and if somebody generates more power, it's not getting utilized, it's a loss to that particular industry. And of course, we are very strongly available in agriculture sector. We started recently giving the block level forecast for the agriculture, almost 7,500 blocks in the country. India Meteorological Department is able to give the quantified weather forecast for the agriculture advisories. And this is something where, the ministry is also looking forward that every farmer should get this type of information. And as mentioned by our earlier speakers, that, India, is, we call it as incredible India. People speak different language. So if I speak in Hindi, or if I speak in English, or if I speak in some other language, I think I need to know that whether that state is receiving that or not. If I'm in Gujarat, probably a farmer, I should be able to speak in Gujarati, or if I'm in maybe Karnataka, I should be able to speak in Kannada to that farmer. Then probably the reception is improved. So all this type of advisories which are going to the last mile, they're converted into the local languages, and they are, without losing the content. This is a very difficult task, sometimes converting the science into the information, usable information without losing the content is something very difficult task. And yet we are trying to do that, not maybe 100% successful, but there's an effort to do that, to reach the farmer. And as I mentioned about extended range forecast, that is the 4 weeks forecast that India Meteorological Department gives. I have here Dr. Patnaik, Dr. Soni, who are here. They are probably working on this. And this year, our extended range forecast, I'm sure the monsoon report is yet to come out with its all statistics, but I understand that our forecast, extended range forecast, was really quite wonderful, and it has helped, especially in the month of September. Something came very brightly to all the farmers and to the country. And of course, India Meteorological Department, what my office is doing at Pune, yes, we do this type of, products every year, every month we do. Recently, last year, we started, writing the state climate summaries. And I'm very happy to share here that we received a lot of information, lot of collaboration, assistance, input from many states in the country. We wanted to write the state annual climate summary. Earlier, we used to do it, we used to write it on our own. So state part was not there. Now we are requesting the state governance, to give their input, and that is becoming the part of it. And lot of states like Kerala is there, Odisha is there, so many states, Punjab, Northeastern, so many states are, participating in this type of input. So there is an ownership in this document that what happened in that. This is a statement of Maharashtra 2021. 22 is also out in the month of last April. And that also has this type of information where the state is also contributing to the climate information respect to their state. And of course, the climate applications user interface that, what we do is, we work in the hydrometeorology, drought research, and of course the health energy also. So hydrometeorology, recently we came out with the rainfall atlas, updated rainfall atlas. Just last year we came, last few months back we came. It is addressing last 30 years the rainfall atlas for the entire country. This is a very important information, digital book available on our website. Anybody who is interested in this, they can download. Nothing, is IMD is now, nothing is in secret. Everything is available almost in the public domain. And this is the way, the ministry and the department is looking at it. The drought, yes, IMD doesn't do the drought, but definitely we have a lot of, inputs for application related to the drought. And the health, as I mentioned, that we are working with many agencies, many NGOs, state government for malaria, dengue, and many other vector-borne diseases, that how this type of information alerts can be given, that when could be the spike related to the dengue or malaria. There is a challenge here from the health department getting the data. So when I give the forecast that, probably the spike could happen after such and such time, or maybe next 2 weeks, we also need to know really whether it has happened. And then probably we need to know the number from the health department, that whether they registered this many dengue cases or malaria cases. If not, then something went wrong in our model prediction. So this type of closed loop feedback system would be able to help us to improve our model guidance. And definitely there are many agencies, like I remember No More Malaria NGO, which is working in Odisha at international level. We have been working with them closely. And there are many other states in Bihar also we are there. And Maharashtra also we are working with many agencies for the health this type of things. And of course, this is the forecast that we all know, understand that, every one of you waits for monsoon forecast, what IMD is going to say about monsoon 2023 or 22, etc. 23 monsoon LRF, long range forecast. As I remember that, we said it 96%. It came out to be 94 plus. It was quite difficult, under the shadows of the El Nino. And the accuracy of the El Nino forecast, as Dr. Pai, who is an expert here, definitely sometimes he can also comment upon it, that now the accuracy of the El Nino forecast has tremendously improved. It doesn't go wrong much. So we were sure that El Nino would be playing with us. But only thing we were hoping that when it goes from, whether it will become moderate or strong during the period of monsoon. And we said that probably the second half of the monsoon, we will see the shadows of this type of El Nino on our monsoon. And it happened in the month of August. September also it was there, but some other drivers were also there, monsoon, other drivers were there, which helped us, to improve our rainfall number. So that's how, so we need to understand that we just cannot depend upon abhi El Nino aaya, to now abhi kuch nahi hoga, ye saal humko kuch nahi kar sakte. So we need to develop this type of climate framework by which the farmer, the government, the stakeholders, and other agencies will be able to plan. The water management would become very important. The irrigation methodology that we are doing that. We need to improve upon our forecast also, and the decision support system has to be more in the place. These are different products that I don't want to spend time much here, that we come out with different products at the climate office in Pune. I request all of you are here in Pune, maybe if time permits, you can visit after this 2 days workshop is over, you can also visit our Pune office at Shivaji Nagar. We can definitely discuss a couple of more things here with my experts available. And of course, otherwise also, my office is always available for any open discussion with any of you. I see Abhiyan sitting there. Thank you, Abhiyan, for joining this very important event. And then, as I mentioned about, the climate data service portal and climate data service portal and climate data supply portal. It's like going to ATM and taking the data. Earlier, there is a lot of complaint. IMD के पास data मांगते हैं, IMD data नहीं है or something. It takes a lot of time. Or sometimes we used to do it manually. But nowadays, with this type of digital world, we are able to provide this type of technology and understand. And there are a lot of students. This is something very encouraging. Rather than researchers, a lot of students from the different universities are asking a lot of data from India Meteorological Department. And I'm sure whatever they do, they share it with us also, what was the result available from that. And of course, I'm quite happy to share here that, India Meteorological Department, IMD Pune office, is recognized as a Regional Climate Center, RCC, by the WMO. This is something very prestigious thing for India Meteorological Department and a country as a whole. And we not only give the forecast for India, but we also give the forecast for the South Asia also, that is the SASCOF. Just last week only we had a session of SASCOF 26, and we are able to give the entire forecast with the SASCOF. I have my friend Anshul here, who is helping us from the RIMES, and MOEC is collaborating with the RIMES, and this is how, the entire South Asian countries were able to give the seasonal forecast, not only for monsoon, but for the other countries also. And maybe a couple of 3-4 slides only. So there are 8 guiding principles that we see when we want to have the efficient climate services in India. So what we require, we require partnership. So we are here at Lavasa to build this type of partnership. So once the partnership is there, I'm sure, there will not be any duplication of the work. What work I am doing, maybe the other agency will not be able to, will not do, or I will not do it. Maybe we can avoid the duplication. And maximize the data exchange. So that is sharing what I'm talking. And climate services, a public good. I should understand that whatever climate services are there, they are meant for the public. And definitely the operational scenarios and the scenarios at global level, regional level, national level, these are the guiding principle. And maximizing the use of climate service and the priority, we must be able to understand, depending upon the state, depending upon the location, I must be able to understand that what are the priorities that the climate services are expected in Himachal Pradesh, what are expected in Rajasthan, what is expected in Karnataka or Kerala or Orissa or Tamil Nadu, etc. So this type of climate services priority identification has to be there. That will help us. So this is from to. So currently, probably we are at the from level. Of course, this diagram doesn't tell the whole story, but maybe a part of the story. So there are different sectors which IMD is interacting, like health is there, power is there, water is there, agriculture is there, disaster management is there. So we are working with it. It's not that we are not exchanging the data. We are working with each other. But how we are working, maybe we are working unilaterally or bilaterally. मैं उनको data देता, वो data देता है, something like that. And sometimes it is only I give them or they give me. It's either unilateral or bilateral. What NFCS will do? NFCS in this country will do something, a transformation, as Father Lizo also mentioned about, the transformation. So probably, we will work in a sort of, multilateral exchange of this information. And this will probably, build up a sort of more better understanding of the resources, each other's potential, each other's scientific capabilities, and that will probably will place this NFCS. This program or this particular workshop is a initiative to establish the NFCS. Please try to understand that, not to establish, but it's an initiative to establish. It's just a beginning, a humble beginning, as Secretary Sir mentioned, just a beginning. All people who are working, expert are working here, those who could not come because of maybe certain other, commitment. Maybe in the coming time, we need to sit together in a different scenarios at different places and find out how this type of the second picture, what you see, how we can work in that particular direction. Of course, for this NFCS and GFCS, how it will work, my friend Dr. Satyaban will give one small presentation. And yes, goals of NFCS, I think Dr. Rupa Kumar mentioned it. Yes, reducing the vulnerability to the society, And of course, I don't want to read all of them, but this is what, the NFCS looking at it, that, we want to have a sustainable development as far as the society and the country is concerned, and the globally. And what by? We don't have to generate a science out of it. Probably we need to come together. Science is already available, as mentioned by many of the earlier speakers. The resources are available. Ingredients are available, as mentioned by Sir. Maybe we need to formulate a mechanism by which, the timing and the ingredients come together and, we have a delicious food. I'm thankful to Crash University yesterday night. The dinner was really extremely good. I mean, it was something very nice, I should say. Yes, this is the last slide of me. While I was coming to Lavasa yesterday evening, I requested my vehicle person, can you just stop for a moment? I clicked this beautiful picture. I'm on a Twitter handle and I shared it at Lavasa. So what happens, probably is, this is my last slide. So the message is, NFCS looks a very big word, but probably I'll put it in a simple word, that let's join hands. Our hands we need to join hands for bringing up this climate framework in a really structured manner, in a very effective way, by which, we'll be able to sustain on this blue planet. Probably we need to change our glasses. We need to clean our glasses, look at each other's services, with respect, honor them, understand them. Sab kuch main karuga, aaj ki duniya mein ye chalega nahi. This formula doesn't work nowadays. I think we all understand. So a team, this is a really wonderful resource team we have, and there are a lot of expertise sitting outside this hall also. So I appeal to all of them. I'm a very small person here. If I've done any mistakes in my statements and presentation, kindly excuse me. But this is what the Ministry of Earth Science is looking at it, that we want to come together, join hands together, and build up a system. We call it as NFCS, but I think probably a framework by which, we are visible to each other in a real scientific domain action manner, and we make this country a very sustainable development. That is what, the government of India is looking at it. Thank you very much. And if there are any one or two questions, maybe if I can answer, I'll try to answer it. Thank you.
Thank you, sir, for a very detailed and informative talk on the climate services in India. Before we break for tea, I request Dr. Satyaban, co-convener of this workshop, to give an overview of the workshop agenda.
Thank you, Dr. Divya. Before we go for tea break, I would like to brief what are the things are ahead until this evening. Actually, immediately now we'll have a tea break, but initially before the tea break, we'll have a group photo in front of this Christ University building. Then there will be a session for GFCS until the lunchtime. After this lunchtime, there will be a sector-wise presentation. All these sectors we are speaking since morning. We have invited representative from each ministry, Ministry of Health, Ministry of Agriculture, Ministry of Power, different ministry we invited. There will be a sectoral talk. Then immediately after that sectorial talk, we have kept a special session for the role of state government for NFCS. So in this session, a representative from each state government official will present their view on these climate services in the country. And the last session of this today is there will be a breakout session. This is a very important session. We want to, as per our understanding, we have distributed participants to 5 breakout sessions as designed by the GFCS, but we'll share the papers during that lunchtime. Then followed by cultural program 6 to 7, and the dinner will be also provided, arranged here from starting from 7 p.m. During this throughout the day's workshop, our committee members also writing the proceeding and what is the plans and what is the presentation, what is the discussion. And by the end of today, we are planning to set the draft outcome statement of this workshop, which will be shared with all the participants by evening, and with the approval of our Secretary Sir and DGM Sir. Then that is the draft outcome statement. It will contain what is the background for this workshop, what is the deliberation happened during this workshop, and finally we'll plan what next, because it is not the end of this workshop. What is lies ahead during the next few years to happen? So that will be planned. So we are going to share this draft as a hard copy. We'll be waiting for your approval and after the final discussion, we'll have a debate on that one. Thank you very much. Thank you.
Excuse me to all of you. We are having few announcements before the tea break. So before the tea, we are having one group photograph at the main entrance of this university. The students will be will outside to show you the route for that. And secondly, the speakers for first session who still have not uploaded their presentation in this laptop are kindly requested to upload the same. And also Wi-Fi is there for mainly specifically for this workshop. The name is IMD workshop and the password is IMD in all in capitals @Lavasa, LAVASA. So you can use this Wi-Fi during the workshop session. And tea break will be for 20 minutes. So we will be here again around 11:30 or 11:35. Thank you so much. A very warm welcome once again to all of you. So before the tea break, the password which I have told verbally, you can see here the Wi-Fi name for all the participants, and you can note down the password. So, our first session of this workshop is Global and National Frameworks for Climate Services. So, to chair this session, I would like to invite a retired scientist, Indian Institute of Tropical Meteorology, Dr. A.K. Sahai. And to co-chair this session, I would like to invite Scientist G, National Center for Medium Range Weather Forecasting, Dr. Sajid Mohandas. For all the details for the presentation and to conduct the session successfully, over to you, sir.
Thank you. There are 4 talks in this, and since we are starting slightly late, so time given is 25 minutes, but we are reducing it to 20 minutes. So in 20 minutes, question and presentations both will be there. So try to finish in 18 or 17 minutes and 3 minutes for questions. The first talk will be given by Dr. Rupa Kumar. Already you have seen him, so I invite Dr. Rupa Kumar to give the first talk. Thank you, sir.
Good morning once again. Thank you, Dr. Sahai. I will try to be as quick as possible. In fact, we had an excellent overview, very comprehensive of the climate services in India that Dr. Hosalikar has described. In fact, in my presentation, I will not be getting into too much of the Indian scenario, because that is what actually we are supposed to actually work out during this workshop. So instead, what I intend to do is to actually take you through the landscape that we have to navigate to actually to be able to establish the national framework. So in that, I'll be largely using my experience in WMO as we actually formulated the various aspects related to the global framework for climate services. In fact, many of the concepts and the approaches are very similar, even if you are looking at a national level implementation of the framework. So, in fact, if you recall the earlier presentations, we already know that the global framework is actually based on 5 what we call foundational pillars. In fact, we have seen, you might have seen this in the agenda as well. Out of this, I think we have a slight distinction in the way we deal with these pillars. Some of these foundational pillars are essentially to support the provision or the production and provision of the information that is required. And we have, of course, the sectors who are already very well experienced in dealing with the various climate risks. But what is typically missing in our domain is that the interface between the two is not very strong. So I think that is where we need to make larger effort. In fact, this is also recognized in the global framework. The one of the pillars that is typically known as user interface platform. That is where I think much of the effort is needed. to make sure that the best of science is actually feeding into the climate-related decision-making in the sectoral level. I think that's where I think we need to spend more effort and more attention also to help us build a stronger bridge so that the information flows effortlessly. So the typical interactions that the global framework needs at the national level, of course, the National Met Service, Meteorological and Hydrological Service, that is typically the IMD in the WMO structure. And we also have a variety of national agencies representing the sectors. And we have national and local government bodies which also deal with many policy-related issues dealing with climate matters. And we also need suitable platforms for multidisciplinary interactions and collaborations. Because we have to recognize this, that climate is not, we cannot individually deal with each sector. Because any climate-related decision, for example, taken in water sector, has implications for the agriculture sector or health sector. So that is why you need a real multidisciplinary system to actually consider applying climate information in the best possible way. And for this, we typically propose, as part of the global framework, organizing national or even subnational climate forums that can help us to bring all the sectors together to understand and take decisions that are consistent within their communities. And of course, universities and research institutes that actually do a lot of research and improve or innovate the information that can be used for decision making. And we have a lot of NGOs that are also supporting many climate-related risks. And public-private partnerships is again an important part. So these are all typical interactions that are required, and particularly they have a major highlight at the national level. So we'll go through the foundational pillars one by one and then see how we can actually address the national level issues. So user interface platform, as I said earlier, is the most important one, where it connects the climate information from the production to the user, and where it's very important to have systems to get the feedback, because it's not a one-way traffic. It's IMD is giving products, but whether the users are able to use them in the best possible way, or whether they find any gaps, whether they're able to understand. So feedback is very important. So that should be a key aspect of the user interface platform. And of course, dialogue, I already mentioned that we need a multidisciplinary dialogue that should be sustainable. It's not a one-off, a one workshop that can solve everything. It should be a regular, periodic platform that can actually sustain the dialogue, so that you can actually understand and meet the evolving needs. And of course, evaluation is very important, which actually monitors the various services that are being made available, and you evaluate them and see whether they are able to achieve the desired socioeconomic benefit. And outreach, where you also have to improve the literacy of the targeted communities to deal with the information that is being provided, not only in terms of the technical aspect, but also in terms of how decisions can be taken based on that information. And one of the most important pillars of the GFCS is what we call Climate Services Information System. This is actually the core. This is taking the analogy that Dr. Ravichandran has mentioned earlier. This is the kitchen. So this is the kitchen where all the ingredients are put together and the dish is prepared. So that is where you actually have a number of aspects related to the development of the Climate Service Information System. And I have the kind of benefit of co-leading a WMO expert team we call it CSIS. We have a CSIS operations expert team. So I happen to co-lead, and there are a number of issues that we actually take into account to build a fully functional and comprehensive climate services information system that actually produces all the information that is required. So this ranges from infrastructure to the capacities, the standards, protocols, the data exchange, and mandates, because each institution should have a mandate to produce information in an authentic way. And also the NMHS, the Meteorological and Hydrological Service. Of course, in India, we don't have a unified meteorological and hydrological service, but in a WMO kind of terminology, we have a single entity, that is NMHS, which should closely work together. That plays a role as the main CSIS entity at the national level. So that is where you have to make sure that the CSIS, and the CSIS is actually not about just giving forecast. It deals with the entire range of climate information, right from past historical information, which actually help us to understand the climate variability, to current monitoring, to prediction of the next season or even next years, and up to climate change. So the entire range of climate information is part of CSIS responsibility. So in that sense, the Met Service may not be uniquely a source of CSIS. So the Met Service has to partner with additional agencies to be able to fully deliver what is required from the CSIS. And the CSIS actually has another dimension to it. This schematic is a bit busy, so you don't have to get into the details. But the information that is even for generating information at the local level, we have to recognize that it is a result of cascading from global to regional to national. So this is where the cascading structure is an integral part of CSIS implementation. We have to make sure that each player within this global, regional, national collective are able to act in the best possible way to provide national level information. So that is where WMO is actively promoting a regional approach. That is where even a country which has full capacity to act independently, it is desirable for them to work with other countries in the region who also share similar climate drivers. For example, if you take South Asia, while we are interested in the monsoon, we are also interested in how monsoon is behaving in the neighboring countries, so that we have the ability to take into account the regional inputs that also affect our monsoon. So that is where the regional approach is very important in CSIS implementation, which we are actively promoting. And CSIS is actually, it needs to be supported by two pillars, which are already very well established because of the weather services. And these are the observations and monitoring, where all the observations where we need to increase the capacities for observations and provide all the required inputs for the CSIS operations. In addition to that, I think one area that definitely needs high attention in the NFCS implementation is the observation. Observations is not just about climate. We also need observations about the sectors. So unless we have equally high quality observations in the sectors on the impacts, we will not be able to actually analyze the climatic impacts on the sectors. So that is where we have to address the shortcomings with respect to standardization and generating observations in a variety of sectoral aspects, biological, ecological, and environmental and socioeconomic aspects, including health. So that is very important. So I think this is another area that NFCS will have to focus on while going ahead. And we also need a good data policy. I just give you an example of WMO Unified Data Policy, which actually combines the entire weather and climate and hydrological collective to have a unified data policy. So NFCS also should try to work towards a unified data policy where you have the required access to all the data that is required for developing climate services. And of course, the research, modeling, and prediction, that is one of the fundamental requirements. And we have, luckily, a number of research institutions that actually help us. But while we have excellent climate research and also excellent sectoral research, what is to be actually focused more is on the applied research, where we need more attention to actually to quantify. It's not anecdotal information. We need to quantify information on the impacts, which will also feed into the impact-based forecast that Hosalikar mentioned earlier. And finally, the capacity development pillar. So that is important. Dr. Ravichandran has mentioned this earlier. And capacity is actually in the climate services context, we have 4 types of capacity that we need to address. One is, of course, human resources, the infrastructural, which is actually the computers, buildings, etc., and the procedural capacity, where you get into the guidelines, best practices, etc., and institutional capacity, where you define the mandates. I give an example. Institutional capacities are very important. Many times we see that the information is available, but nobody is looking at it to take the decision. This happened in France a decade back, or 2 decades back, where the Met Service has given a very good heat wave forecast, but the health service was not looking at it. 2003, which it was realized later, and it led to a number of deaths because of the heat wave. So now France has made it mandatory for the health service to document what they are doing with the forecast. So this is very important. So that institutional capacity is important, and they should address both demand and supply side, and they should be service oriented and respond to user needs, and also balance with the science capabilities that are existing at any given point of time. So in general, GFCS considers the NMHS, that the Met Service, as the main underpinning entity at the national level, mainly because they already provide a large number of climate services, as Dr. Hosalikar mentioned earlier, and they are mandated by the WMO Convention, and are anyway structured and trained to provide 24/7 services, and they already are used to adopt standard practices. And another thing that we have to keep in mind is that users actually don't distinguish between weather and climate. When you go to a user, they actually ask the question ranging from tomorrow's weather up to what will happen after 10 years or 20 years. So they don't care how it is being developed, who is developing or what. So we should not complicate their lives by sending them to different windows for different types of information. So it's very important to have a single window through which the entire information can be provided. This is another thing NFCS can address to be more effective. And of course, the Met Service typically has a large pool of expertise, and also they have a lot of partners that can actually help in generating the services. So I will skip this. This we already have seen. And in capacity development, typically the way WMO does is that we classify the existing capacity of different Met Services to a category 1, 2, 3, 4, from basic to advanced climate services. And the idea is once you classify a Met Service in a capacity grade, the effort should be to take them to the next level. You can't take basic to advanced directly. So you first go from basic to essential, and essential to full, etc. And luckily, in India, we already have advanced climate services, and we have to see what capacities are required to take us further in the advanced climate services. I think here, one important aspect that Dr. Ravichandran has mentioned earlier is that we should strive to provide support to Global South. So I think that is where the regional and global aspects that should be part of our activities. We should be able to develop capacity so that we can actually help other countries that are in need. So this is where you have a number of regional and global level activities that you have to get into at the national level also. I think I will quickly go through some of the challenges that we have. Human resources, new competencies will be required, and training materials will be required, and also recruitment and retention. You should always have redundancy in terms of training and recruiting people, because many times you train somebody and then this person moves on to something else, you are quickly losing and you are starting from the scratch again. So this is where human resources is very important to have redundancy. Procedural capacities, guides, manuals, etc., that should be made available. And WMO is actively promoting what we call Climate Services Toolkit, which actually is a collection of all the available tools for generating climate services. And we can actually customize that broad WMO toolkit into what is required at the national level for India. So this toolkit actually is a combination of push and pull, where you push the technologies that where we can actually raise awareness about the capacities of science that we can actually generate and provide products. And at the same time, we should also pull, that is to understand user needs and trying to provide those, supply those needs, ranging across all the core functions, that is data, monitoring, forecast, and also projections. And of course, institutional capacities, I have already mentioned this. And in terms of the NFCS, what we need to do is that we should be looking at it as a mechanism for coordinating, facilitating, and strengthening collaboration. And why it is done is to actually to co-produce. It's not just one-way provision of information. We have to actually work with the sectors and the users to make sure that we generate information that is relevant to their decision context. And of course, the stakeholders essentially are the Met Service and the various sectoral agencies that are part of the climate services platform. And while going towards NFCS, actually, what is important is to generate provision for dialogues, and also it is assumed that NMHS, that is IMD, should be given a primary coordinating role in developing this NFCS. And we also should have a structured approach, that is, you start with a baseline assessment, and then incrementally we improve towards the full-scale NFCS. And the potential benefits, of course, are the increased collaboration, increased information sharing among participants, and elevation of the importance of the climate service and adaptation, and better identification of the climate and weather information on their service needs, and planning, and also these are various benefits that are likely to emerge out of the implementation of the NFCS. And the governance, I think this was also mentioned earlier, we need definitely high-level support to make sure that all the relevant players are able to sustain that collaboration. It's not just one meeting, it's actually a continuing process. And this is where I think the governance becomes very important. In many countries, this is actually, the governance is handled at a very high level, like I mentioned earlier. And the way forward essentially is to focus more directly on the national CSIS implementation, and also bringing national climate forums as an enabling mechanism for NFCS. So this can help us to actually enable partnerships. The national climate forums also contain lots of sectoral stakeholders. And we also want state-level climate forums where we can actually look at the state-level climate problems, and also using the local language for communication that can really help, and enhancing global and regional inputs, because even local needs, local climate information cannot be generated without global and regional inputs. That's where I think IMD already has a lot of strength. I think that can be further mobilized. And we also need climate services user forums where actually you can bring various sectors in a more targeted manner to look at specific sectoral problems and help in co-design and co-production. And we also need to actually take the benefit of a lot of regional institutions that are actually operating in this space, like RIMES or ECMOD in Nepal. So they are already working on regional aspects. I think we should actually try to work with them so that we can actually make best use of the regional capabilities that are existing. In any case, I think there are a lot of investments going on, including the International Development Agent support. I think we need to find ways to consolidate, and there is actually a South Asian Hydromet Forum that is already being coordinated by RIMES. So things like mechanisms like that can help us in actually consolidating all the regional investments in the best way possible to help us with the NFCS. And in conclusion, I think what is very important is to focus on providing improved access to climate information, past, present, and future aspects, and multidisciplinary and international collaboration that are important, mainly in exchanging information, And NFCS can be a kind of major step forward to systematically provide that particular aspect. And we, of course, need to focus more on national level capacities in all dimensions of climate services. So that is the kind of landscape that I wanted to provide, and I hope it is helpful. Thank you.
Thank you, sir. Nicely presenting what should be done, how it should be done, what are the challenges and way forwards. So if there is any question, okay. Please.
Sorry, this was little cumbersome, so took me some time. Dr. Kolli, thank you so much for the presentation. It is really nice to understand more about the climate services which is being developed at the global level. And sir, I think you were kind of ahead on when you said that the cooperation, collaboration, and I think capacity building is one of the aspects. Sir, I would like to understand, like, one is from the physical science part of it, where we are trying to improve the information sharing. The other is the, let's say, the response side of it. So, for example, a lot of the anthropogenic activities, and now it is well established, has been influencing the climate. What our experience of working in the States is that many times different departments, the policies they are implementing actually influence other sector adversely. For example, adoption of solar irrigation pump might be good from the carbon, reducing the carbon emission, but it may lead to more water development or more water use. So, sir, in that aspect, we see that there is already a lack when it comes to different departments talking to each other because their mandates are very different. So, in your experience and your kind of experience of working at the global scale, are there any best practices of these different institutions coming together, helping out each other, and then designing their policies for implementation? So it will be great to know, sir, from you. And I'm Nitin Basi. I lead the water program at Council on Energy, Environment and Water. Thank you so much.
Thank you for that question. In fact, this is where I strongly recommend mainstreaming organization of national climate forums. And in fact, these national climate forums is not just on an all India scale. The national climate forums can be done on subnational scale as well. It can be done even for a city. For example, New York City has its own panel of climate change. Like IPCC, they have a New York panel on climate change, where the mayor is an important part of that panel. So like that, I think we need to have multidisciplinary platforms fully authorized to consider and take decisions. They are not just kind of academic discussions. They should be actually linked to the policy that the government is actually handling. I think that is where the sustained climate forums at different spatial scales will be very, very helpful on a multidisciplinary side, because that's where I think the point that you made, that one sector, one agency may be taking a decision which can be creating problems for the other sector. I think that's a very valid point, and we need to minimize that type of incident. Yeah.
Thank you, Dr. Kumar. Now, due to lack of, okay.
Sir, solely to point out, I think space-based observations are a key component of this NFCS because this observation, when it comes to observation pillar, space-based as well as ground-based observations, we need to combine together. And here, throughout the presentation, that space-based involvement, that was very less. It was pointed out. And also in the way forward also, that how to incorporate all this thing and how we have to increase our space-based observation, that also should be taken care of. So, myself, J.V. Thomas from ISRO headquarters.
Yeah, I could not go into such detail. I think that's an excellent point. It's actually not just space-based. When we talk of observations, we typically think of only IMD, because IMD has a systematic network of observations running maybe more than 150 years. But we also know that observations are nowadays being taken by so many agencies, even ground level measurements. CWC has its own rain gauges. State governments have their own automatic weather stations. So I think all players who are actually involved in observations and generating observed data, they should collaborate and generate a unified data set that represents observed climate. I think that can be facilitated by the national framework. So in the observations and monitoring points, there is one aspect where you actually promote partnerships from all the agencies. And this is about climate. Space-based observations can also help us on the sectoral observations like vegetation index, etc. So those are the things that land surface conditions, those are the various things that can actually help us to get a better idea of the impact side also. I think it's very important to have that kind of arrangement through the NFCS.
Okay. Thank you, sir. No, we are late. No, discuss with space weather observation based on one workshop which we are in.
Maybe at that time we will definitely, it is meant for the people who are working in that scenario. So ISRO also will be invited. It's already in the pipeline. Maybe by December or something, we will come out with the declaration.
Actually, nowadays there is a blended approach also. You have blending of space-based and also conventional measurements and also reanalysis products. So these are, you can actually generate that type of products which are kind of very advanced and can provide a lot of information.
Thank you, sir.
Thank you.
So now, based on this question, space-based and this, I am inviting Dr. Rajashree Bothale. She is Deputy Director, Earth and Climate Sciences, National Remote Sensing Center, ISRO, Hyderabad. So she will give a talk, and maybe your questions will be answered in this. Thank you.
Good afternoon, everyone. First of all, sorry for my sore throat and little bad health, but I am sure I will be able to do the justification to my presentation. And thank you very much for setting up the pace and introducing the one major topic, that is the space-based remote sensing. I'm from National Remote Sensing Center, and a little bit I'll be talking about what we are doing using the space-based observations and also for the climate services. And I'll be talking about one of the major program. We all know that when we want to study the climate change, because now when we are talking about the services, first we should know about the different, what are the driving force to study the climate change. Sometimes society, because climate has got effect on the population due to flash floods, cyclones, droughts, and science is behind that, because we have to understand, track, and predict the climate change. And economy also largely it affects the study of the climate change, because the livelihood of the people is affected. Energy and transportation sectors are badly affected because of the climate change. So we have a lot of extreme events. We all are aware of that. Heat waves are there, rainfalls are there, cold spells, greenhouse gases, which are causing a lot of rise in temperature, disasters. We all know about day before yesterday disaster which has taken place in Sikkim by the Govt, that is the glacial lake outburst flood, which has caused the lives. Cyclones, floods, landslide, and over the years we have taken a lot of measures so that the human life is not lost in most of the events, but the damage to property is taking place. Cryosphere is getting affected, sea level rise is there, and melting of glaciers are taking place. And we are all talking about the reducing emissions, carbon neutrality by 2070, and sustainable development goal, where we are talking about the change in temperature and how it is going to affect the things. So what is the need of the hour and the future? Need of the hour is that we need long-term observations, whether they are ground-based or whether they are satellite-based observations, to study, understand, and to predict the different parameters which are affected, which are there, which affect the climate change, and ultimately leading to the climate services. We require climate data records. We require global observations because not only for India, for entire globe observations are very much necessary. We require network of ground-based observations for modeling and validation. And I know IMD has got a series of such networks, and we also have certain ground-based observations. And entire country, different departments have got lot of observation networks, and need is there to combine all together at one platform. We require, we want to go ahead with the mobile-based sensors where the information is available on your high-tech mobiles, and you are providing the source of the crowdsourcing for generating local specific models, and the multi-institutional collaboration, which is very much necessary. So when we talk about from the satellite point of view, we require constellation of satellites. We require polar orbiting satellites, geostationary satellites, microwave satellites. And improved role of geostationary satellite is felt by everyone because they provide the constant information to us. They are constantly seeing us and they provide the information. The need is to have the hotspot identification, that is through the onboard processing capability, so that directly we can identify which are the vulnerable areas on a particular day, whether it is for emission or for any other thing, and then the immediate measures can be taken up and the public can be made aware. Short-term and long-term prediction of the climate parameters, modeling with the improved accuracy, and fast processing algorithms are needed for that. So we need the integration of all the observation platform. And this is the EO census of India within 2047, which recently we have dwelled on during the Chintan Shiva. So we need the integration of Earth observation satellites from geostationary platform, LEO and sun-synchronous platform, and then even many nowadays we are calling the POEM, that is the fourth stage orbital experimental modules, which are going in the fourth stage of the PSLV. We need airborne information and also the network of ground-based information, because that is the crux or that lies everywhere in the center. And when we talk about the, we require high resolution spatial data, we require lower swath data, geostationary data, sun-synchronous data, and a constellation of the data set is needed to study the entire climate. So what actually is needed? We require for climate research and services. We have lot of input data. We have to do the processing and generate output. It could be in the field of atmosphere, ocean, terrestrial, or cryosphere. And not a pre-processing is required because the data which is obtained, it is in the nowadays when we are talking about the high resolution data, it is coming, large number of data is there. It is getting downloaded by the satellites. We have to do the resampling, we have to do the interpolation, and then we have to find out the long-term trends out of that, slope estimations, Mankanda. I mean to say a lot of processing has to be done to understand what that data actually contains. And then what could be the output? Output could be we can generate pixel-wise output maps can be generated, spatial relationship could be generated, temporal variations can be found out from one time to another, and anomaly map can be generated when you have the CDR data available for a particular field. So geospatial technology plays a very important role in that because we have all the data set which is available, and these data sets can be analyzed for water and fuel security to address climate risk through the different national and international collaboration. I'll be just mentioning about, many of you are aware about a program of ISRO that is called National Information System for Climate and Environment Studies. In short, it is known as NICES. It's a national level long-term aimed towards the generation of national level long-term geobiophysical products data pertaining to terrestrial, ocean, and atmosphere, and naturally the cryosphere, which becomes part of terrestrial. It is a multi-institutional endeavor with so many partner agencies working with us. And one of the objective is generation of observation network, calibration and validation sites, dissemination of the data through the NICES portal, and generation of essential climate variables when the CDR is available and they satisfy the given criteria for impact assessment, vulnerability, adaptation, and mitigation. It has got satellite observations, model-based observation, ground-based observation. They are put into the portal. Modeling is done. Infrastructure is developed. So these are some of the infrastructure which we have developed over a period of the time. The project was initiated in 2012. We have completed 10 years, and now we are into the next decadal plan is approved by the department. We had a PMC. PMC told us to go for the 10 years plan. Now we have gone for the 10 years plan, and it is already approved by ISRO headquarters. So we are talking about the essential climate variables because whatever we require, whether we want services, whether we want to serve the society, we have to have the long-term database available for further analysis. So if you see the global climate observation system where you have the 54 ECVs or product-wise 135 products are there, out of it 35 are discernible through remote sensing. Presently, we are having 10 to 12 products which we are calling as an essential climate variables which are available. And there are so many products, around 60, 70 products in terrestrial, ocean and atmosphere, which are under different stages of development or the different years of data set is available. So for some it is 5 years, for some it is 10, for some it is 20, 25 years. And slowly we will be, once the long-term data processing is over, they will be converted into essential climate variables. We have a lot of data downloads by different users, and as you can see here, 3 types of user can be seen here, that is academia, government and others, with academia making the maximum use of the data. And if you see the data set like atmosphere, ocean or terrestrial, so ocean has got the maximum download and also the terrestrial, and followed by atmosphere. So what actually is needed? We have a satellite mission. We have to convert, we have to find out the parameters. We have to use the different models for the decision support. So satellite observations are there as per the user need. You apply the science and application, because when we are talking about the climate services, many products are science dominated products. And then we take the ground and aircraft or the ship-based data for processing and validation. After validation, the data is available for outcome is available for the dissemination for different services, like for example, NICES or the socio-economical development or economical development. So some of the like satellite data, and correspondingly, if you see here, you have the flux, like the ground-based observation also. So like met parameters are obtained from INSET 3D, SOMI NPP, then we have the flux towers to support that. Similarly, for the cloud, if we do through INSET, then we have the sky imager to validate it. Similarly, for any other parameter, whatever we take from the satellite, there are the ground-based observation to validate the product and generate the final output. These are, I know a vast instruments were shown by the previous speaker, IMD speaker, but we also have a lot of instrument. We have a climate research laboratory for atmosphere at Shadnagar campus, which is 70 kilometers away from Hyderabad, and like sky radiometer, micrometer, tower, flowmeter, and also we have this spectrometer, portable FTIR spectrometer, and also FTIR to understand the various parameters related to atmosphere. Network of UV sensors are there, VHR is there. And a lot of ocean instruments are there, which are either the lab and the field instruments, which we use when we take them to the ocean, and instruments in the network, like for example, lightning detector, UV sensors, radio sound sensors, etc. So now, after having the data for so many years, we are also shifting to climate services. Already so many services are there, but more focus is there to generate more climate services. And since a lot of CDRs are there, ECVs are there with the modeling. So for example, hot weather outlook, forest fire, high resolution soil moisture which is needed, flood prediction, vegetation, crop based, land cover changes, some of them land. Similarly, in ocean, we have sea level rise, fisheries, or SST, cyclones, and then atmosphere, air quality services, emission hotspots, solar radiation, wind energy pollution, and so on. So basically is that we should be able to make the decision for the climate sensitive societal areas, and we combine all the data set together for generation of different services. So few examples I will show here, like I know some overlap will be there, that this is being done by IMD or this is being done by CWC. So that let us come out of that. But what we are doing, I will just try to tell. So we are also giving the heat stress hot weather outlook. One is the temperature-based heat index, and second is the moisture and temperature-based heat index. And this product is available from 2016 onwards on NICE's portal. So last year, more than many hits were there from more than 11,500 users till October 2023, and the detailed information, whether it is a danger area or the normal area or what kind of area is there, that information can be seen. Another thing which we do is the atmospheric lighting. Why I'm telling direct effect on the society, sometimes back we have given one talk to the health sector. So which are the services which have, or which are the parameters which affect directly the society, and some may have the indirect impact. So lightning has got direct impact on the society. We know that if it is stuck, it causes death. And the survivors, they have lot of injuries, burns, cardiac arrests, etc. So NRSC has established 46 networks all over the country, and they are almost 300 kilometers apart, covering entire India. And we are getting daily data out of that, which is available on our Bhuvan portal. And various host institutes and other organizations, we are having collaboration with them. And regularly we are attending the workshops for that. Then another is the atmosphere. 14 minutes. So atmospheric rivers, indirect impact is there. So a lot of work is going on, and product in the developing stage, where we can give the fog intensification during winter using the satellite-based observations. Similarly, air pollution potential, ventilator corridors, studies have been done. Some are not yet matured to the climate services, because these are the things which are already available with us, which we are doing. Trace gas concentration, study of them over, like it is given over Delhi. And fire also, forest fire alert service. You know that the real near-time forest fire alert services are being given from our Bhuvan platform. Every half an hour information is available using the satellite data. Similarly, this is one of the case studies. Surface soil moisture, we know that they have the indirect impact, not direct impact, because they affect the food security and human health and ecosystem function. We generate from long-term data from 2002 onwards is available on soil moisture using the satellite data. For oil spill also, a lot of work is going on using the microwave remote sensing data, and we find out which are the vulnerable areas or which are the areas where the oil spill has taken place and oil spill alert is given. So in nutshell, for the outreach, which was one of the points mentioned by the previous speaker, we have come out with the NICES newsletter from October 22 onwards. It is available at nices@nrsc.gov.in. Please write to us if you want to have the past copies, past issues, or the future issues of the NICES newsletter with us. So thank you very much. This was in nutshell about what work we are doing. It is not totally exhaustive. Some of the things I tried to put what we are doing, but there are many more things which might not have been included in this talk. Thank you very much. NICES has a linkage with Ministry of Environment and Forest, Department of Science and Technology, Ministry of Earth Sciences, CSIR, and various IITs and other universities. Thank you very much.
So if there are one or two questions.
When we discuss climate change, especially the observed data, what is more important is the homogeneity of the time series. Many times, the skeptics of climate change people say that you tend to use stations from urban cities, and this urbanization is introducing some kind of bias in the time series. So that's why the concept of global observing system, in which they put the observing system in a remote place, so that this kind of urbanization is not getting into. So sadly, when you use the satellite data, there's a lot of issues coming out, because you use different platform, different sensors, different time periods. So you need to really make it a kind of homogenization. My question is, are you attempting that? If it's not doing it, it's a big mistake which we will be making.
No, that is very correct. So that's why I said that we have presently 70 geophysical products, but very few right now we can call them as essential climate variables, because we have to see what you mentioned, that there should be long-term data should be there, and they should be uniform. Because for example, wind, ocean wind, we are taking from different scatometers. So all the scatometer data, now reprocessing work is going on, so that entire data becomes seamless and it becomes a climate quality. So that is why I mentioned very clearly that we are still in a process of developing long-term data and converting them to the CDR and then essential climate variables, because GCOS has given certain standards and we have to adhere to those standards.
Any other question? Yeah.
Thank you very much for that lecture. And maybe it's a small remark that I would like to make here. You see, there could be a distinction between the research services and the climate services applications. So when we talk of NFCS, into the core area, if we put in a lot of connectivity with research data, that would become bulky and maybe unmanageable in terms of looking up catalog. Because as a user, I may like to look up what products you are having. And atmospheric composition data and other things, they would possibly not be useful directly. So it's just a suggestion for the NFCS that the research aspects of it can be linked and connected and not be a core area of the climate services. So if that be so, then we need to segregate all kinds of data into research data as well as applications data.
I agree, sir. All the research data, we are generating the products, and from products we are making the services. So services are the next step. First step is that long-term data. Once the data is there, then you go to the services. Like for example, fog intensification, I told. You need not know what is going in the behind, or the soil moisture product. You need not know how it is coming. But we are at that stage when we are generating the lot of data and then migrating to the services sector. Like for example, lightning, I told you. So we are into the prediction also. That are we able to do some prediction work? So recently we have published one paper on that. So it is a migration basically. Behind you need not know what is happening. For user, it will be services.
Thank you, Dr. Rajashree, for
Thank
very
you, sir.
nice, informative talk. So the next talk will be from WMO, and he is successor of Dr. Rupa Kumar Kolli.
Yeah, it is my great pleasure to introduce Dr. Chris Hewitt from WMO Secretariat. Chris is currently the Director of Climate Services branch in WMO. In fact, I have known Chris for many years. In fact, he has been very closely involved in the development of the GFCS implementation plan. Even before joining WMO Secretariat, he used to support our activities, particularly in the user interface for climate services. And in fact, I think there is Chris has a lot of experience in climate services in the UK Met Office. And in fact, on the NFCS also, he has vast experience in supporting the development of NFCS in China. I think his contribution and his support will be crucial for us to actually succeed with NFCS. And not only giving presentation, he has actually promised us to give all support as we go forward on the NFCS. With this, I hand over to Chris for his presentation.
Thank you very much, Kumar. I'm having some technical problems. I cannot hear the audio, so Can you hear me? Can anybody hear me?
Yeah, we can hear you.
Can you hear me? Can anybody hear me?
Yeah, we, yeah, 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 yeah.
Okay, I will carry on. I'm very sorry. So I have to mute my screen, so I cannot hear you. I have a message in the text telling me you can hear me. So maybe in the text from your technical colleague, if they can tell me if there are any interruptions or problems, and I will start my presentation. And I'm not sure how we will do questions, so I'm very sorry. Let me start the presentation and hopefully you can see it. So thank you, Kumar. I am the Director of the Climate Services branch of the WMO, and I am even more sorry now that I cannot be there with you at this workshop. I've been working, as Kumar said, in the climate service field for a long time. Before I joined the WMO, I was involved at the UK Met Office and with various groups around the world, including on working and developing and supporting national frameworks for climate services. So I'm absolutely delighted that you are embarking on your national framework for climate services in India. And I've been asked to give a bit of a background on the global framework for climate services. So this is what I will cover, the global framework for climate services, and then to link it to the national level, and in particular the workshop you're having there, a bit of a discussion about the climate service value chain, and in particular the importance and challenges of user engagement. And then move on to the important topic of regional coordination and national coordination, which will be a focus on the national framework, and hopefully some time for some concluding remarks. So climate services, I'm sorry I missed the earlier talks, but just to check we're all on the same page. So I've been giving talks about climate services for a long time, and there are some different views and opinions and confusions about climate services. I'm not trying to provide a definition here, people have different definitions, but just a scope. So in terms of the broad scope, climate services are broadly the provision and use of climate information to assist decision making in a very broad sense, decision making, policy making, and all of those things. This has been done all around the world, has been for a very long time. Climate information is being used in decision making and to help manage risks. And there are some nuances and some subtleties that are very important. So these services, they must respond as much as possible to the needs of the users. And at the end, I'll talk about some challenges there. There are obviously challenges in doing that, but the services should be aiming to respond to user needs. And there's a broad range of users for these services, policymakers, decision makers, governments at the national scale or at the sub-national scale, perhaps at the local scale, public sector, the private sector, the general public. There are many, many people and organizations who use these services and will benefit from using them. They need to be based on scientifically credible information and expertise. I managed to listen in on the previous talk, and that came across very clear on the previous talk. So the scientific underpinning capabilities is essential for these services. And there needs to be appropriate engagement between the users of the services and the providers of the services. And I'll talk about that more in a minute. In terms of timescale, there are many different timescales of interest on the climate timescale. And I'm trying to separate this from the weather timescale here, but I note at the bottom there is often an overlap with weather services as well. But in terms of climate services, we're talking about timescales of months, years, decades, those sort of timescales. So not really the day-to-day weather over the next few days, but I do recognise there's often a link with weather services. So in terms of climate timescales, I've split this into three broad categories. The first one, the past and current climate, and this is probably the most important element of climate services in my view. So the services are typically based on climate observations and climate monitoring. We also have climatologies, we have reanalysis tools, so model-produced data sets to show the past and current climate. And this is essential to help people understand their vulnerability to the past and current climates, and also then as a baseline for planning for the future. So in terms of the future, I split that into two categories here. You can split this multiple ways, but just to illustrate the near-term future climates and the longer-term. And so the reason I split this is because the services are typically based on climate model outputs for the future timescales. And so for the near-term future climate, we have monthly to seasonal to multi-annual climate predictions. So we have a lot of capability, as you're very aware in India, on these timescales, monthly, seasonal, multi-annual. And there's a range of interests. So the figure on the right is supposed to show some illustrative applications on these timescales. So if you look at the monthly, seasonal, and annual timescale, aid agencies, market traders, there's lots of trading done on these timescales, people planning for maintenance of infrastructure, insurance and reinsurance sector are very interested in these timescales to help prepare for hazards and to price accordingly. People planning resources around energy, water, food, and then people starting to think about adaptation to climate change as well. There's an interesting link on these timescales to climate change adaptation. So on that note, the third timescale is the longer term future climate, and here the climate services are typically based on information from multi-decadal climate projections, such as underpin the IPCC process, the Intergovernmental Panel on Climate Change, with its coupled model intercomparison project, CMIP, Cordex for doing regional information. So here there are huge interests obviously on climate adaptation, people understanding mitigation policies, planning large infrastructure projects. So there's a growing interest across all of these timescales, and some of the applications span across these timescales. And as I said, some interest actually spans across the weather timescales as well. So it depends on each decision-maker and policymaker and context, but there's a broad range of timescales of interest for climate services. So the global framework for climate services. So I had the honor of being involved in this right from the beginning. Back in 2009, World Climate Conference 3 was held in Geneva, and World Climate Conferences are big events, very influential, led to some major global activities, linked very closely to things like the IPCC, GCOS, a range of the World Climate Research Programme, a range of big activities. And the most recent one in 2009 called for a global framework for climate services, recognising that the need, the capability for climate information to be developed, provided and used for society. So a global framework was established in 2012 with a vision to enable society to manage better risks and opportunities arising from climate variability and climate change. There were several key priority areas identified, listed on the left there: agriculture and food security, water resource management, health and disaster risk reduction. And then a few years later, energy was added as well, recognising the importance of climate services for the energy sector, particularly renewable energy, both in terms of mitigation and adaptation. And then the figure on the right shows how this framework is structured. So there's some very important building blocks to this framework. So we can start anywhere, but if we start to the bottom left, we have climate observations and climate monitoring, one of the underpinning parts of the capability of the services. Huge amount of climate research, climate modelling and climate predictions, another essential underpinning capability. This produces a lot of information, so there's a layer called the Climate Services Information System, which your colleague in the room, Kumar, is very knowledgeable on and centrally involved in. And then at the top we have the users and the decision makers, and the essential part is this link, this so-called platform for user engagement between the users, top here, and the underpinning capability at the bottom. And that link is absolutely key. And this is all very much linked into national frameworks for climate services. So national frameworks for climate services were something fully envisaged under this global framework. This is global here, but things happen at the national and sub-national scale. So this started just over 10 years ago. And so 10 years on, we've had various reviews undertaken to look at the progress under the GFCS, the WMO's Congress, so the big governing body for the WMO, and its executive council subgroup have had various discussions internationally around how the GFCS is going and what could be done next. And there are various other structures. There was a climate coordination panel, and they've all provided a lot of very helpful and useful feedback and advice on where to go next. So this next slide summarizes where we're going from here on. So we're refocusing the GFCS. So it's the same vision, still want to enable society to manage better risks and opportunities from climate variability and climate change. The bottom left is the same structure, so all of the underpinning capabilities still essential. The climate service information system, the engagement between the users and the providers, all of those things are absolutely essential. And on the right, the little graphics show the priority areas. It's still carrying on with these essential priority areas: agriculture, food security, disaster risk reduction, renewable energy, energy in general, health and water. And now we're focusing on these 5 broad areas. So this is where we're really putting our efforts in over the next 5 or 10 years, building on what's been done before. So these aren't completely new. They're just a different way of focusing. So firstly, strengthen the climate service capacity and capability for all of the actors in the value chain, which I'll come to in a minute, but particularly under this global framework, the national meteorological and hydrological services. They're an essential component of climate services, and we, through the WMO and other organisations, work very closely with the National Met Service. Then below each of these headings, so then a couple of bullet points just to illustrate some examples. So in particular, this first one, very key to establish national frameworks for climate services. So as I said at the beginning, I'm delighted we're having this workshop today in India. National Climate Fora, which I'll mention in a minute, and also importantly linked to the regional structures. So there are some regional frameworks for climate services and regional climate fora. And it can be very useful to link the national scale to the regional scale. So that's the first one. Second one, and I think the first one is most relevant to your workshop today, but quickly to go through the other ones. So support climate policy and finance. So looking to develop and provide authoritative scientific information to support climate policy and climate finance. And then there's some examples of what's being done. So the WMO produced regular reports and advice to support adaptation and mitigation. So every year we produce a global state of the climate report, and we will produce a provisional state of the climate report this year at COP28. And as we're all aware, this year is proving to be very warm globally and also regionally. And we produce regional reports as well. So we now produce 5 regional reports in addition to this global report to make the information more relevant to various regions. And some nations produce national reports as well. We produce a report every year on the state of climate services, and each year there's a focus sector. And this year the focus will be health. So we'll be launching the state of climate services for health report in November. We produce regular bulletins, collaborating with many groups around the world to provide information about ENSO. So this is the El Nino Southern Oscillation. So typically you'll hear headlines about La Nina or El Nino. So these bulletins provide information about that. Updates on the state of the climate in general, perhaps newsworthy events, those sort of things. And all of this builds on knowledge from IPCC, Intergovernmental Panel on Climate Change. Third one, very important to think about standards, guidance, good practice for climate services, quality management, and develop training. So we assess and develop the climate service capacities and needs of Met services, organisations and countries around the world. And we, through our various technical commissions, the WMO has 2 technical commissions, the Services Commission and Infrastructure Commission. Through those, we look to develop guidance on standards and competencies for climate services. The climate services value chain, so this will be my next slide, that's linking together the underpinning capability all the way through to the users and taking action. We need to develop that further and improve the linkages across that. So linking very much the underpinning capability of this diagram here, the observations, monitoring, the research, information and the users. And there are various programs we can link closely, for example, to the World Climate Research Programme and other programs to improve that, ultimately to generate value and enable actions from the services. And then finally, look to improve the visibility and effectiveness of the global framework and promote coordination and collaboration around the world. Services are essential for society, and particularly at the moment this year, for many reasons, is looking like a very challenging year in terms of climate and the impacts on society. And we need to have global, regional, national coordination. So I'm looking to think about how we can provide global fora, stakeholder communication, knowledge sharing and collaboration. So in India, you're having a national fora essentially. We're looking about how we can do this globally. So the climate service actors, I think this is now important for thinking about national frameworks for climate services, who would need to be brought together within a nation or a region to develop, deliver and use climate services. So this is one way of looking at a value chain approach for climate services. The supporters value chain is commonly used in industry. So I've mapped the porters value chain to climate services. So if we start on the left, we start with upstream capabilities such as the observations, the research, the predictions, projections. We then produce a huge amount of information. Some of that we produce operational forecasts. So the seasonal forecasts are produced in an operational mode, even the multi-annual forecasts. I think the multi-decadal forecasts through the IPCC are moving more and more towards an operational type of situation, updated much less often, but also they are updated in an operational way. Then with that information, we often need to downscale it to a more local scale. So these climate models are global, and some of them are downscaled regionally. So we need to think about how we make the data more relevant to the local scale. Perhaps need to tailor that information as well, think about impacts of climate and perhaps linked to other ones. And so we might need to then develop specialized services, perhaps linking to hydrology, for example. I need to translate the information. I don't necessarily mean in language in terms of English to French or whatever, but translating to the actual language of the decision makers. So what is it? What's the terminology they use? And there we may need to bring in sectoral expertise as well. So work very closely between industry, the decision makers, and the climate service providers. Then deliver the service, communicate it, and ultimately on the right, help users take decisions and take actions. So that's the value chain. And then the bottom in the lighter green is an illustration of who the key actors are in this value chain. So some of the actors, such as academia, they span all of this. So different elements of academia undertake different parts of this value chain. Some national Met services span across the entire value chain. Many don't, and that's not a problem, but some national Met services do. And some climate service providers span this entire value chain as well. And then perhaps international organizations and programs like the WMO and UN agencies, they may be more on the left-hand side, so the upstream capability, the operations, those sort of things. And then the more user end may well involve in-house consultants, consultancies and industry bodies. But they do also span the entire value chain, so it's not meant to be a definitive list, this is just illustrative. And then down the right are examples of who the users are: industry, government, local government, NGOs, public, etc. So on to user engagement. So I was also honoured to be leading a WMO expert team several years ago on user engagement. And here we had a very clear task. This was an international group to identify and evaluate examples of user engagement for providing climate data. And then we published guidance and good practice with case studies. So there's a short Nature Climate Change article that summarises findings of the expert team, and then there's a longer WMO publication which lists the case studies. So in summary, the diagram on the right shows our main conclusion is now very much linked to national frameworks for climate services. So start to think about what are the users' needs, because it's not the case that user engagement can be applied in every single case. So we identified three broad categories of user engagement. So if we start at the bottom of this diagram, very passive engagement, and there's nothing wrong with this. Websites, web-based tools to provide the information. So if we're honest, this is probably how most people get their climate information or weather information. So it's passive. You have a one-stop shop window. It can be kept up to date relatively easily, provide a wide range of products and information. It can be developed to be easy to use and guided by the users. It should be intuitive. And so these are very important. A lot of information is provided to decision makers through web-based tools, but they are passive. And so some decision makers would like to have something more interactive. And so in this middle stage here, we have what we call dialogue-based. So bring people together. So it's two-way. It's not just providing information. It's a chance to have multi-way communications. You can build trust between the different groups. You can learn together, produce together, develop capabilities and capacities, and have regular interaction. So the workshop you're having there will be an example of this. You're bringing together different groups of people to have discussion and engagement in a more dialogue and interactive way. For some, though, they want very focused, very tailored, and very targeted services, so bespoke services. These are much more intense, highly iterative. The data that's provided in the service that can be provided can be made directly usable by working together through one-to-one contacts and developing an in-depth understanding. So there are different levels here, and some users and decision makers may want to have all of these. So they may be receiving information through websites and web-based tools, undertake some wider interactive group activities, and then have very focused relationships to develop and use specific services. And others may be happy just with the passive engagement. So there's these different levels. So now going from the regional, and then the next slides will be on the national scale. So at the regional scale, we have quite a good structure for the WMO with regional climate centres and regional climate centre networks. So you'll see on the figure here that you have a regional climate centre in Pune. And so the primary users of the information from these regional climate centres are the national meteorological and hydrological services within the region. And there are some mandatory functions these centres have. So they need to provide products, long-range forecasting, climate monitoring, data and training. And it's highly recommended that they think about going beyond those to get into climate prediction and projection, other data services, coordination, capacity building, research, development. So these centres are all around the world, and their operations must be consistent with WMO data sharing framework and standards. So you have a recognised one in your part of the world. So they provide products and coordination, and then we also have a series of regional climate outlook forums around the world. We have 21 of these. Some of them have been running for decades, and they're regularly conducted. And what they do is they produce consensus-based seasonal climate forecasts. So you have one in your region, and they bring together groups. So this will be the middle part of the previous diagram where I showed the interactive engagement. They bring together a range of groups across the climate services value chain to produce this consensus-based seasonal climate forecast. And that's excellent. So those are carrying on. But we're recognizing that, as I showed on one of my early slides, there are other timescales of interest to decision makers. And so we're transitioning towards regional climate forums. So it's a different concept because, as the diagram shows, it spans the whole range of climate timescales, not just the seasonal predictions. So the regional climate outlook forums will still exist. There'll be in some ways a subset, but for some decision makers and some regions, they will find it more useful to go beyond the seasonal timescale to consider other timescales. So this is a concept of regional climate forum. So at the national scale, everything I've said would be analogous at the national scale. So national frameworks for climate services, the same idea as a regional one, but more specific and something more tangible. So undertake coordination, think about governance at the national scale, develop collaborations, all to improve the development, delivery and use of climate services at the country level to support decision making. So as I said, it's fantastic we're doing this in India now. And the figure on the right, this shows the status of national frameworks for climate services around the world as of 2 years ago. And this figure is very out of date, which actually is very good news. We need to update this because over the last year or two, we've seen a lot of countries start to develop their national frameworks for climate services, including you in India. And so I'm keen to get this figure updated and update it more regularly than every 2 years, perhaps every 6 months we'll look to update this. So there are more countries now that have national frameworks. So those are the frameworks, but then you need to have a forum, you need to have a platform to bring together the groups for the dialogue. So you have an example you're having now, and it's up to you, but you probably want to think about what you will do going forward. And so have a dialogue to design tailored climate information to the national context, translate key messages for users. So at the regional scale, I talked about these regional climate outlook fora for seasonal forecasts, moving towards regional fora for the range of timescales. And so the national fora would very much benefit from outputs from those regional fora to then feed into your national fora, if that's the way you want to go. And so many, many countries around the world are starting to undertake regular, at least annual national climate forums. Some of them are on the seasonal timescale, some are for climate change, some are for climate monitoring. There are many, many countries that are now starting to develop these. So in terms of guidance, your team there are very familiar with these, particularly Kumar. So the WMO produced some step-by-step guidelines for establishing a national framework for climate services. The current version was issued in 2018. It has these 5 steps, and these are guidelines. So this is good practice recommendations for what to do. It's not something you have to follow, but these are guidelines for what will be useful. So firstly, assess where you are with climate services at the national level, identify the key groups. And then the next step, which I think is what you are doing now, hold a national consultation workshop to bring those groups together, identify gaps, key priorities. Next step, when you understand that, develop a strategic plan and an action plan for what you're actually going to do. Some countries will then find it very useful to get a high-level endorsement of that plan to make sure these things happen. And then next step, launch the national framework and then run it. So monitor it, evaluate it, and go ahead and do it. So we're looking to revise those guidelines at the moment. I think those steps are still broadly very useful, but we're now drawing on these many experiences from around the world where countries have done their national frameworks to revisit these guidelines. And some countries have decided it would be very useful to develop a framework to go beyond climate services, so perhaps to have a framework for weather and climate services, or weather and water and climate services, and that's very much a country-dependent decision. So we're going to produce guidelines or update the guidelines for national frameworks for climate services, and we're going to try and include some guidance and good practice for those countries that wish to expand the scope beyond climate services. I realise I'm running out of time, so I will speed up. So this is in the document I showed before. It just illustrates key groups that a country may wish to bring together, which I believe is what you're doing at your workshop, to develop a national framework for climate services, and it will be country dependent. So my final slide, I hope you're all still with me because I'm sorry I can't see or hear you. So finally, presented perhaps a bit of a positive picture, but there are many, many challenges for developing, delivering and using climate services. So firstly, it's only worth delivering a service if it can be used to influence an outcome. So all of the services that we develop and deliver, we should be thinking about making sure that they will be useful and used to influence an outcome, a decision, policy, whatever it might be. And that is hugely challenging. The way to do that, engagement, coordination, national scale and other scales. It's very important to bring together the key groups across the climate service value chain to make sure the services are being delivered appropriately, to influence the services so they can be developed to be useful. And it's hugely time consuming to do this coordination engagement. There's no way of saying it isn't. It is time consuming, but it's hugely beneficial. So time spent having workshops like you're doing and having discussions and engagement, I can't see another way that you can develop services. Needs to be done to make sure they are going to be useful and actionable. The underpinning capability, there's often a big gap between what it is the decision makers need to take actions and decisions versus the capability coming from the scientists in terms of observations or forecasts or whatever it might be. And we need to be honest and open about that gap. We need to make sure that we communicate what the restrictions are in the capability, and also to then see about ways to narrow that gap. How can we improve the underpinning capability to better meet the decision makers' needs, the users' needs? The concept of users is actually very difficult. I'm coming from a provider background, and it can be challenging to understand who the users are and then to find out what they need. And that's something that we need to work more at. And going back to the second bullet point, it's around coordination and engagement. That's what we need to do, keep talking and working together. It's very important to include other disciplines, particularly in climate services. Social sciences would be one example. So there are many examples around the world. The same is true on weather services as well, where information is provided and there needs to be more added to that information to think about decision theory, communication theory, all of these things to make sure the information is actionable and acted on. And finally, improving the capabilities and capacities of everybody on the value chain. It's not that different parts of the value chain are perfect. They all need to improve their capabilities and capacities. Thinking across the different parts of the value chain as well is very important. So I will finish there. Thank you. I'm hoping you're all still there. I was shocked to stop sharing my screen, but I'm not sure how I'm going to do the questions and answers.
Thank you, Chris. Can you hear us?
I will try. Thank you very much.
Can you hear us? Hello? Can you hear us? Hello? Yeah. Can you hear us?
I can hear you.
Okay, okay. So if there is one or two questions. Can you hear us?
I can hear you.
Okay, okay. So if there is one or two questions. Can you hear us? Okay, okay. So there is question, one or two. Okay, so there are no questions. Thank you, Chris, for very informative talk. Thank you.
So
We will.
there are no questions. Thank
Yeah.
you, Chris, for very informative talk. Okay, so we will. There are no questions. Thank you, Chris.
Okay. So now Satyaban, please. Satyaban is needs no introduction because has already given vote of thanks. So
Good afternoon, everyone. My talk was prepared for 25 minutes in view of the shortage of time, and it's close to the lunch break. So I will finish my talk within 10 minutes. But this is the very important talk we planned because as these participants, they came from different ministries, different agencies. We'd like to just brief why this our IMD headquarters entrusted us this NFCS activity for CRS Pune, and how we are coordinating with various state government departments, how we are coordinating with central agencies, and how we are coordinating with international agencies. That is what. So there will be some slide which are already covered by the previous speakers. So I will quickly speak those speakers. I do apologize for the same. So my background was the background why these activities were carried out, and GFCS already Dr. Kumar and Dr. Chris has explained. And what is NFCS? At this stage, I no need to explain. There are already several talks. Role of IMD in coordinating NFCS, that is where I will more focusing. And there is a brief summary. So we already know this is one recent paper by Ray et al., where we have seen that our India is how the extreme weather events, it didn't left any part of India, whether east to west, north to south, every part of India, it causes in number of extreme weather events are increasing, and it is causing the huge impact in the different part of the country. And it is also, most of the IPCC projections are indicating that the extreme weather events, either heat weather events or cold weather events, especially heat extremes and extreme rainfalls, are increasing. So in view of this due to this, how to face these challenges, extreme events, and how the challenge society cope with such extreme weather events, this NFCS will be a great mechanism to help the community. So now I am not going to see, but at the time when the GFS is formalized, we can briefly tell that is 5 goals was there for GFCS. That is enhancing the resilience of society to cope with related hazards, and advancing the key development goals, mainstreaming the use of climate information and services in decision making, strengthening the engagement of providers and users of climate services, and the last, that is the important, which is the maximizing the utility of existing climate services infrastructure. So this is also I'm not going to skip at this stage. As we say NFCS, we know already service providers are there and those who are using the services. But what is the aim of this NFCS? That is the NFCS aims that all the institutions are working together in the related to climate services. They are kind of scattered. But once they see in the right panel, we'll see that image, they come together, they merge together, they work in the mutual agreement manner, the service of the climate service can be improved. That can help us to reduce the loss of human lives and loss of the properties. So then the question comes, why IMD is leading, India Meteorological leading, why in the NFCS? We are telling that is a multi-institutional framework, but why is it leading? So as per the GFS guidelines, we can see that it was there that the country's NFCS should be led by the National Meteorological and Hydrological Services, which is NMHS. So in India, the NMHS rule is applied by the India Meteorological Department. That is why IMD is leading this program in cooperation with various state and central agencies. Now it came to the climate research and services. This is most of many people, those who are out of IMD, there is a brief history you can tell. This building is actually our IMD Pune office. So the top of I am writing that this building is standing tall for about 100 years for the weather and climate services in the country. That means this office where the IMD Pune office, you can see here, that building was inaugurated in 20th July 1925. Very soon it will complete 100 years. And that is the then headquarters of India Meteorological Department, Pune. And what does this CRS Pune office currently working? So there is what NFCS, we are talking about the 5 pillars. Most of these 5 pillars activities are happening within the CRS office. For example, the climate research, which is the part of 1 pillar. Then the observation and monitoring, where we are doing, there is also the surface instrument, SID, various observation network that is coordinated by the division. And the capacity development, that is also one part of these 5 pillars. There we can see that this is the Meteorological Training Institute, which is also a WMO recognized regional training center that is situated in Pune. It is a part of our IMD Pune office. Then there is a agreement division, weather forecasting division, and we are whatever the climate monitoring, and another is the climate application and user interface department. So this I am not going to do as part of the CRS activities. We are doing this climate monitoring activities. But this one important slide, we are telling how we are coordinating with the state government, because we have a presence in each state. So since last 2 years, we are in following with our annual climate statement for the country. Since last 2 years, we are preparing the annual climate statement for each state of the country. This is the examples, because the shortage of space, I am giving only 8 space. That doesn't mean we are preparing for 8 states only, but we are preparing the annual climate statement for all the states of the country. How we are preparing? Any weather and climate data is we are having, but if it contains the data related to loss and damage data, any agriculture loss, any loss information we are getting, that we are collecting from our state government office in coordination with our meteorological center situated in the different states. So what we do before around around September, we write to all the chief secretary and all the relevant 5 important sector, disaster management, water, who are the relevant, generally they are coordinating office. We are writing to provide the loss and damage data. And by end of December and initially in the month of January, what are the information are available, we are putting together. So the last year we can see, many of the state government, they provided this their data. So wherever we received the data and we consulted them, where we got quick response, we have prepared this report not only as a IMD report, but it is a joint report between the IMD and the state government. This I am not going to say because I already discussed. We are doing the climate forecasting, which is coordinated by our CR office. And this is also, we already, previous speaker explained, another actually climate application and user interface group. And climate data, so because most of the climate data which IMD deals with based in our Pune office and which is coordinated by the Pune office, as our head CRS, Sri Hosalikar was mentioning, there is a data portal. Nowadays, as per the number of extreme weather events are increasing, as the challenges are increasing, now we are receiving a huge request for the demand of the weather and climate data. Diverse field, students, researcher, academic institute, and different ministry also. In the last couple of months, we are surprised to receive that one car manufacturing company also, they are asking, what is the El Nino, La Nina data and rainfall data? That is one. Another one, we are receiving data from the fashion industries because they wanted to know how the weather, the warming pattern, the region variation of weather and climate changes, anything happening, that they need to, the fashion industry also, they need to cope, they need to change their products. That is how the demand of the climate data has been increased in the recent years. This is actually, this is not only looking after this, coordinating the activities in the country, as just the Professor Chris Hewitt mentioned, we are also coordinating the weather and climate activities for this South Asian country, which is focusing on the 9 adjoining region of the South Asia. It is actually our IMD Pune office is also a WMO recognized regional climate center to look to coordinate the means weather and climate activities in the South Asian region. Various activities during the last 1 year, for example, we conducted training program for our participants from the South Asian countries. and we release bulletin. For example, every month, we know now last 3 years it was a La Nina, and now it is El Nino. So even general public became more aware of this El Nino La Nina because it is successive La Nina and El Nino year. So we would like to inform that in India, from IMD, every month we are releasing El Nino forecast bulletin for the next 9 months, which is every month updated in our IMD website. So similarly, we are providing climate outlook, not only for India, we are also providing climate outlook for the South Asian climate, even individual country level, we are providing information. This is the where we are telling, I explained about the collaboration with central agency, collaboration with the state government. This is one example to conduct some of the international program, to coordinate with this program with the South Asian countries. We also need some international cooperation and international collaboration. These are the various agencies within India and outside India, starting from various parts of the world. They are also collaborating with us to provide weather and climate science in the country. So when NFCS is designated, this is the last second slide. How we planned, because once it was decided that there will be NFCS will be formed in our country, then we conducted a brainstorming session with our through IMD community, because we have to lead. Before we telling something to our partner organization, we should know exactly what we are going to do and what we are going to ask to the other collaborating agency. So then we prepared a scoping document. We shared with all the scientists to get feedback from all the different states, for example, so that we can formulate our plan. Then we started preparing for our consultation workshop. Then we are waiting for the final green signal when we will come together to frame this climate services activity in the country, so that NFCS India will come true as desired by most of us. This is a success story why we wanted to come together. This is the one example I will see. But we can see that in the 10-15 years ago, it is everybody is an example for everybody. We are coming in a many news article and many international agencies are explaining, due to cyclone, for example, sometimes there is a 20,000 death is used to occur, 10,000 deaths, some of the cyclone used to occur. But in the last few years, we can see that this number of, this is the way the paper by Ray was explaining, we can see the number of extreme weather events are increased, but if we see the far decades, the number of loss of lives during the last few decades is not increasing in that rate. That is how it is possible. That is possible due to this example. We can see cyclone means IMD, NDMN, this is national agencies, state agency, and other agencies, those who are related to the cyclone activities, they came together. That helped to reduce the number of loss of lives in the country. Similarly, we can see in the 2005, there was a large number of deaths due to heat wave. But immediately after, see, many state, many municipality corporation, many department, they started actually heat action plans to reduce the loss of lives. Many state governments started working, collaborating together. So that indicates that even though the number of the extreme events are increasing, the loss of lives is reduced. This is the success story, that when multiple agencies are coming together and they are working together, that is the result. So where it is only just 2 examples, but if NFCS India will be realized, there will be a many successful story to tell during the next decades. That is where I am. This is the last slide. Because it is the 5 important sectors are covered in these activities. We are, as a service provider, we are providing data to the different 5 sectors here. But what happens, sometimes it is a one-way mechanisms which is happening. But what we are providing to one agriculture or water, the same data, same information, if 3 institutes work together, the climate services process will be improved. That is what aim. So the NFCS India will be not only in collaboration or coordination between the only 2 agencies, but it will aim to the structured firm, that whole mechanism, different sectors mechanism will come together to, that will help to develop a climate smart country. That's where this is just quick summary. I don't want to go straight. It is because I already explained all these activities.
Thank you.
Thank you very
Satyaban.
much.
Thank you. We'll give a, Dr. Satyabanji, thank you for your talk. Any questions?
See, one of the important points that you said was about the data portal. So I still remember it was initiative from Dr. Rajivan when he was secretary. So that, we have a online data portal was there. So if you see that there has been a very significant increase in the users, mainly because we had made all the gridded rainfall data, temperature and other data free of cost. Now researchers are using. So that is one of the important points. So just I want to add that along with this portal, we also should consider to collect sectorial data. So this is an important stage today that many sector people has come. So because to further development of climate services, we need also not only the climate data, you need a sectoral data. So we should have a scope for increasing this. And another point that you mentioned about state, climate summary. I strongly feel that the ownership of preparing this climate summary state should be with the state government. We should encourage and empower them to create. We should provide them data to make a district. Because if IMD prepares everything and you put in website, nobody is going to use, frankly, because when I was in Kerala, first time in the state government, we had prepared climate summary and there was a lot of appreciation. So instead of having everything in a put website, we should prepare through local MCs and they should work with the state government, some state agency, and they should take district wise and and it is easier for them to collect all the impact data and other thing and put in a summary. So I think IMD, this is again another stage where we can put encourage and empower state government to do that. Yes. And the third important point is that as a part of this NFCS, we also should encourage state level climate, like monsoon, wherever extreme events are occurring, or monsoon like we give in a national forecast in May, we should encourage state government to have a local, in a local language to have a monsoon forum. So these are just my comments, which we can have discussed in later stage when state government people will be speaking on.
Yes.
Thank you.
This afternoon we're talking. One more thing.
Good afternoon, everyone. I'm Captain Ramnathan. I'm from School of Naval Oceanology and Meteorology. Thank you very much for the informative presentation since morning. For a long time, Navy has been in touch in collaboration with IMD for various information sharing, data sharing. We have been taking so much of data from you, and we are also ready to provide platform for giving data. We have about 9 naval air stations, and our ships are ready to get deployed. Most of the time, they go on a repeated sortie to areas in both Arabian Sea, Bay of Bengal, even South Indian Ocean, all over. So we can be a very good platform for providing data. I think we should also be part of this NFC.
Yes.
Defense should be very much part of this. And second thing I would like to know, one important aspect, at least for Navy, is the sea level variation. So for our infrastructure development just along the coast, and sea level rise is going to play a very important role. The next 40 years, 50 years, our infrastructure developments are going to happen now, which we are expecting it should sustain till that long. And if there is going to be any change in sea level, that should be also part of this climate change services which should be provided to the forum. And that will be of big use.
Yes. Regarding your first point, that is, we very much agree that is what we came together to collaborate, increase the engagement between the different institutes. That is what we are here. So that will work. And in terms of sea level rise, anything issue, because our partner institute is INCOIS, they are doing a lot of activities related to the ocean services. So they will be there because we also invited our INCOIS partner to this meeting. So any kind of related to ocean services, because any type of weather forecasting related to marine weather forecast, for example, it is IMD coordinating. Anything related to our ocean things also, it will be supported and coordinated by the other MOS institute. That is what we are planning.
Just to add on to what Captain Ramanathan said, I'll take 30 seconds. I'm Commodore Barve. I'm the Principal Director, Naval Oceanology and Meteorology. So other than the fact that data is used by us and we would like to share and we would like to be on the same platform as IMD and other agencies, there's another aspect about instrumentation and infrastructure. I have seen that, we have a naval air station or we in naval headquarters, we want to buy a particular equipment, we do our own research, we find out the vendors, we do the entire government procedure to try and put 3 or 4, sensors or some kind of equipment in our air stations. But actually speaking, I don't see why in the near future, we cannot be part of, our stations cannot be part of what IMD is envisaging at the national level. We could always comment on the suitability of an equipment in terms of security, etc. But if we are part of the same platform where all weather sensors, weather equipment, etc. is being centrally thought of, we could probably benefit in the long term.
Yes, sir. Yeah, this is a very important question. So I request our head CS, who is the heading our instrument division, he will be a very good person to reply this.
Barve Sahab, I think we have IMD and DINOM. We have already started having a dialogue on this, and maybe very soon we know, because this requires sort of policy related matter. Maybe sometimes we meet at headquarters or as quickly as possible and we sort out. This is doable, and I think this is the need of the time. I think we should not waste each other's time tendering and again and again. Maybe this can be worked out under the guidance of MOES also. Thank you. We'll do it.
Yeah. Just a very quick question. Thanks a lot. I mean, you gave us an insight into the line of thinking that you already have. And in that, I presume we are in the beginning. This workshop is somewhere in the beginning. Yes. Okay. Now, 2 terms came up in this. One is the framework and the other is the forum. Climate National Forum and the National Framework. Are we differentiating between the two? Because the framework appears to be a little bigger than the forum itself. The forum is just a hub where the user and the provider are linked.
Yes.
It can be even thought of as a soft mechanism.
Yes.
Or it can be a hard mechanism, whatever you think. But when you talk of framework, there could be something bigger than that. I presume that's everybody's notion over here. And that's related probably to governance.
Yes.
I mean, a forum is something where it's voluntary. I need something, I go there. Okay, but a framework is something where it is mandatory. That means you are laying down certain rules of the game where all the governments at different levels, they will conform to it. I mean, if that is the general thinking, I mean, we could perhaps differentiate between the 2 terms.
Yeah. Thank you, sir, very much, your suggestion. Yeah, due to shortage of time, I cannot take any questions, but we can talk anytime during the lunch break or tea break or during the dinner this evening. Thank you very much.
We'll thank all those 4 speakers. It was a very important session to set the tone for this very important meeting. We'll hear the feedback from the stakeholders later. And Dr. Rupa Kumar Kolli, Dr. Satyaban, Dr. Rajashree, and Dr. Chris Hewitt. So let us give a claps for all of them. Yeah, with this conclusion, I'll conclude this session and hand over the mic.
Thank you, Dr. Ike Sahai and Dr. Saji Mohandas for chairing this interesting session. Now we will be breaking for lunch. Lunch is arranged in the banquet hall downstairs. Volunteers will be guiding, and we will resume the session at 2 o'clock. I request all the speakers who are giving presentation in the next session, kindly share your PPTs. We will upload here. So the next session will be chairing will be by Dr. M. Rajivan, and co-chairing will be Dr. Shantanu Bal. So at 2 o'clock we will start the session.
Good afternoon, everyone. So after the lunch, we are proceeding for our second session, which is user perspectives of climate services. So to chair this session, I would like to invite our respected former secretary, Dr. M. Rajivan. And co-chairing this session, I am inviting Dr. Shantanu Kumar Bal, Project Coordinator, ECRIP from Central Research Institute for Dryland Agriculture, Hyderabad. So,
E4-6, okay. So anyway, whatever we have, I think we'll start. I think this there are 1, 2, 3, 4, 5 presentations, and each presentation of 15 minutes duration. You want me to speak here? So first presentation is by Nataraja Subash, my good friend from agriculture.
So shall I start, sir? Okay. Good afternoon to all, respected chair, co-chair, and distinguished delegates. First of all, I would like to thank the organizers for providing me the opportunity. Basically, myself, Dr. Subash, Head, Division of Agriculture Physics, School of Natural Resource Management, ICAR-IARI, New Delhi. And basically, I will talk about 3 aspects. One is how we are using the advisory services under this Grameen Krishi GKMS. And second one is how we can do the impact analysis at the farm level, because we are talking about the district level or block level, and how we can do the impact assessment at the farm level. You see, each farm is a different aspects, and even they grow different components. And also the main point is the resource availability with the farming community, the availability with the farmer, that is most important. And the third one is how this historical data can be utilized for vulnerability analysis. That 3 aspects I will cover. And the first thing is why we need the climate services in agriculture. You see, the management of weather and climate risk in agriculture has become an important issue due to climate change. And the IPCC also highlighted the multiple climate risk for agriculture and food security. Particularly, it will vary with the crop as well as the cropping system and also farming system. Then how we can use the weather and the climate information that will help to make better informed policy, institutional and community decisions, particularly decisions of farmer, that is reduce related risk and enhance opportunities and improve the efficiency of use of limited resources, because each farmer is having their own resources, and how we can utilize, how we can improve the input use efficiency, then increase crop, livestock and fisheries production, how we can do. And these are the 3 aspects. One, we see the weather, that is days to week. We have the observed rainfall and temperature, and we have the forecast, and we can use this forecast for alert on pest and disease forecast, then early warning of extreme weather events, so that farmer can take their decisions like timing of planting and harvest, then timing of fertilizer application, then pesticide application, then irrigation, etc. And also protecting lives and property. Basically, we will give the advisories to mobile, radio and newspaper. This is the existing system we are doing. And also next is climate variability. That means we have the information on climate variability as well. This is for months or 2 years. And here we have the probability studies. And based on that, we have the probability studies with the historical data. And we will do based on this data set, we will discuss with the experts, different stakeholders. Then we will go to the extension expert. Then we will do the farmer decisions they will take based on what crops they can grow, what variety they can select, and also the livestock stocking rates and feeding component, then intensity of input use, labor and market. We need to link this with the market as well as the value chain we need to do. And also intensification and diversification of cropping system. That means one crop is there, they are following. Suppose they have the historical data is there, then we can modify the existing cropping system we can introduce the new cropping system or new crop, or also we can, in the cropping system is there, rice seed cropping system, we can introduce one crop after that we can do with the historical data, and also diversification of sources for increasing the income. That way we can use the historical data set, and also then climate change studies. As I told, climate change studies, we have the impact at the district level or crop, but how it can be linked at the farm level. That example, what we did some work in this direction, I will show you that. And so that based on this study, we can make some major capital investment under different changing scenario, and also farming systems can also modify, and also we can plan some breeding aspects also based on the climate change impact. And as shown, this is the significant extreme weather events occurred. And as you know, in India, we are telling about the diversity. You see, as far as the predominant cropping system is concerned, we have more than 80 cropping system across India. This is a predominant cropping system. When we talk about the predominant cropping system, when we talk about the second predominant cropping system, we have more than 140 cropping system exists over India. Then, just comparing the Indo-Gangetic basin, Indo-Gangetic plains, which is the food basket of India or South Asia, you see the difference between the different region. For Indo-Gangetic basin, we have the western region, upper catchment region, and the western eastern region. You see the difference between these regions. You see Indo-Gangetic basin, that is this region, basically the upper catchment, you see their problem is different. Low productivity region as far as rice feed system is concerned, and the poor investment in infrastructure, medium to high precipitation, then high potential for cold water fisheries and livestock we have to do, and the degradation of land and water resource. So like that, we have the different problems in this area. And when we talk about the western region, it is the high productivity region and the food surplus region. Then high investment in infrastructure. Already we have the good infrastructure facilities, but higher inputs for agrochemicals they are using, and the low to medium rainfall. And the problem is over exploitation of groundwater in that region. And when we talk about the this eastern region, it is a low productivity region and low investment in infrastructure and underutilization of groundwater, and very few developed irrigation network in that area. But there are extreme weather events when we talk about the flooding as well as moderate drought in most parts of the eastern region. Then, based on our experience, we are part of that GKMS project. Here we are issuing the this advisory to the farming community in NCR region, and we also studied. I want to highlight this one. Basically, what is the impact what they are getting in the last year because of the rainfall forecast? The farmers could save around 9,600 rupees. 6,000 rupees per acre they can save because of our advisory services. So that is the impact at the farm level. Then another study we did based on the integrated assessment of impact of climate change at farm level. We have studied this in the district of Meerut district. We have studied around more than 120 farmers field, and we have collected all the data set regarding the crop management aspect, then socio-economic aspect also. Because anyway, we are telling the crop component, but we need to see how this will affect their income. That is why we have collected the socio-economic aspects also in these farmers. And based on this, this is the approach we have adopted. This is basically what is the sensitivity of current agricultural system to climate change. When we talk about the climate system, you see current agricultural system is this one. Here, this is the current system. Because of the climate change or climate variability, the yield will reduce to this level. Then because we will provide some adaptation measures, and based on that, we can increase the yield to this level. But when we compare the future, you see automatically yield level will increase to this level because of the technological interventions. Then in that time, there may be climate change aspect. Then the yield will decrease. Then we need to think about the future adaptation strategies. What adaptation strategies to be followed in future? That is different compared to the current adaptation strategies that we have studied. And here, the typical farming system in that particular study area, you see each household, they will keep different, they will grow different crops, rice wheat system, sugarcane wheat system, then minor crop, maize, sorghum, and each household, they will keep 1 or 2 animals, and they will grow the fodder also in that particular area. And they will use this cow dung for, they apply for field. And we have studied the climate change projected values, and it is very difficult to study all the climate GCMs for impact study. We have selected 5 GCMs for subsetting, we did, and we have selected under different quadrant, basically hot, wet, hot, dry, cool, wet, and the middle of that, we have classified the GCMs, and then we have studied 1 GCM in each category. And this is a better data set and how the different models behaved, and particularly during the rice wheat system, rice wheat season. And this is for temperature and also the rainfall pattern during the rice season as well as wheat season. We found that when we talk about the annual rainfall, that is okay. There is not that much variability. But when we talk about the seasonal, then there is a lot of variability with the rainfall. And these are the parameters need to study the economic situation of the farming community. That means we have collected all the data set for actually what we did is the climate data is there. Then we linked this with the crop simulation model. Then we linked with the TOAMD, trade-off analysis and minimum data set model. That is basically the economic model. And then we linked these things, and this is the approach we have followed. We have started from the farmer. That means we have started the survey data. Then we have the link with the different stakeholders like researchers. And then we have the link with the developmental officials at the State Department. Then we have the state level, because agriculture is state subject. That's why we have the link with them. Then finally at the country level, because any policy decisions at the country level, that will affect the local level. That we have studied. And then we have come out with 2 representative agricultural pathways. We are talking about climate pathways. Like that in agriculture, we have 2 pathways. One is a green pathway. This is sustainable agriculture pathway. That means for the future. That means in the future, better management of natural resources. That will be the government policy. In that time, more allocation will be there for natural resource management. In that case, there will be less degradation, low cost of production, and sustainable mechanization. Mechanization will be there, but it will be under sustainable way. Then there will be low income disparity in future. So the region will become food secure on sustainable way. That is the green pathway. And another pathway is gray pathway, that is unsustainable way. That means because of the high population growth, there will be agricultural intensification, and the higher exploitation of natural resources, declining land productivity, finally the high market and climatic risk will be there. In that condition, there will be unsustainable agricultural pathway. So based on that, based on the discussion with the different stakeholders, particularly with the developmental officials and the progressive farmers, we have arrived the direction of change in future. That is representative agricultural pathway is nothing but the virtual representation of the future that we have, and we have quantified the direction of change based on the literature as well as the discussion with the researchers. Then we have run the models, and finally this is climate change projection for that particular area under green as well as gray pathway, and then how it will impact the food security in that region. The rice, there is a negative, and also we have studied two models, that is DSAT as well as the APSIM model we have studied, and finally we have the vulnerability. We have found that around 50% of the farms in that area is vulnerable to climate change under the present situation. But when the future, there will be adaptation. When we incorporated the adaptation strategy, we can increase our, there will be 50% of the farms in that district will be under green pathway, their income will increase. There will be an increase of income by around 20% in future if they adopt the adaptation packages. Because adaptation also, we have some package like the change of date of sowing, then also increase of this fertilizer application. That means increase the input use efficiency so that we can increase the food productivity so that their income will be increased in future. So this is the final output of that I already told. And this is, then another thing is, nowadays most of these studies related with the forecast. What we did is, this is the variation of all India rice production. When we talk about the rice, there is a lot of year-to-year variability for during the Kharif season, rice, sorghum, pearl millet, and maize. And what we did is, we have tried to use, there are data availability, because we need to study the historical data with the El Nino effect, because this year also initially it was there El Nino effect. So what we did is, we have studied 3 years, 2002, 2004 and 2009, this El Nino year, how the productivity varies spatially. Okay, there will be an increase or decrease at the country level, but how it will be under a spatial level. That means at the district level, all these crops, how it will perform. And under this, what we found that we have published in the climate services, here we have identified some of the districts which are vulnerable under El Nino situation. We have identified, and these are the, with respect to rice, when we talk about the rice, these are the districts which are vulnerable under El Nino, because we have considered 3 years. In these 3 years, these districts, they got reduction in yield. But at the same time, the remaining districts, it is some of the districts, they have only 2 years reduction. So there is also vulnerability. And finally, we have arrived around 77 districts are vulnerable under this El Nino. That we have studied, but we need to see, because this is only 3 years study, 3 years we have considered, we need to study more El Nino years, but we need the data set for that. And another thing is, this one, future strategies, what we can do. You see, basically, we are giving advisory to the farming community, but it should be reliable, because once it is reliable, then they will trust us. And another thing is confidence building of farming community. That is also essential. Then only they will follow our advisory. Then use of ICT for tools for preparation of dynamic and the decision support tool for preparation of advisory. We are issuing the advisory, how we can, automation can be incorporated into the advisory. Then village or block level accurate climate information. Already IMD is issuing the block level forecast, but how we can improve the forecast, because we need at least more than 60 or 70% accuracy is needed for agriculture purpose. Then strengthening collaboration with extension agencies. We have the KPK system, but how we can link more collaboration or more effectively we can utilize the system. Then more participation of national, international, and private participation in dissemination of advisories. These are my suggestions. Thank you for patient listening.
Thank you. It's a very wonderful presentation. So, any questions to him? It's okay.
Yeah, thank you, Dr. Subash. Yes, for your talk. Actually, in the initial slide, you are saying the future our yield is going to increase. So, and what will be the adaptation strategy for future? And number two, whenever you are using this forecast or anything for the agro advisory, how do you define this impact? Whether it will be different for the different crop, whether it will be different for the different stage of the crop. How, if suppose if you want to fix the impact of particular forecast or advisory, how we can do that one? How to impact matrix or parameters? What are the possible parameters for that?
Yeah, regarding your first query, basically in the future adaptation strategy means we need to need to develop some new varieties that will require reduction in input, so that we can increase the productivity as well as the profit also we can increase in the future. That is one adaptation strategy. This adaptation package we have suggested. And next one is second question regarding the advisories. Suppose this crop, wheat crop, you are getting 2 rainfall events they are getting. Normally in wheat, we need 5 irrigation. Suppose they are getting 2 irrigation from the rainfall, they saved 2 irrigation, that also converted into that income. And also this is for one crop. Suppose at a farm level, we need to consider all the crops which are growing by the farmer. That we need to consider.
Dr. Subash.
Yeah.
What do you think about IMD services? How should we align our agrometeorological advisory services for better applicability at say farm level, if not farm, at village or panchayat level? What changes? You are partner, you know how do we deliver the services. We are working in that together. What additionality should be there in that service so that it becomes more effective and maybe a part of recommendation of this workshop?
Yeah.
This is regarding weather. It's a weather service.
Yeah.
It's about weather service because.
Okay.
Today is climate service.
Yeah. See, Dr. Subash, your result which you showed very excellent. But I think today what we may need is actually what are the current arrangement of climate services with various stakeholders, and what are the gaps, and what more we need to do, because that will help actually today's ultimately coming. So that's just my comment, and the next sector people will come.
Yeah.
I think we should insist more on this point. What are the gaps and what more to be done and how we can better.
Yeah. Group discussion we will.
So thank you, Dr. Subash. I have a small comment.
Okay.
You are talking about it's good that you are doing a climate change assessment report, a climate change assessment exercise. It's very important. But I have taken Meerut as an example. But be careful, these climate change professions have a lot of uncertainties. And going into a district level and trying to do some kind of impact assessment is a little risky. So, and also especially if you have estimates are quantitative. So, better to do some kind of a probabilistic kind of assessment. And also, it will enhance the area. So, district level is to 2050 at the Meerut level, we don't know what will really happen. The models are just indicating.
Yeah.
We have to be very careful.
Okay, sir. Thank you, sir. Thank you for.
Yeah, okay. So we will move on to the next presentation, climate services for public health by Aakash Shrivastava.
Okay. Good afternoon, everyone. To start with, I would say a few words that since morning we've been hearing a lot about the sectors that are relevant to the economy. Now, beyond the impact that the climate change has on economy, it also has a huge impact on health. Now, the way it is different here is that even though we have now agreed broadly to the new definition that health is about the well-being of a human subject, his physical, mental, social well-being, and not the mere absence of a disease, but unfortunately, the health department continue to only be able to address the disease component of human subjects. So all other sectors need to come forward and participate if they want to talk about the holistic health, about well-being of human subjects. Because if it is left to the health department to cater to that subject, it is unlikely to happen, because the administrative control of the health sector is largely only on hospital, health centers, and medical professionals who are primarily designed to provide cure. There may be some essential public health services, but it cannot cater to providing an absolutely healthy environment for a survival of a healthy well-being. With that, I will start my presentation, please. So, when we talk about climate change, this is a very classical figure from the US CDC, which explains how does climate change impact human health. In the center are the 4 core factors of climate change. The next circle is about the impact of these 4 core factors into these exposures at the next level, and the outermost are the various spread of diseases or health conditions that happen because of the next level exposure variables. Now, if you look at this figure, what it tells us that climate change impacts almost every aspect of health that has been known to us so far. Entire spectrum of communicable diseases, entire spectrum of non-communicable diseases. So there is practically very less that the climate change is not going to impact in what we know about human health. Of the available figures that have been available with the literature, we can see that in context of magnitude, also its impact is not. Let's see only on the 5th level, the air pollution. This is an Indian study where the Indian studies say that almost every year we lose 17 lakh Indians on account of air pollution. So I'm talking about just one of them, and there's so many others that need to be accounted for. So somewhere a very fancy effort came in the year 2015, when under the Prime Minister's Council of Climate Change, it was recognized that health is not being addressed properly, and a separate mission on health was asked to be formed. And by 2019, we came up to put up a national program, because we realized that we cannot address this question sitting at the headquarters. It has to be a cooperated work of the state government, district government, and the national government, because climate impacts differently in the different parts of the country. And therefore, there is a mechanism in the Ministry of Health known as the National Health Mission. When we identify a certain health issue that needs to be addressed in a mission mode, then the central government and the state governments come together to address that by sharing of funds. So we bought it as a program in 2019, and fortunately, today, in all the states and in all the district health departments, we've been able to identify an officer, a team, and to supervise them, we have a multi-sectoral task force and governing body. To work forward with the climate change health-related aspects, we have asked all the state governments to develop their state-level climate change and human health action plan. Today, 34 of them have been developed of 36 states, and they have the approval of the ministry. And the next level that we are working now is to develop onto the district action plan on climate change. It's not that previously there was no contribution in the national action plans of climate change that you must have heard in 2008 and 9. It also used to have a small section on health sector. But the problem was that the people who contributed to development of those small sections did not hold responsibility to implementation of it. By making a mission, at least we have accounted that people who are making the plan are also held responsible towards the implementation to it. So it is going now to be in a continuity manner. As we cannot address all the health concerns all together, we have listed out some of them which we have addressed as of now. Air pollution, heat-related illnesses, extreme weather events, climate-resilient infrastructure, and some states have also addressed vector-borne diseases, and to some extent we are working on health vulnerability assessment. The other that on that side are probably our future scope of action, but this is where we are today. And if I say on the 34 state action plan, they all have specific health-related subjects, chapters on air pollution, on heat, on extreme weather events, climate-resilient infrastructure. So I'm going to talk about the work that we have been able to do so far under this program. The first is related to health-related illness and death. We have established a surveillance system through a portal. This is known as Integrated Health Information Portal. And that we have started collecting this information. Previously, we used to collect it on email mode. This year, we were successful in initiating it through the portal from March 2023 only. The data has been collected across from all the health facilities, primary health center and above level, and it's usually been collected in the period March to July. We collect information about heat stroke cases and deaths. The deaths information is collected on total deaths, cardiovascular deaths, and other causes of death. As probably we heard that the deaths on heat may not necessarily only happen because of direct impact, but also because of cardiovascular failures. The IMD has been working with us in these 4 or 5 years of our program and have been quite helpful for us in providing the necessary data and support. We have utilized an API link to this surveillance platform to collect information on Tmax, Tmin, and relative humidity data. And also, we use the forecast bulletins that are available from the IMD, seasonal bulletins and other 2 weeks bulletin. And we, along with health advisories, share with the state officers and district officers through emails and WhatsApp during the season. We, however, do require collaboration for complex analysis on meteorological parameter and the data that we collect on this surveillance so that we can understand the relationship between these outcomes with meteorological parameters, and also on certain other complex parameters of meteorological data which are not available to us directly. For example, the heat wave and the severe heat waves that may have happened, the continued numbers of heat wave days that might have happened, and the heat humidity indexes and so on. Also, we may require support for threshold computation for cities to understand at what level of temperatures or weather meteorological variables do we start noticing an increase in number of cases or a number of deaths, and that would help us in our planning of health services. Similarly, there is also a surveillance system that we have established under the program, which is an air and disease surveillance program, which is going to be onboarded. It is at the process of onboarding, and maybe by this winter, we'll have it on the platform portal itself. Here, we collect emergency department data from Sentinel Hospital from the NCAP cities. NCAP cities is the cities listed under the National Clean Air Program as the non-attainment city. From there, we have established the Sentinel Hospital. We collect information on acute illnesses as well as exacerbation of chronic respiratory illnesses, the visits, the admissions, and the interventions done. We have used AQI API link from the CPCB and also use the IMD forecast bulletin along with the health advisories that we share on email and WhatsApp group with our district program officers. Here again, we would require collaboration for complex analysis of health outcomes with air pollution parameters. Now, the third is vector-borne diseases. One of the efforts that we are making right now is using application that is been provided to us by the WHO TDR Geneva group on predicting forthcoming outbreaks of dengue using meteorological, epidemiological, and entomological indicators. We are still on working on availability of servers to host this application. So this work is still in process. We haven't initiated it. We also know that IMD Pune, it releases its threshold information related to malaria and dengue that is available on the website. However, how are we going to make use of that information would require further talks and deliberations, because it is, as of now, is not available in the form in which it can be used by the state government. But we can still work on that further. The next area is vulnerability and risk assessment for planning and implementation. Now, there are two types of assessment here. First is health vulnerability and risk assessment for the climate-sensitive health condition, accounting for extreme weather, demographic, socioeconomic status, and availability of health services. So, ranking the district and sub-district according to their vulnerability for this climate-sensitive condition. And the another vulnerability or risk assessment that we require to work on is climate resilient health facility infrastructure. That is to understand the climate vulnerability for the purpose of planning construction or retrofitting of health facility in areas where they are prone to be impacted by climate change. All the healthcare facilities in our system are geotagged, and if we can work together, we will probably use this information. The next area of work is early warning for climate change related extreme events. In order to activate the health sector preparedness to extreme weather events, we would require extreme weather event warnings, not only to the Department of Relief and in the state government and the district government, but also to the health department. We very recently, in the pre-cyclone workshop that was held with IMD a couple of days ago, we also requested to link our state and district level nodal officers' email IDs to receive these warnings. But same would be required for other bulletins, so that they, along with respective advisories, could be provided to state and district health departments on time. And also jointly required to work on health impact-based messaging, so that automated messaging can be provided to the community whenever a respective threshold of a given condition is crossed. Historical data of meteorological time trends, hotspot maps, extreme weather events, if available from the state to sub-district level, can help us create hazard plus health impact awareness for the listed places wherever these conditions are affecting the health of the people. Also to help health sector planning for resilience and also for health infrastructure planning. For these three purposes, if that historical information that is available with the IMD can be shared with us, we could design that respective information and make use of them in our planning purposes. And as I said earlier, just like in temperature, threshold identification using firstly only meteorological indicators and secondly meteorological plus health impact indicators to be able to communicate to the public when action is required for a given hazard. So as I said, 34 states have already published their state-level action plan with separate chapters on air pollution, heat, extreme weather events, climate resilient healthcare infrastructure, and some have on vector-borne diseases. Now we are in the stage of drafting the district action plan. We need to understand that health is a state subject. More work on the health-related matter will be available at the state and district than at the central government, but we can facilitate working with the state and district level officers and teams that are identified under the program. NPCCS could help the interested IMD scientists to connect for joint work with district health department on local data sets to strengthen these plans. The program linking district, this program is also linking district to academic institutions like medical colleges, but we could also link them to additional institutions that was been talked about today, such as other universities and interested institutions of technology, so as to provide academic support on health and meteorology and their data analysis at the local level. Now, what are the gaps that we think that could be further addressed? Now, while state level information is usually available to us more easily, district and sub-district level information information, we do get some forecast data, but actual information would probably help us in better planning. It will help us in planning, important planning and functional units at the district level data. And also standardize the methodology to convert the recorded grid data to district level data. Then also certain parameters, as I said, that information is not available. We don't have information on heat wave days, severe heat wave days, and how long did they last. We do not have information like on heat index, heat and humidity index, etc. Also, the bulletin so far is only available for the period up to June 30th. But as we realize that not all parts of the country, the heat is over on the June 30th. Many parts of the country continue to report heat-related cases and heat-related deaths even after this crossover. So if this could be extended further, considering how different parts of the country are responding to heat situations, it would be helpful. And also direct early warnings to the health departments, state and district health departments on extreme weather events. So what are the data that is available in the health sector? There are some data that is actually a national level or a district level survey data, which is supposed to be very good quality controlled data. That is National Family Health Survey, district level health survey, and census data. These are the information which are quality controlled and are usually relied upon. Even with we also rely usually on these outputs. In the Ministry and the Directorate General, we at the national level do certain data collection. We do data collection on disease surveillance and disease outbreaks. We also collect information for specific health programs, and some of them are on portal, some of them are not on portal. But we do collect some information through this national program. But I again re-emphasize that these all information is being collected at the state level, at the district level. The national level, not all data that is collected at district and state level flows at the national level. So it is going to be better if the work is done at the lower level. On the cross-sectoral issues, of course, nutrition is a big issue. If we could work in climate and agriculture, we could understand where we need to address nutritional illnesses. Again, water quantity and quality has been impacted. So if we could understand their relationship, we could work towards on waterborne diseases. We also would love to have information on where do we have sunshine, where do we have cloud, so that we can think where we can install solar panels, for example, in our healthcare facilities. In terms of capacity development, understanding climate data and weather data is not easy for health professionals. So capacity building courses would be useful. So this is, once again, the expectation that I mentioned above. We do have technical expert group. Please be a part of it and identify people who can work with us in health sector to take this work forward. Thank you.
Again, a very good presentation and from the health sector. I think you will be here. I think I'm not to questions probably. Health is also an important. Of course, it's a state subject. So yeah, over there.
Thank you. That was very interesting to know the various areas in which you are already thinking and working. There were two major issues. The lack of data from the health sector could be, perhaps it was thought even earlier, that all the registration of the diagnostic laboratories be made mandatory, so that you don't know, you will not be able to probably assign the cause of mortality through that data, but at least the occurrence data can be easily obtained. That will be a massive data set that can be accumulated centrally.
Yeah. So I would only say that problem of health data is a chronic problem in the country, and for years the health department has been struggling to fight out this. But as I said, it's in the power of the states, because it's just constitutionally a state subject to design how they're going to their own data set. So you would usually hear that we do not make anything mandatory or do not notify things from the central level, because that's not constitutionally the power, unless and until there are some specific issues such as we had in COVID or other areas that we start coming from the national level. but we do promote the state governments and the district government to take up the initiatives. And it's not that the data sets are not available at the state level or at the district level. That's why I said, if there may be states that are doing better compared to others, if we go down and work with the states and the districts, you might find a huge amount of data and quality data that can be used to develop local services. And we at this program will be there always to support that partnership with the state and the district officers that are a part of our network.
That's a good point which over this place. We had serious problems. IITM has developed a model and IMD has developed a model. We wanted to have data from health sector. I remember when I was secretary, I wrote to ICMR that it's a NCDC center in Delhi. NDC or NDC? Yeah? NDC. So I wrote to the director of that, but we never got a response.
So I'm just giving an example of our own. I just talked about that we are trying to work with WHO.
But I tell you, if you really want to do climate services, unless you have this kind of data, nothing can be done.
So it's not that a service that
No, I'm not blaming you. I'm not blaming
I'm
you.
not saying about blaming. What I'm saying is that this work that we are planning on vector-borne diseases using WHO TDR tool of prediction of dengue outbreak, we have not approached the national body for data. We've gone and identified 5 state governments, identified our state level partners, and we are collecting data from them to put into this tool. So we ourselves sitting at a national program are not necessarily, because the idea is, if I go and ask the national program, the objectives of the national program do not align with my objectives. So the national team will be more focused on the reason why the program has been established. I need the data is definitely available, but the national team may not be so interested in sharing or thinking about the data with us.
When
But the
IMD
state
released-
government and the district government may.
So when IMD really starts the climate services, that's one of the points which they will be raising it. And also the registration he was talking about, when somebody dies, are the doctors really registering his death as related to climate? For example, heat waves. It's not necessary that he will die because of heat stroke. Heat stroke, typically they will say because of heat stroke. But old people who have pre-diseases will die because of heat wave, because his problems will get activated. But when he goes to hospital and dies, they will die natural death. But it's not like
I agree. Medical certification is a big issue.
So there are
in
some
country.
issues
Yeah,
which
there
are,
are issues.
we are not
But again,
going to
medical certification is also a part of another ministry. So vital statistics is not in the control of the ministry.
This is the problem. This is somebody's responsibility. That's the problem.
So things are very complex and difficult to address.
Yeah, I understand.
Sir, one issue.
Yes.
Sir, in your PowerPoint presentation, you have highlighted about the vector-borne disease. Sir also had IMD Pune has also highlighted that citizen can get the early warning system in case of malaria and the dengue. Then the issue is only the World Health Organization getting server, etc. What your experience or with the past experience? What the citizen can benefit from this early warning system in future? I was just the timetable when it can happen. Just it is a big eye opener for us, sir. My state, I am Tripura and belongs. There is some areas in tribal dominated area. There is a malaria is an issue. If you get the early warning system, like the what you are getting, the cyclone, etc., is a very, very benefit for the citizens.
I agree that early warning systems that are happening we are extensively making use of that. People had come forward and talk to our state officer and district officer on a webinar and was kind enough to explain the entire system. Now, like this program has been put into place, these officers have been assigned responsibility to work on extreme ability. They need to know what's happening. They need to know where they need to work for. And for that, this is coming very useful to us. But what I said is, you also need to go further. You also need to test the data against the data of vulnerability to these climate factors and see together how we can further improve it so that it becomes more adaptive.
Sir, we should, yes, Raju, I'll just reply your question basically. What IMD is giving regarding that warning, it is just like climate actually outlook for health. if you see that it is World Health Organization and they have some transmission window actually, what that transmission window, because it is vector-borne disease, Plasmodium virus, and so some temperature and humidity, they help that to grow that vector. Okay, so based on that, we are using extended range forecast. We are giving outlook for the temperature which help that is malaria outbreak. Okay, now for validation of that, what we have started 2-3 years back. Initially, we have started simply.
I think we can.
No, just what
please,
lag.
please,
What lag?
please.
So if we validate that with the data, actual malaria outbreak data, then we can improve further that, or we can better develop the transmission window better, because that is also varying with the spatial variability. For Tripura, for basically Odisha, we have started with Odisha state government, Malaria No More, and IMD, Pune, and this. So we are initiating that. We are doing some further improvement of that.
Yeah. Fine, fine. Thank you. Thank you. I think we'll move on. Very, very interesting discussion. But the next presentation is by Water, National Water Academy, SC, DS Chaskar.
Respected Chair, Co-Chair, eminent experts and delegates, good afternoon to all of you. All speakers before me has very well articulated the case for strengthening of climate services in India. They have also emphasized the need of joining hands together and working together by all the stakeholders to achieve the goal of climate smart society. Central Water Commission is also one of the stakeholder in this, which delivers hydrological services. So in my presentation, I'm going to highlight what are the services that CWC delivers, which are delivered in association with various organizations like IMD, state government, project authorities, NDM, etc. I will also highlight the issues and challenges that we are facing in delivering these services, and also the ways and means by which we can have a upscaling and improvement in these services. We all know the importance of water in our lives, for livelihood, for the ecology in which we live, and also for the socio-economic development of the country. That is why water management is also very important. But water management aspects, they depend on hydrometeorological data and climatic information. There is no aspect of water management which can be done without them. So whether it is assessment of water resources, whether it is a planning and design of hydro structures or water resources structures, whether flood and drought management, irrigation, drainage, water supply, water quality, fisheries, assessment of navigational potential, various studies, and most importantly, resolving interstate issues. As you might be knowing, most of our rivers are interstate rivers, and there are many disputes ongoing among various states, and resolution of this dispute also depends upon the historical data pertaining to rainfall, pertaining to river flow, pertaining to the water used by respective states, so on and so forth. CWC, as I said, is a premier technical organization in the field of water resources development and management. Apart from its core mandate of assessing, planning, managing, and developing water resources at a national level, it also has core mandate for delivery of various hydrological services. These are the core activities which CWC performs. First and foremost is a hydrometeorological data collection, including water quality and sediment, collection, compilation, analysis, and dissemination, flood forecasting services for all river basins of India. It is also a nodal agency for flood under disaster management. It conducts hydrological studies, morphological studies, sedimentation studies. It has also started glacial lake monitoring, coastal data collection, and of course, capacity building and training. The hydrological observations by CWC was started in 1950s. Over a period of time, we have increased our reach. As on today, we have 1,543 hydrological observation stations. These observation stations also have a meteorological observations. We have adopted telemetry in a big way. Out of these around 1,500 stations, 1,054 stations are having a telemetry. Apart from this, we also have 187 only meteorological stations. And the spread, you can see it on the map. The data that we all normally observe includes river water level, river discharge, river cross-section, water quality, suspended sediment and silt concentration, and also the meteorological parameters that we know, rainfall, sunshine, temperature, etc. These observations are different in different periods because in monsoon, we require more frequency of this data, basically to cater to our needs of flood forecasting. We started water quality monitoring in 1960s. And over a period of time, we have established about 782 stations at which we collect the water quality samples. We are planning to go more than 1,100. Not only we collect the water sample, but we also analyze that sample in the laboratories that we have established. 427 level 1 laboratories, 18 level 2 laboratories, 5 level 3 laboratories. And the result of this collection and analysis, and also the data that we collect for sediment, water quality, and discharge and level, etc. We publish this data as a water yearbook annually, and which is available in the public domain. For the last few years, we have also started monitoring of glacial lakes, particularly of the area more than 10 hectares. As you might know, as you may be knowing, glacial lake outflow burst is now a very common phenomena. Just 2-3 days back, we have an incident in Sikkim, and CWC station was the first to know about it because we have people at the remotest site on the rivers measuring the water level and discharge hourly basis, and that is how they came to know about that lake outburst, whereby the height of the water level went more than by 19 meters. So here we are monitoring about 902 glacial lakes, not only in India, but also from other countries, which might have some impact on our Indian rivers. Recently, we have started collecting the coastal data also, because coastal erosion is one of the mandate of our ministry. And the objective is to create an integrated data bank to tackle the coastal engineering problems, along with vulnerable stretches of Indian coast in a scientific manner. And the parameters that we measure are wave, current, tide, wind, coastal sediment, beach profile, bathymetry, shoreline changes. And these parameters are very important when it comes to have any structure for coastal erosion, to stop the coastal erosion. One of the other important service that we give is a reservoir storage monitoring. India is having numerous reservoirs, more than 6,000 large reservoirs India is having. Out of the total storage that these reservoirs contain, we monitor about 70% of it through 150 major reservoirs. We issue weekly bulletin, which is very useful for planners at the national as well as state level, particularly from the Agriculture Ministry and also from the Power Ministry, because they get an idea as to how much storage they have in the dams so that they can plan their cropping pattern and irrigation accordingly. One of the most important or crucial service that is provided by CWC is a flood forecasting. It's the only agency in India which gives flood forecast. It is given for 338 stations. We request state government as to at what station they want for a forecast. So right now we are giving 200 level forecasting. Level forecasting is normally given on a river where there is a city or where there is a big habitation. and administration would like to take preemptive measures if there is a water level is going high. Inflow forecasting is, as of now, given for 138 reservoirs. It is basically very crucial for operation of the reservoir. If the reservoir authority is in the knowledge that this much of amount of water is coming in the say next 7 hours or in the next 12 hours, they are in a better position to operate the gates. So total 338 stations are being operated by CWC. We issue two type of forecast. One is a short-term forecast, which is up to 1 day, and then the 7-day advisory forecast, which has been started with effect from 2023. Earlier, it was a 5-day advisory forecast. The flood forecasting network of CWC has rapidly increased. We were 1 or 2 stations in 1958, and now we are having 338, and we are planning to go to about 375 as per the request of the state governments. As you can see it here, most of the flood forecasting stations are on Ganga and its tributaries, Brahmaputra and its tributaries, and Godavari, basically because these are the most flood-prone rivers, and that is why in the states of Assam, Bihar, and UP, and also West Bengal, there are more number of FF stations. The forecasts are not issued throughout the year, but we have a designated monsoon period, and depending upon the rivers, we have a designated monsoon period. For Brahmaputra, Barak, Tishta, we have 1st May to 31st October. All basins, northern basins up to Krishna, we have 1st June to 31st October, and south of Krishna, 1st June to 31st of December. We issue forecast. For example, we issue red alerts with hourly updates, 3 hourly updates when the water level is above highest flood level. When it is a orange alert, we issue 6 hourly for when the water is above danger line, and yellow alerts whenever it is required. All the forecasts of CWC are instantly made available on the website. Short range forecast is given in this form, where you can see the trend of the water level. This is a snapshot of dashboard which gives the flood forecasting bulletins of CWC. We know that short-term forecast has its own limitations, basically because it has a very short lead time. It is based on the reach approach of the river rather than the basin approach, and it doesn't give much lead time to you when it comes to small, hilly, and flashy rivers. And that is why we always try to increase our lead time, and that is why CWC is also issuing forecast based on the hydrologic and hydraulic models, and by taking the 7-day forecast given by IMD to issue 7-day forecast for all the rivers of India and for all the 330 stations. So this way we have increased our lead time to 7 days. We are not dependent on the river gauge data, basically because these models, which have been totally automated, they cull down the data from online sources for the next 7 days or for the next 7-8 days, and also for the past few days. The model is run for the actual data available for the past 2 or 3 days, and then it is extrapolated based on the forecast for the next 7 days. The model is fully automatic. No human intervention is there. It calibrates on its own. And this model results are also available on the CWC website. There you can see different colors, pins with different colors. And when you click on any pin, you will get this kind of information about that particular station as to how this is receiving rainfall from various tributaries or from various other stations or rainfall stations, and how that rainfall is getting translated into runoff or a hydrograph in a graph like this. So CWC has 36 divisional flood control rooms across the country, which are 24/7 during the monsoon period. They collect data from our own sites regarding water level, rainfall, discharge. The flood meteorological offices operated by IMD, there are 16, I think, total. They give specific QPF for our divisions, basin and sub-basin wise. And this data is utilized by these control rooms to give short-term as well as long-term forecast. This data is also go automatically because the data that CWC sites are providing, it is instantly entered into the database, online database in real time. And that is how that particular model that I was talking about, that also pulls the data from this system and runs it. The information about the forecast is disseminated almost in real time, specifically through email, SMS, websites, and WhatsApp for the specific groups that we form. And it goes to our website. I have given the address of these two websites, Flood Forecasting System of India Water gov.in and Advisory Forecast. Recently, we have launched an in-house app called Flood Watch. The whole information of CWC forecast is available on a fingertips through this app. It has been recently launched in the month of August itself. And short-term, long-term, all forecasts are available. It also gives you the state-wise and basis-wise forecast. Now, the challenges which I want to talk about is when our flood control room is preparing the forecast, they have to get a complete picture of the basin upstream of that forecasting station. So there are plenty of agencies which are collecting data: IMD, CWC, state governments, dam authorities, and other project authorities, powerhouses, etc. Now these data is in a different sources, so they have to first compile the data. Then only they can get a complete picture. So the multiple agency or multiplicity of the agency is one thing. That is basically because I have to bring all those agencies on board on some common platform and take the data from them. Secondly, each agency has their own database. So our people has to convert their data into our usable form so as to draw some conclusions out of it and prepare the forecast. Then validation and calibration of model. As I said, the model that we prepared for the advisory forecast, that runs automatically. But at our level, when we do it on our own, calibration and validation is always a time-consuming process. As you might be knowing, that efforts have been made by Government of India under National Hydrology Project, which was earlier called as the Hydrology Project Phase 1 and Phase 2, to synergize the data collection and data compilation work. And IMD is also one of the agency for in Hydrology Project. Government of India has recently established National Water Informatics Center, NWIC. It has been tasked with a responsibility of synergizing all the stakeholders which are collecting the water information and hosting it in one single portal. So this NWIC has now created a web portal which has 4 components. WIMS, Water Information Management System, is basically a one-stop data collection platform. India WRIS is a one-stop data dissemination platform. SWIC is a platform for getting states on board so that the SWIC can be coupled with NWIC. Water and Allied Resources Information Management System is also there, wherein we are trying to collect and collaborate with other institutions like agriculture, etc., so as to get the data regarding cropping pattern or parameters which are useful for the agriculture. So initiative has been taken by the Ministry of Jal Shakti in creating a common platform for data entry as well as for data dissemination. Now, one issue that we always face when we conduct our flood forecasting tasks, short-term forecast is only for 1 hour, for 1 day, and it is based on the base station. How much water is coming from the base station, and we predict what time it will take to reach the forecasting station, and whether it is a city or whether it is a reservoir. But then the lead time is very low. The long-term forecast that we give, 7-day forecast, it depends upon the IMD's forecast for 7 days. So obviously there are inherent limitations. So what happens is the authorities to which we give this forecast, they tend to believe or follow only the short-term forecast. They don't really operate their dams, or the district administration also don't really take measures based on the long-term forecast, because they say कि long-term forecast तो पता नहीं आएगा, उतना पानी नहीं आएगा, there is a uncertainty. But short-term they know कि इतना पानी बताया है तो आएगा. So what happens is there are problems in the reservoir operation. आप लोगों ने सुना होगा जैसे केरला flood की बात हुई थी. When Kerala flood happened, it was said to be a man-made flood. क्यों? क्योंकि gate जल्दी operate नहीं किए गए थे. Now recent example on 16th and 17th, when Narmada floods we got, I myself is in charge of the flood forecasting for Sardar Sarovar project. So on that day, there was a heavy rainfall in the catchment area. The project authority did operate the gate, but Bharuch was still inundated. the Western Railway was suspended for about 12 years, 12 hours. It never happens. Why that happened? Basically because even though there was a long-term forecast, the project authority did not act on it. They are always looking for the short-term forecast. उनको पता है इतना पानी आने का इन्होंने short-term बताया उतना तो आएगा, but long-term की इसमें believe नहीं करते. So what we are trying to do is we are trying to extend our short-term forecast by few hours further. How that can be done? That is possible by having a rainfall runoff model for the basin or sub-basin which is upstream of that particular location, and then gauge to gauge correlation is to be added so that we will get some extra, 3 hours or 6 hours or so. So they say, one of the speakers said that even 15 seconds are very important, and that is what we realize number of times when we do the forecast, that a 1 hour of time or 2 hours of time to the project authority sometimes is very important. So our purpose is to have a rainfall runoff model for the basin, but then we should get a complete picture of the runoff rainfall that as it is happening in the catchment area. So we have a rain gauge network. We also take your data, but then this rain gauge network may not capture cloudburst scenarios or highly varying rainfall pattern. That is also one of the big tasks for us. Many times what happens, we give the forecast, this much water will come, and then reservoir people say, "Arey, इससे ज़्यादा आ गया, कैसे कहाँ से ज़्यादा आ गया?" Because there may be some area where the cloudburst happen or the variation of the rainfall was not captured by the rain gauge network. So, and secondly, the frequency of rain gauge observation. Many times the rain gauge observation is 2 hourly, 3 hourly, or in case of state government it is once in a day. Yeah, I'm just coming to an end. Once in a day. So another issue is with the telemetry stations, because whenever we increase the density of the telemetry station, there is always a issue of reliability in respect of telemetry data whenever there is an extreme event. Suppose in Bothale last year, on 7th of July, there was a rainfall of the order of 600 mm in 24 hours. Now, because our people are there, they know 600 mm ho gaya sab yahan pe. But had it been a telemetry station, we would not have believed. We would have thought that telemetry ho sakta hai, kuch gadbad ho gayi hogi. Because in the adjoining area, it is only showing 50 mm or 100 mm, and in one station it's showing 600 mm. So even telemetry becomes unreliable. How to believe it in case of extreme scenario is always a issue. So our suggestion is, we should have a radar network which will capture the rainfall as it is occurring. Okay. Then the radar network should have a higher density and also the higher frequency of or higher resolution of measurement. We can have radar with rain gauge or telemetry data. We have many data merging methods by which both of them can be correlated with each other. We also have a problem of urban flooding nowadays. How to address urban flooding, though the reason for urban flooding are mostly the city development and the drainage congestion, but then can we give some advance warning to the people of a city that heavy rain has occurred and you should avoid these areas? Here also high resolution radar, rain gauge data merging can be useful. One example which I have taken is a Japan example, wherein the whole country is totally covered by overlapping radars and also a rain gauge network, and they are automatically synchronized with each other so that they get complete real-time picture of what is happening at all the places. CWC is also working closely on the inundation modeling, because that is what most of the state authorities are demanding, because they want to know that how much area is going to be submerged today, tomorrow, day after tomorrow, and we are working on that aspect. One of the issue which I wanted to highlight, that how we can achieve public participation in flood management, particularly for data collection. One of the issues which was highlighted by 2-3 speakers was capacity building. National Water Academy, which is a part of CWC, is located in Pune, and we conduct training programs specifically for state and central government officers free of cost. We are also a recognized WMO regional training center since 2012, and we have conducted numerous distance learning programs in association with WMO. We have trained about 750 officers, hydrologists all over India and also for the abroad. And right now one program is going on which started just day before yesterday. 150 participants are there, including 30 participants from international members of the WMO. So I was talking about the inundation modeling. CWC is also working on it. Thank you.
presentation from water. Any question, one question? You are a water man.
It was a nice presentation, sir. I represent Government of Kerala right now, but I'm a professor of water resource engineering in Madras. I have a couple of comments, observations rather than questions. Primarily, when you give the forecast, see, the flood happens, but as a researcher, I would like to know the data immediately for analysis and purposes. But when we approach the gauging station or the CWC office in state, they say it has to come from the center. They are not in a position to disseminate the data unless there is a consent from the headquarter or the regional office. Can this be waived?
Actually, all forecasted data, flood forecast data, including the water level.
Not the forecast I'm talking about, the observations.
Observations for the other stations you are talking about. But there is a very well established procedure actually, because there is a data dissemination policy, and under the data dissemination policy, the data is given free of cost. The only thing is there is some paperwork you have to apply to the regional chief engineer. Okay, as if, like I'm having the additional charge of a Gandhinagar office, so many requests is received at my place, and it's only a question of 1 or 2 days by which I approve this thing. There is no.
It's not 1 or 2 days. That's the reason I'm raising this concern. I had a problem in Kerala when 2018 flood happened. 2019, 20, and 21, there were a lot of. It was not devastating floods, but when I wanted to get the data from the CWC station in Periyar River, it took around 7 months to get it.
No, that's bad. No, but that's not the. That's not the policy. I think that may be kind of a lapses on the part of that local office.
It's a concern which you can answer.
But you can always seek the remedial, because there is a proper data dissemination policy, and you should get the data free of cost.
You mentioned a lot about telemetry and your network, observation network, calibration.
In fact, many of the IMD sites are maintained and operated by CWC.
So what I suggest, because you are in Pune, so we both are Punekars, I would suggest that maybe sometimes your office or maybe we can have interaction half day, and we can definitely talk on this automatic weather station. That how we can improve your technical resources or technical inputs we can improve. Maybe we can
Sure.
Yeah, thank you so much, Chaskar sir, for the nice presentation.
Thank you.
And I completely agree with the rainfall runoff modeling that you mentioned. Only one thing, I mean, most of our catchments are highly engineered in that ways. We have a lot of check dams, reservoirs all across. Now, to get a proper rainfall runoff modeling, irrespective of the model we can use. I mean, we can use SWAT, we can use VEEP, we can use HACRES, whatever we want to use. But because they are so much engineered, and not all the reservoirs have a gauge network present. So I think one of the first step is also to strengthen the gauging itself in all those small reservoirs that are there, so that when we are making the rainfall runoff prediction, I mean, it cannot be represent the virgin condition, but still it can improve the way we are estimating the runoff that might be generated.
Yeah, increasing the gauging network is one thing. That's why I suggested the radar, because once you have a radar, high density radar, then there is no, you can get the complete spatial and temporal distribution of the rainfall, which is much more accurate than your, rain gauge stations.
So I have, before I say call the next presentation, I have 3 comments. One is, of course, we did not discuss anything about climate services beyond 4 to 5 days. Whether are you interested in, for example, extended range forecast, seasonal forecast? So that kind of aspect you did not discuss. Number one, and that is the purpose of this meeting. Weather services.
Basically because
that's fine. We'll discuss it. And second thing is, it's good that you are coming forward to work very closely with the IMD. Morning, Rupa Kumar was saying that in many countries, it's a national meteorological and hydrometeorological services together. In India, it is separate entities. IMD knows how much water is coming from sky, and afterwards IMD doesn't know where it goes. Whether how much water is flowing, how much water is going inside, we don't know. Because it is handled by CWC. And CWC also doesn't know how much water is going inside the ground.
No, that is why I told that NWIC is now becoming a single platform where CWC, CGWB, state government people, and all other agencies also are supposed to enter their data.
So my point is that all agencies should come together.
Yes,
Otherwise,
yes.
the hydrology.
Yes, 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 yes. Yes.
We should come together to solve the problem.
Solve the problem. Yes, and that is what I'm saying. That's why I specifically included a slide of NWIC because that was very relevant in today's, deliberations.
You must be knowing the big river in the US, Colorado River. There are a lot of dams, a lot of water supply is used by for agriculture, but they have a beautiful river flow management system.
Yes,
Beautiful
yes.
system, purely science and
Yes,
technology.
yes.
Why we cannot, if they can have, why we cannot have?
Yes, and that is why our ministry is proposing a river basin management bill. One act which is bringing so as to manage the rivers as a river basin as a whole rather than in parts, because that is what happening today. Yeah.
Sir, one comment, sir. Sir, one comment.
Yeah.
Regarding this, your comment about this radar and rain gauge merged data, I just want to give you some information that NCMDL is now merging the radar and gauge data plus satellite data with 15 minutes, 1 kilometer product.
1 kilometer.
1 kilometer product.
Because
Yeah.
I think the picture one I showed,
Yes.
it was switching from 1 kilometer to 250 meter.
Okay.
To get a closer, resolution, particularly for the city area.
Yeah, but what I'm telling is we are already doing that radar and rain gauge
Merging.
merged product actually, MERA product, and it's already operational.
But
in
I think
real-time basis.
my suggestion was to increase the radar coverage,
Yes, sir, of
because now when I have to give a inflow forecast for the Sadas River, I don't have any radar there, which I can use to this one. Yeah. Thank you so much.
Now we can go to the next presentation, Climate Services for Energy by Dr. Goutam Das, National Power Training Institute, Ministry of Power. Dr. Das, please.
Yeah, good afternoon to all. Unlike all the speakers before me, I'm not so knowledgeable. I have little experience, so I may upset you, but at the same time, I'll release you sooner than you expected. So I'm representing National Power Training Institute, Faridabad. Just a month back, actually, I was with Power Foundation of India as a chief data scientist over there, and I did work. I have gathered some amount of experience in using IMD's data, which was very critical and crucial for my analysis and coming to the conclusions. And in this regard, yes. I'll be love to be challenged and cornered, because that's the way actually I learn. And what I can tell that how the climate data is being used, and I'm primarily not a power guy. I'm more of a data scientist. But however, being in the power industry for some time, actually I learned a little bit. Let's see that how I could make sense to you all. Did I press the other one? So it was not one side. It was, and I did. Acha, this one. Acha, okay. So primarily, we are using the climate data along with the other domain data to help us take the decisions. In this context, actually, I should say the meteorological data is pretty crucial for us, and it's all the way from planning and then generation and operation and maintenance. In the power planning section, starting from the infrastructure planning, recently actually we were into actually forecasting the power peak demand as well as that energy consumption forecasting for coming 25 years for our nation. at India level as well as state-wise for each state, which will help us actually plan for our infrastructure, be it generation, transmission, as well as distribution. But more importantly, in today's context, actually, when we are thinking of actually green transition, energy transition, there actually it is not only the total demand and the peak demand, I mean total energy consumption and the peak demand. At the same time, actually, how we can leverage the renewable energy for a green transition. So that means it's the mix and match of the different sources of energy is another critical aspects which actually got added to, which were not so critical earlier. So in this context, actually, while talking about the planning, obviously one of the major plans actually in today's context to our nation is actually infrastructure planning, and that's what nothing but actually investment. So we are actually struggling with the investment not only for foreign, so where we are trying to understand that what will be the investment from the abroad, but also we are finding that our own investors in our own country actually is not so courageous, or I should say is not courageous or not attracted to actually invest in this context. And that's actually helping us actually not go ahead with that actually plan we are making, that we have got to make some 400 gigawatts in coming 7 years, which is a question now. Time to operate and market, naturally, unless we can actually make our infrastructure ready and active or act on action. So we are not able to complete, I mean, with confidently we can actually claim that we will be able to meet our target. Payback period and the feasibility, that's cost benefit analysis is going on along with that. So next is power generation. The moment actually we are done with our infrastructure planning and actually accordingly actually we invest and get our stuff done, then in the generation part actually based on that climate data actually people can understand that what's that long-term and short-term forecasting, and based on that actually we can go for our procurement of the raw material and the resources readiness and manpower buying. Coming to the operations and maintenance, it's including power trading, because very recently actually I was working on actually power trading part, and where actually you must be knowing that most of the I do not know the representative from the power industry over here, but very critical part is that actually we do have actually power PPA, that power purchase procurement, power procurement agreement, which are generally 15 to 25 years long. But in today's world, actually, what happens? For example, actually, for in the case of actually solar power, so when a couple of years, I mean, maybe 8 to 10 years back, actually, when people actually signed at a cost of actually 8 to 12 rupees per unit, whereas actually today it is available 2 to 3 rupees per unit. Now that's where actually people are struggling today. At the end of the day, who are suffering? The consumers are suffering. So that's another area actually where actually a lot of things are required. And going forward, primarily when we are trying when I was working with the Central Electricity Authority, so our objective is for our nation actually to make the more secure power, more cheaper power. Then we are thinking of actually bringing more power into the exchange. We are not able to do so because of the long-term actually power procurement agreement, and that is where actually if we can make the consumers actually, or if we can make the buyers more confident about that exchange, about that availability, then probably we can make more sense actually, where we can see that volume in the day-ahead market and the real-time market will increase, and it will help us actually our consumer folks, because this is a very gray area. What we find actually because of the primarily the supply constraint conditions, that means the total supply that's being offered on the power exchange is more than that of is less than that of actually the minimum power that is being asked for the purchasing. So it is less. Then what happens in that supply constraint situation? What happens that power price becomes a cap price. In India, actually, sometime back it was actually in the day-ahead market it was 20 rupees per unit. Then actually 12 rupees per unit. Currently it is going on 10 rupees per unit, and that is what. In some of the countries, actually, it's pretty dynamic, it's pretty actually open market. In Indian context, it's not so. But that is where another area where actually we can work on. Quantity-based demand, including asset management. When you talk about asset management, naturally, We can think of the preventive maintenance, reliability through reliability analytics, and sell and buy decisions, as I mentioned earlier. Okay. Just a small, actually, in Indian context, actually, we can harness the blessing in disguise that India, because India is a vast, diverse country where actually the time difference between east and west actually around 2 hours. So, a little slightly more than 2 hours. So, when in Arunachal Pradesh, actually, it is actually evening, and that is in Bombay or Gujarat, it is not so. So, what we can do, we are having transcontinental actually transmission through international transmission grid, but India actually from we do not need to export, we do not need to actually store the energy, we do not need to store the energy in through battery or hydro. We can very well actually pass on our energy from our neighboring states or cities, so that way we are blessed, and we can if more that if we can predict our climate data more accurately, we can plan that also more accurately, and we can make benefit out of it. These are actually the different climate impacts actually on energy systems. That means the better actually we can actually forecast and get the data from IMD, so probably our nation can actually help us. But whatever I have talked about, it is only related to power sector. So we have temperature, so turbine production, efficiency, demand for cooling, heating, AC and heater in different states and different cities, rainfall, how the wind speed actually will help us actually predicting actually, not predicting, planning for our potential actually generation, wind energy, solar generation for cloudiness, snowfall, ice. It's not so much actually important in our case actually. Humidity is very critical actually. When I was trying to predict our national and state-wise for coming 20 years, as well as when I was doing it for Delhi, the city, for 1 year, day by day, there actually, there's a, I'm pretty sure most of you are aware of actually that apparent temperature. That means the combination of the effect of temperature as well as humidity together on human body. So we were working on it, and there are some challenges. There are some thumb rule globally accepted by NOAA. But challenge is that for India, actually, we are yet to come out with that threshold figure at which actually people start actually switching on the AC, or at which temperature when it goes below that people start switching on the what is it called heater. So that is another area actually still can be worked on, because so far actually the literature doesn't come to a very conclusive figure with which actually the prediction can be done for Indian power energy sector. Then other stuffs are actually river flow for hydro generation, coastal wave height, subsurface soil temperature, flood statistics, drought statistics, storm statistics, sea level. Actually, sometime back actually people did talk about actually sea level stuffs. So I just took some few of them over here, which actually we work. Load forecasting for distribution and generation. Both the distribution DISCOMs and the generation, they actually plan, and not only it's a plan actually also for, as I told, that the power purchasing is a major actually activity, and so it helps us actually planning, actually operating in case of hydraulic power also. The hydraulic power generation depends on the water availability and the prediction patterns. Data including rainfall, snowfall, helps hydropower operations manage reservoir levels in collaboration, of course. In this case, actually, you see what we do actually when we are trying to think of actually making the best mix out of it, or best efficient or effective result for our nation. Actually, we keep some of the sources in dormant state. Actually, when there's a requirement, then we'll put them up, and when actually hydro is something, actually immediately you can put it up, whereas actually in case of thermal power it takes some time. So and in very emergency you'll go for gas, because gas is very expensive. Okay, I mean, the thing is that whatever I'm talking is so obvious things that I do not need to tell you, because you people know more better than me. Renewable energy forecast, actually, yes, it is today. What we are actually in the renewable case, actually, we we are in a very nascent state. We are working out, Government of India, Power Ministry is working out the various American, what is that called, laboratories or the research organizations to understand that our potential. So in this context, actually, one of the small things actually I can talk about, again, actually coming from more from the data scientist perspective. I mean, suppose from the satellite image, if you can actually understand the various parallels, and then if you can understand, we can do that, we can evaluate and assess that cost-benefit analysis about that, feasibility of that, having actually solar pumps or wind energy, because it's a very costly affair, and we need to understand because the capex is high, even though actually it has lowered down, but we are expecting much more to lower down so that actually our consumers get benefit out of it. Transmission line maintenance is a major thing for the transmissions. There are two aspects of it. Temperature actually, even though actually, try to understand, even though actually our transmission lines and all, actually when it was built, it has enough actually buffer. But I need to understand that the way we are actually growing, our economy is growing, our electrification is growing. Because of that, actually our capacity of the transmission line is in question. And because of that, actually, and on top of it, the temperature goes high, and otherwise there is also a concept of actually creating a capacitance between the transmission lines and the ground. It creates a capacitor, and that capacitor actually fluctuates actually the voltage, and those are some of the nuances and challenges. It's a purely technical, electrical engineering, but those are the aspects to be considered when you are like if you are not properly, thoroughly actually understand that whether impact on the transmission line also may become an issue. Energy trading I talked about. Trading market actually, again I'm telling, very few percentage of our total power is being actually traded through actually exchange. Where the challenge of it probably we are, if you can appreciate it, the challenge of it today, we are not in a position to understand our price of our power because of the long-term power agreement. The real-time market price is actually not evident to us. Today we do not know. If somebody asks what is the price or what should be the open market price for Indian power, we are not in a position to answer because most of our actually price is dictated by our actually long-term actually power purchase agreement.
Yes, sir, please conclude.
Yeah. Oh, couple of stuffs actually which are nuances in this context. Actually, very recently we have started working on. I just take 1 minute. Okay. Smart meter analytics. That is where actually we will be fine-tuning our planning for future infrastructure and effectiveness of the microgrid and net export-import. And it's this, we are talking about the net zero stuff. And there are a couple of things people talk about. And in this context, actually, I'll just touch on that. The green energy transition, where actually we are working on the green taxonomy. So green taxonomy actually again needs the climate data to understand and appreciate our future potential and all. We are yet to come out with a green taxonomy in case of India, where European Union, China, UK, Canada, Australia, Japan, South Korea, Singapore, they have done. And last one I'd like to tell you that AI and machine learning, how it is using the climate data for the benefit of the consumers and the benefit of the stakeholders is that we are using AI and machine learning for explainable AI. The reason is that because of the climate data, the more accurate climate data is that, the more actually confidently we can tell this will be the price of the things, this will be the amount of potential, this is where actually we are going to make outage and all. So trustworthy AI system for the mission critical decision making can be done in case of explainable AI. In case of AI at speed and scale. So now, when we are doing the image processing, the way actually today IMD is receiving the data and passing on to it, that the speed actually, that the velocity of the data will help us. We predict the stops in more real time, and that will help us in actually taking the decision. And last one is the Edge AI. That means that the Edge AI, I just took an example, is primarily for the RTM. That means real-time data, real-time actually market and day-ahead market and all. If we like to purchase the or sell the power in 15 minutes block, also can be done. Actually, that means the AI age. That means that the age, our data should be available, and I should be able to make sense out of it. And with that, I'd like to end it, and we can actually talk over the cup of tea or during dinner. I know that the time is a constraint over here, so I do not want to delay for the rest of the people.
Thank you, Dr. Das, for your nice presentation. Any quick questions, please?
Thank you, Goutam. You mentioned about the transmission lines. Probably in India, the losses in the transmission line as far as the power is concerned is the highest in the world. Maybe something like that, 23% or something. Whereas as compared to in US, it is just 2% or less than that. Maybe whatever we generate, 25% of that is not getting used. And there could be many reasons for that. We'll elaborate the reasons later on. I just want to understand that, India being the tropical country, we have a lot of potential for the solar and the wind energy. So definitely there is a, calculation on all this, the potential that how much energy, solar or potential energy it can generate. And if this can be taken up in NFCS or with some collaborative work, already there is work, we can start this type of work. Based on the climate data, what is the solar potential or what is the wind potential that a particular place we can have. Maybe, this type of assessment will bring forward certain industries, to come forward, to come out with their project, come out with their installations, come out with their, the grid network available. And last point, the demand forecast, which I'm talking, like, based on day-to-day, weekly and seasonal demand forecast. Because last minute trading online, I see that, on the SCADA, when you do the last time trading, the rates are very high and to avoid the outages. So maybe if you have a proper demand forecast made for the power generation, maybe this type of, finally it will go to the consumer. So this also can be avoided. Maybe these are some of the points, maybe we can discuss for the cup of tea or something like that, or whenever you want to respond to it. Thank you.
Yeah, I'll be more than happy to discuss with you because there are two aspects of it. One is that actually I'm in touch with a couple of US-based actually transmission organizations where actually in India they can actually, the couple of actually US-based organizations is started operating in India. So they are actually, I'm in touch with them so that actually we can use this data, and climate data is one of the critical input for them. And secondly, you are talking about that solar and wind energy potential and all. In this regard also, I cannot take the name of that organization, but Minister of Power, with the help of some of the nodal agencies, actually are collaborating with a couple of US actually labs. So in parallel, I don't think why we should not actually collaborate. Actually, can be done with lesser. It will be more cost effective and more realistic for Indian. Because I do know the challenges actually we are facing while collaborating with those US-based companies.
Sir, one clarification on this thing. ISRO has developed a solar potential app. I mean, covering the whole country using the INSAT data. Any point of the country, we can know what is the sunshine hours available, what is the solar potential. I mean, installation coming over there. And if you put a solar plant there, what is the output, how much power it is going to be available, that is already available. And also a mobile app is developed. All this forecasted, this thing, it will be available on Veda's portal of Space Application Center, Ahmedabad.
Excellent.
And based on the Prime Minister's PMO advice, this app has been now extended to the global calculator. Okay. It's globally all areas is being covered. That also is going to be inaugurated by PMO.
My only question will be that what is your forecasting period? I mean, how long actually?
So that you can discuss in detail. Okay. Yeah. Okay. Thank you, Dr. Das. So next, let's move to the last presentation of this session. Climate Services for Disaster Risk Reduction by Dr. Anshul Agarwal. Regional Integrated Multi-Hazard Early Warning System for Africa and Asia.
Good afternoon, everyone. So, first of all, I would like to thank Hosalikar sir and Dr. Satyaban for inviting me here and for giving the opportunity for presentation. So, basically, our organization has a slightly different context than what we are hearing from morning, because we all are the national agencies, but our is more intergovernmental and international organization. So, currently, we are working with almost 45 countries across Asia Pacific and the Africa, Asian in the Pacific region. So, for before going to my actual presentation, I'll just like to give a brief context, because since I'm talking with most of you since morning and many of you don't know what RIMES is. So just giving a small introduction, that RIMES is a international intergovernmental organization which is managed by its member state, and it was established in 2009. And basically it's regional because we have many countries across these three continents. Then it's integrated. Our main purpose is to link the application of science with the users of early warning systems. So that is the main purpose, like where our role comes for. Like we were part of GFCS implementation in South Asia. For NFCS also, we can see a lot of role for us, like which we can play and support different organizations here. Then we work for the multi-hazard context. Like when RIMES was established, it started for earthquake and tsunami services, but it has expanded to many hydrometeorological hazards. Then our mandate is to provide the early warning services. Like it's like what we are doing is we are enhancing the preparedness and response and mitigation measures. So for that, we are providing the support to the countries. And this is a system like where we connect our regional technical support unit with various national and local systems to provide this kind of services. So these are the countries where we are working. So we have right now 22 member states and 26 collaborating states. And currently, like for RIMES, since it's an intergovernmental organization, so we have a council which Dr. Ravi Chandran, our Secretary for Ministry of Earth Sciences, is the chair for this, our organization. So basically, I just want to highlight few collaboration which we have with various our technical organization in India, especially with the Ministry of Earth Sciences. So we have a very working relationships with IMD, INCOIS, NCM, RWF, IITM, where we are taking their various state-of-the-art products which are available. And basically these organizations, when they produce or run the models, develop this data. So that is not only for India, but for various countries. But there is no specific mechanism to take this data to the various countries, for various agencies, for various sectors for application. So where RIMES play a very important role, where we are taking these products, and not only the products, like India has a lot of capacity for running various kind of models and generating different products, tools for disaster management, for the early warning services. So we also help in providing the capacity building for these countries. So some of the examples of this support are like, as we heard since morning, there is a South Asia Seasonal Climate Outlook Forum. So we collaborate with RCC Pune to organize 3 sessions of SASCOP every year. And there are various tools have been developed for generating this seasonal outlook, as well as there is a established climate services user forum. So every time, like we have many representatives from the agencies which are present here, but we wanted like more involvement of these sectors in these products. I think RCC is doing a lot of efforts for that, and this National Framework for Climate Services is one step forward for that. Then we also established the regional observation networks, like with support of INCOIS. We established some buoys in the Indian Ocean region, so that don't only help the countries where it has been established, but it's also provide the data from these countries, which is being used by the agencies in India to verify our forecast as well as make use of it for early warning services. Then for GFCS implementation, so RIMES was the partner with WMO for its implementation in the South Asian region. And there we did one piloting of the Climate Outlook Forum in India, in West Bengal, in UP, with support of BHU, Varanasi, we did that. So that there is like the context for that is that we need these kind of services, but we have a different climatology, and India is vast country for doing this kind of services. So for that, we need support from various state governments. So I think we will hear it in the next session. Then we also did various pilot projects on application of seasonal and sub-seasonal forecast at the farmers' field level. So there we did one pilot project in Bihar state in India. And also we are running some of the specific trainings or programs for application of the different range of forecast products for the risk management in agriculture. And we did that kind of trainings in India, in Tamil Nadu and Bihar states. Then we also developed some decision support systems for agriculture sector, which was piloted in Tamil Nadu, and later on it was adopted by IMD, and it's now the operational system at IMD. And we are also we have developed some decision support systems for disaster risk management for Tamil Nadu and Odisha state that I'll discuss a little bit in detail during my presentation. So basically, since my topic for this session is for the user context or user perspective, so I wanted to bring this, but we have heard this a lot since in morning from all the presenters. So basically, the most important part when we talk about the user's perspective, so important is to go from the bottom up approach, right? We have very good high quality products coming from different kind of state of the art models, but the main purpose or main utilization of these products tools is when it reach to the end user, the person who actually need this data, this information. Okay, so for that it is very important to understand the user demands, the precise information which they need, and the kind of language and the way we can deliver so that it actually reaches to the end users. Okay. Then we need to assess the different kind of products and services which are available with different agencies. And I'm actually very glad to know different kind of agencies are producing different data, especially ISRO and all have different kind of products which can be utilized here. Then we need to perform some specific research, like when these products are available, though how to bring these products to meet these demands. So we have demands, we have products, but how to match those? So that is something where this NFCS can play a very important role, and where the agencies like RIMES play a very important role also in India as well as in many countries. So for that purpose, we can develop the tailor-made decision support systems, which can help for the operational support for different agencies. And this helps to bring the research to operations. And for that, we need also various kind of trainings and capacity building activities with users so that they can specifically understand these demands, products, and take it for use. So moving forward, so I just want to give the example of some of the decision support systems which we have developed in India. So we started piloting this with Tamil Nadu state, and where we have a decision support system which is known as in short Tamil TN Smart, that is System for Multi-Hazard Potential Impact Assessment and Emergency Response Training. So what does this system does? Basically, it provides the information from the different range of weather forecast up to sub-seasonal and seasonal forecast at one platform, as well as it has a lot of information from the ground level. So it provides all this information at one platform for the disaster managers to make their decisions in case of various kind of emergency events. And same kind of system we have developed for Odisha state, that is known as Satar. So these systems have been contextualized basically based on the requirements from the disaster management agencies in both these states. So in Tamil Nadu, we are working with TNHDMA, and here we are working with OHDMA to develop this the system and what kind of information will come here. And for that, then we are collaborating with our agencies like IMD, NCMW, INCOIS to bring their products and services to these tools in the way these the disaster management agencies require this. So basically, the main purpose of developing this tool is the main objective here is to develop an operational information decision support system for policymakers, disaster managers, and the communities to manage the disaster risk holistically by transforming different range of forecast into actionable and impact-based early warning. So that is the main objective of developing these systems. And here we are utilizing the cutting-edge technologies, advances to facilitate the decision-making process during all phases of disaster management. That is right from early warning to preparedness to emergency response, mitigation, and recovery. So there is the data coming from different agencies, from the science-based agencies, from the revenue department, from state disaster management agencies, as well as a lot of information about what kind of response mechanism is available in the state, in districts, at block level. So all that information has been brought at one level so that it can help during different phases of the disaster management. Okay? And the main vision for this, which has been given to us by the state disaster management managers, is that to make this these apps as this decision support system as one-stop solution for all information generation, processing, analysis, and dissemination by integrating different kind of tools, data, best practices which are available at one platform. Then the focus to focus and integrate the most critical and priority hazards and impact-based forecast generation process for that particular states, districts where we are developing this. Then to support an establishment of a technical wing for HDMAs to support operational, to provide the operational support during emergencies, and also to work for further development, understanding, and integrating the specific sector demands, and also the dynamic risk management, dynamic risk assessment for different conditions, and to bring innovative technologies and redundant communication system to maximize the reach to the last mile. So different kind of processes like CAP we heard in the morning, cell broadcasting, app-based alerts. These things have been integrated into these systems to make the to bring different technologies and make dissemination more effective from these. So for this, the decision support system which we developed, so specifically these are the integrated platform. These have been developed as an integrated platform for disaster response, which has the disaster risk profile. So the information which you are seeing here, we have the disaster database for each district and block levels available in India. So those has been brought to this particular decision support system which has been developed. So all this profile has been digitized and brought here. It also has the assessment of historical disaster events which has occurred in the past. Then it brings the real-time monitoring of weather parameters into the system. It also provides the short-range, medium-range forecast and extreme weather alerts. Then there is an option to analyze the evaluation of the forecast performance within the system. And also it generates the risk information which is based on weather forecast at different time scales. Okay? So then it can generate the color-coded maps and also generate the specific advisories and alerts for different locations which are being provided to the disaster managers, and then they can take the decision to disseminate it to the public. Okay? And it also integrates the response and resource allocation options based on what all the facilities, resources available within the states, different districts and blocks. So for that, there are, for TN Smart System, there are specifically 14 modules, and these are developed based on the preparedness. So what kind of information is required for the preparedness? There are different modules to integrate that information. For response mechanism, the different modules has been developed for recovery and mitigation, as well as for the integrated modules which integrate all this information to provide the holistical approach for this particular disasters. Same way in Satark has been developed based on the different major disasters which occurs in the Odisha state. So these modules have been defined for different, based on the different disasters. And for all these disasters, the similar kind of information has been integrated into the Satark system. Okay. So basically these systems are providing a comprehensive platform for data analytics, which help us in descriptive analytics, which has been used by policymakers and operational users by using the historical data, and then using which they can analyze the risk and patterns at different locations for different kind of disaster. Then there is predictive analysis, which can be used by the policymakers for operational users, and also with the communities which are at risk, so that they can analyze their risk as well as the trends based on different kind of historic data which is there in the system and the forecast which have been issued. And as well as there is a prescriptive analysis which can be used by the policymakers and operational users to have the potential impact outlooks with risk management options at one platform. Okay? And these systems have been built into two modes. We have the web system, which has the all detailed information about different kind of disasters and hazards which exist for different reasons. And there are mobile apps which are providing the real-time information as well as the different kind of hazards. Okay? And so there are products like from IMD, ECMWF, RIMES, INCOIS, all integrated at one platform. And there are the forecast products depending on the context of the state, the kind of hazards which exist into the state, which help to do the value addition to these forecasts, so that this value-added products can be provided through the web-based as well as the mobile apps which have been developed for here. So that can provide this kind of information, and whatever information for the forecast products we heard in the IMD presentation this morning. So most of those have been integrated here, which are already available, and then those are being integrated with the ground-based data to generate the kind of hazard and the risk profiles to issue the alerts for the disaster managers. Okay. So basically here we are working with the 4 stages of continuous cycling process for these tools. So these tools we are working for now like almost 5 to 6 years, but every year before every monsoon season or any major disaster, there is a lot of development and new innovations come into the process, because there is a lot of engagement with the and partnerships being developed every time. Then service design and development, delivery and evaluation and improvement. So these are the 4 stages of continuous cycling and development process we are adopting to develop these kind of products. So this we have developed with the 2 states, and we are open for the collaboration and partnership with the other states also. And at the same time, we are working with IMD with our under the guidance of DGM sir to develop these kind of systems for the whole country also. So thank you so much.
Thank you, Dr. Anshul, for your kindly completing this, presentation. So few questions, please.
I'm sorry, I'm Captain Ramanathan. I just wonder, what is the timeline of forecast you give for Tamil Nadu? Probably a week, month. That is the maximum timeline you look at.
So here
for all the disaster.
No, it depends on the context of the disaster.
Okay.
But the forecast is like we have integrated all range of forecast right from the nowcast products, the 3 hours until the seasonal forecast. So we have 3 days forecast, the medium, the short range, medium range, as well as long range products all integrated there.
Okay, thank you.
Questions, please.
In relation to the proposed national framework of climate services, what do I expect more from the IMD to provide you, or what you can help this particular framework to support this framework?
So
are you happy with the whatever IMD is providing now, or you need something more? You should project that thing.
Sir, basically for national framework for climate services, we actually need the more value-added products. So that is the user-specific products. So for that purpose, I think we need to develop like maybe Hosalikar sir and Kolli sir can support this one. But what I feel like we need more pilots to be developed. And when we have to taste these products and the services, because as also mentioned by our colleague from WMO in his presentation, this is very much time-consuming process. And for that, we need to have a lot of engagement with the user agencies. And for that particular engagement, we need to develop some pilots. We need to present this case, test the applications, and then scale up these products.
You had been working with the 2 states.
Yes, sir.
Are there any additional requirements which are being projected by these states, which
Yeah.
IMD should provide?
There is a lot of requirements
So
coming,
have
sir.
you given it back to the IMD, or should we project it?
We are working together in this, sir. So like for Bhubaneswar, I am with like our
It's
IMD.
okay. My point. So we can tailor it to the national framework of climate services. Idea of having, since you are working with the states,
Yes, sir.
you know their requirement should be known to the people who are going to manage the national framework.
Definitely, sir. We'll think that.
Actually, the basic purpose of this workshop was to look at what kind of services and what kind of information is available and what is expected. So all the lead speakers are expected to at least present some of the expectations so that the organizers will be able to that will help them actually. So with this we have concluded all the 5 presentations, and starting from agriculture, water, energy, then public health and disaster risk reduction. So we all know that climate information is directly related to all these 5. So as I am from agriculture background, I would like to add a few things here, because I'm basically representing ICAR, and CRIDA is doing a lot of work on national innovations and climate risk in agriculture. And I'm also coordinating one project which is looking at agrometeorological aspects, means establishing crop weather relationships. And as you know that Dr. Subash also presented a lot of things, a few examples that he give, but a lot of researches and information is being done at ICR level. And we are also working with IMD in collaboration regarding agro-advisory services. And what farmer exactly needs is very simple information, which can help him to take decisions. And the information should be very simple, should be fairly accurate. That means I'm talking about the forecast. If forecast becomes little bit better, so obviously the agromet advisory is going to be more effective. That is our expectation, that our experience, and also expectation from whole group, that not from IMD, with also from IITM and other agencies which are actually looking at all these forecasting aspects. And we all know that it is a gradual process. Forecasting will improve slowly and slowly, and that will ultimately help us to give a good kind of agromet advices. So with this, I think I will now hand over the mic to our chair, Dr. Rajivan, to give his final comments and just conclude the session.
Final comment is I think we are breaking for tea.
Thank you all. We would like to thank Dr. M. Rajivan and Dr. Shantanu Kumar Bal for chairing the session. We will be breaking for the tea, but a quick break. We will be taking only 15 minutes. So the next session will start by 4:35. Those who have to upload the PPTs for the next session, please share your slides.
इसको लूप में प्ले करना है।
ऐसा जो इसके बाद जो भी ये होने वाली है presentations हैं, actually we were not told to make a presentation. We were just told to speak on the topic. Is it essential to have a presentation? उन्होंने बोला कि कोई कोई आगे जब speech देके जाएंगे बना के जाएंगे
Hello. Welcome back all. So we are moving forward. The next important session, NFCS and role of state governments. So this session will be chaired by Air Vice Marshal Dr. Ajit Tyagi with Dr. Pradeep Taplial, Scientist G, SAC Ahmedabad. You can actually download the photos from using this QR code. We will be displaying it outside also. Maybe later you can download all the photos.
Thank you, Divya, and very good afternoon and welcome to the esteemed representatives from the states. As we have all seen that the states are going to play a very important role in identifying the user requirements for the NFCS. So once again, welcome. Only my constraints are there that we have 1 hour and period available. We are already late by hour and 15 minutes. So we request you to cooperate, each speaker to highlight the user requirements. You are doing wonderful job in your states, but kindly highlight what you expect from the IMED or from the NFCS. Each one is being given 5 minutes only. So very important, 5 minutes with you. So please manage. Thank you so much. We start with the engineer Tana Tage from the government of Arunachal Pradesh. We have got a very good representation, particularly from the northeast and the eastern. Some of the western India is missing. We don't have any representative from Maharashtra, Gujarat, Madhya Pradesh. So probably the IMED is taking care of that otherwise. Okay. Welcome.
From my side. फिलहाल अभी गुड नाइट बोलेगा ना गुड इवनिंग बोलेगा टाइम तो पता नहीं है आफ्टर 2 hours in my state it is will be the dinner time already started set अंधेरा हो चुका है and I'm traveling all along from the Dong Valley that is Anjao district bordering China where India gets first sun rays. Actually I'm representing the state of Arunachal Pradesh. Well, good evening all of you. I don't have much to deliberate here because my organization is very new. It is just 18 months old. My organization name is Center for Art Science and Himalayan Studies under Department of Science and Technology, bifurcated from the Arunachal Pradesh Space Application Center, which was established by Dr. J.C. Chinnaya as a director. He was the founder director. I worked here. Sir, this department has been created under the Pakke Tiger Reserve 2047 Declaration on Climate Change, Resilient and Response Arunachal Pradesh. Through this department, the state government is trying to do some research work which are very relevant and will helpful in derive Arunachal Pradesh as a carbon neutral state in the years to come. Sir, this shows the commitment of government of Arunachal Pradesh that we are committed to promote sustainable development in Himalayan region in general and the state of Arunachal Pradesh in particular. As an institutions, we are expected to play a very crucial role in addressing the environmental issues, social, economic challenges in the region while ensuring the protection and conservation of our unique natural resources. According to these policies, my department has identified some of the areas where we will be working in later days, such as survey to demarcate, geolocate, and assess the current hydrological conditions of all water bodies and the catchment areas in the state of Arunachal Pradesh. Rehabilitate, encourage community-based planning for protection and development of wetlands and rejuvenation of tanks and wetlands and springs water bodies. Generate awareness and capacity buildings for judicious use of water bodies, natural water bodies. Promote integrated and whole of school, college, technical education institution to encourage the participation in climate change research activities, build responding abilities and fosters inter-sectoral partnership for related education community development that enhance climate resilience of children, adolescents, and communities. Many more ideal areas are there which has been identified. And basically my department is working in 4 verticals, that is in disaster management, in energy sector, and in the geotechnical engineering, rock engineering, all these domains we are working. And within 18 months, we have successfully signed a memorandum of understanding with Norwegian Geotechnical Institute and the India-Norway bilateral cooperations, which has been approved by the Ministry of External Affairs. And it was categorically stated that there is no political issues from any angle. The government of Arunachal Pradesh should go ahead with the implementation of a geothermal project in Arunachal Pradesh. Because last 1 year, the Chinese government is objecting it. And because of that, the Ministry of External Affairs could not issue this clearance letter to us. It was possible only because of the intervention given from the Ministry of Arts Sciences, our Secretary, sir, who is not here. Because his effort only, we got a clearance, and successfully we have signed the MOU and work is on execution on the field. And secondly, since we are also working in a domain of climate resilience, so we felt the importance of climate data, which is to be leveraged and utilized for the state of Arunachal Pradesh. And accordingly, we approached the IMD, and they are so kind enough that they have sanctioned, allotted 142 AWS, and DRDO, DRG has also given us 54 instruments for installation in border areas. But it has been taking a long time for installation of AWS in our state, because one bag cement in plain area, it costs rupees 500. When it's reached in the LOC or LSC, the prices comes up to 2,500 rupees per bag of cement. Because of that, we could not speed up the installation of AWS in our state. And another third important projects we're implementing, that is permanent seismic stations. So National Center for Seismology has given us 8 numbers of seismological stations. And for permanent structures, we are constructing it. We are on full work, we are working on. And by the end of December, we will make it operational. So Honorable Minister will be coming to inaugurate all these stations in Arunachal Pradesh. And that will be dedicated for entire Northeast, for entire 8 states of our country. That's coming under the northern state of India. And one more important projects we are going to take up, already agreed in principle and sanctioned by the Ministry of Jal Shakti, that is rejuvenation of dying rivers and streams in selected districts of Arunachal Pradesh. These are the few projects within 18 months we are taken up in the state of Arunachal Pradesh. As far as my suggestion, because previous all the speakers has come to the point that state government department agencies should be given the equal participations in decision-making support system and planning for the sustainable development. In this regard, Arunachal being a hilly state, we need to adapt climate services at basin or watershed level, as most of the people live along the terrain areas. And one more important challenges will be coming up before us is the maintenance of AWS. As I told you, sir, that you know the installation cost, because IMD, I think they have worked out around 10 to 15,000 rupees per site. But when it is like for the state of Arunachal Pradesh, it costs around more than 30 to 45,000 rupees per site. So in these cases also, in long run, we installed AWS, but in future we need to maintain the instrumentations and all that, and the security and safety is also a concern for us. Therefore, I would like to request the IMD to have a look on this. And secondly, sir, very important thing is that about the data sharing policies, we need to have a broad framework through notification or a paper that IMD, whatever data is generating, that should be shared with the other agencies that are working in the state for the specific purpose and all that. But due to absence of written notification or the framework, the access of data is not possible. सबने तो बोल दिया डाटा अपलोड किया, डाउनलोड कर लो, ये कर लो, लेकिन आ जाता है, एक बात आ जाता है जब डाटा शेयरिंग के बाद आता है कि कुछ पॉलिसीज है एंड दिस क्लासिफाइड अनक्लासिफाइड के अंदर में डाटा शेयर नहीं कर सकते, तो ऐसे में हम लोग को मुश्किल हो जाता है यूजर एजेंसी को डाटा एक्सेस करने के। तो इसको हटाने के लिए से एक डाटा पॉलिसीज इन ब्रॉड फ्रेमवर्क में लेके आने से देंगे। और सेकेंडली कैपेसिटी बिल्डिंग के ऊपर बात करना चाहता है सर। लाइक मेरा स्टेट है, इट इज़ वेरी न्यू एंड वी आर वेरी न्यू टू दिस डोमेन ऑल्सो, सो वी नीड ट्रेनिंग फॉर आवर बडिंग कमिंग अप साइंटिस्ट एंड ऑल दैट। तो आप लोग जैसे बड़ा ऑर्गेनाइजेशन, इफ यू कम फॉरवर्ड to train our scientists and all this. These are the 2 points from us. Thank you very much.
Yeah, thank you. Thank you, Mr. Tana Tage. Sir, he's one of the celebrity in the northeastern region, and though 18 months, but I know him for last 1 year. When we prepared the climate annual summary for the state, the first response we got it from Arunachal Pradesh that they are ready to, give the inputs, and Tana Tage was directly in contact with us, and he shared a lot of information related to the loss and damages, and really, I'm thankful to you. The other things that you mentioned about AWS installation, yes, we understand that a special approach has to be made, especially when we are, building up this type of network in the northeastern region. Yes, I agree with you, 500 to 2,500. Same thing, we are facing the difficulties, especially in the areas of Leh and Ladakh, when we want to install AWS ARG. The cost which is calculated and real cost on the ground is different, but this we will work out. The third point which you mentioned about the data sharing, the data sharing policy is in place already. Maybe if required, we can review it. But there is something called as classified data. If the data is from border sharing areas, then probably it is generally not being shared directly to the users or somebody who is demanding. But definitely, if the government agency or state government is asking, this type of classified data also can be shared, but then it requires a different channel approach. And rest of the thing, like I understand that we have signed one MOU, IMD signed one MOU with you for more than 100 AWS system. So that also we will definitely go through. And you must be knowing Dr. Mohan, K.N. Mohan is there, who is heading the RMC Guwahati. And in case if anything required from the Climate Office, Pune, please contact us. Definitely we will help you.
Okay.
Thank you.
Thank you. And with the Honorable Minister and very positive Secretary and Dr. Hosalikar, I think Arunachal Pradesh has a bright future. So please make best use of it. Okay. Next, we are requesting Shri Rahul Boja from Government of Telangana. Okay, if not, then we move to the Dr. Kundra from the government of Uttarakhand. Welcome, ma'am.
Good evening. I'm Dr. Pooja from Disaster Management Department of Uttarakhand. Today I will discuss only 3 or 4 points, what we have in present and how we are disseminating in to end user and what are the gaps and what are our recommendations. So why we am discussing today? Because so we can do for future this work together. So in existing system, I will introduce the hydromet network which is presently we have and the forecasting early warning what we are getting and this is how we disseminate and identifications in the gaps and improvements. This is the existing system of hydromet networks. So different departments have installed different sensors. So if you have meteorological sensor, we include all the SFOs, ARs, ASD, ARG, weather service, all instruments. So IMD have 80, CWC have their owns. Even Uttarakhand State Disaster Management installed 176 stations. All the data already shared with IMD and other agencies. And hydrometeorological sensor, automated water level recorder, 28 from installed by CWC. And 3 are the Doppler radar. 2 are in operational mode, and one will be soon 2 or 3 months. This is the map. So if you are seeing that, if you see that, this is the area where we have lots of the sensors. And this is a 3 Doppler radars. This one and this one is operation. This will operation within 2 or 3 months. So this Doppler radar will cover is covering this much area only, and this is covering on this much area. And I think maybe this will cover this, but the upper area of the Uttarakhand will remain uncovered, even by the automated weather stations are also not there, insufficient amount. So this is the gap. This is the field photos. On the forecasting early warning, Center Water Commission only provides the trends and warnings of the river waters. IMD provides the weather warnings. DGRE Chandigarh, SASE, they provide avalanche forecast. And after getting a early warning or forecast from IMD or other agency, anybody is there, in SCOC, we use, at same time, they use recipient districts and a state emergency operating center with all the stakeholders, all the line department, and same with our medias. Through CAP, we are also using last 2 years. In 2021 to 22, it was a testing mode, but from 2022, it's an operational mode. So we are using that CAP and the other electronic media, social media also. So this is our SCOC functioning, it's 24/7 working. Or this is a scenario for the during monsoons. In all that, you are seeing that all the departments are sitting there. Because disaster management department, it acts as a roof between all the departments. It fills the gaps if there isn't any gaps in between any departments. Identification of the present existing systems. If you talk about the hydromet network, so as I already showed in previous presentation, there is an inadequate looking to tough hilly terrain, and there's a connectivity issues in hill stations. So, and if we talk about the forecasting, in weather forecasting, we only receiving a district level forecast for the rain only. Other parameters like temperature, rainfall are not included. And the lightning and avalanche, same, they are all on the district basis. If we talk about the hydrological forecast, the river trends and warnings are only available, and the warnings only for the 4 stations. Our district, our state is so bigger, but we are receiving for the only 4 stations. And the warning is restricted only lower reaches, and that the 4 stations are the lower reaches, not an upper hills. And flood forecasting not available at present also, sir. This is the forecast which we are receiving district wise, and you can see that during July and August month, how every day Not a single day or 1 or 2 days is only other green. Some districts. That's why yellow, orange, yellow, orange. Our requirement is we know that satellite observations are important, but they can't substitute for the surface-based observation, and they themselves need validation for the surface data. So we need to densify the existing network of a hydromet network, and forecasting agencies should generate impact-based forecast, which will help us because at present what we are getting, that is a district level forecast, and it is sometime it happens some portion of the district covered by the rain and some are uncovered. So public we generally disseminate that information whole of the district, and it will trust issue for the publics. Next one is a precise and terms of spatial and temporal. Should include other parameters such as temperature and other snowfalls, and essentially should provide a training for a technical decision makers. Thank you.
Thank you, Pooja, for comprehensively covering within the time, and whatever the observations you are there are very taken, and I'm sure it will be taken consideration in our recommendations. Thank you. Now I request Shri Animesh Das, representative from the government of Tripura. Thank you. Welcome.
Very good afternoon, everyone. So, myself, Animesh Das, Additional Secretary and Director, Science and Technology, Government of Tripura. We have been asked to say something regarding the role of the state for implementation of NFCS. Sir, Tripura has been witnessing significant changes in its climate pattern. Over the year, we have observed an increase in the frequency and intensity of extreme weather events. From prolonged heat waves to erratic rainfall patterns and at times devastating flood, and these changes are having profound impact on our agriculture, biodiversity, and overall way of the life. This year, for the first time of the history of Tripura, Tripura had to shut down its school for a few days due to unprecedented and severe heat waves. So this is the workshop which has been organized by IMD is really, it is the need of hour. And definitely, sir, we being the state, we will contribute ourselves, whatever the data, whatever the information inputs are available with us, we will share it to give a shape of the national framework for climate service. Sir, one thing I can share, sir, the Department of Ministry of Environment, Forest and Climate Change, under their direction, all the states are preparing, sir, the state action plan for climate change. And it is being revised. In the year 2012, actually that state action plan was prepared by all the states of the Government of India, and now it has been revised. Some state has already revised and it has been approved by the ministry, and some states are revising it. So all the data information are available with all the stakeholders. So we will share that data which are available, so it will be beneficial to come into a conclusion and to prepare the final framework for climate services. Sir, it is my only one request, sir. So the data portal, there must be one data portal should be developed and one indicative action plan, so that all the state can follow it and state specific action plan can be prepared, because region to region and state to state, some action plan may be may differ. So accordingly, we can proceed. So climate change, sir, is a pressing concern for sustainable development of our country. And 5 sectors has already been identified as a special focus in NFCS initiative to address the challenges due to climate change. So we hope that, sir, by working together with all the stakeholders and the states, organizers, and other communities may involve also in the process, and we'll definitely will be able to pave the way for a climate resilient India and secure our future generation. Thanks to all, sir.
Thank you, Dr. Das, and offering your all help in related to the National Framework for Climate Services. And let me assure you that Med Center Agartala will be there working closely with you. Okay, now next we have another colleague from Tripura. Please. Okay, welcome. Shri Anindya Kumar Bhattacharya. So we are lucky to have 2 key representatives from the state of Tripura. Please.
Namaskar, sir. I am here to tell you, sir and madam, that early warning system is helping the state government in saving life of the citizen. Last 2 years, we have got the information from the IMD that there will be cyclone, severe cyclone. Then this is helping the state government to take the informed decision. State Disaster Management Authority, headed by Honorable Chief Minister, is calling the scientist of the IMD Agartala for discussion so that she can take the informed decision whether state disaster force will be able to handle or national disaster force would be called off. That we have taken another decision, the Sendai framework and the Prime Minister 10-point agenda, particularly number 3, but categorically state the community preparedness volunteers. What we are doing in Tripura, each and every village and the urban local bodies, you will find civil defense volunteer, Apta Mitra volunteers. They are trained. They are helping the citizen to develop the apps, Damini, Mosum, all the National Portal Disaster Management Alert System. And beside that, IMD, what our information is getting, we are trying to send through mobile operator in local language so that citizen can understand the gravity of the cyclone and etc. So we are working in this line so that by 2027, all citizens get the information in their mobile early warning system. Thank you, sir. My friend already spoken about Tripura. I have just supplemented few points. Thank you, sir.
Thank you so much, Shri Bhattacharya, and very, very encouraging work being done by the IMD and the state government with respect to the warnings. Now I request my co-chair, Dr. Thapliyal, to follow up with the remaining presentations.
Thank you, sir. So next speaker is Dr. K.P. Sudhir from Government of Kerala.
Good evening, everyone. I represent Government of Kerala with the Department of Science and Technology. With limited time, I will just browse through my presentation. Well, Kerala is one of the states where we have a network of research and development centers which require the climate services from IMD and other agencies as well. And we also have a specific institute called Institute for Climate Change Studies, which cater to all the requirements of the climate services in Kerala. It is a very, very infant stage. Though the institute was started in 2014, it got actual momentum in the last couple of years. And Dr. Pai was heading the institute for 1 year. And currently it is now on the track. So if you look at this, there are 8 different institutes which are diversified into water, forest, biodiversity, and health. We have an institute called Institute of Virology. Then we have Botanical Gardens, School of Mathematics, and so on and so on. Until 2018 flood, most of us in Kerala were believing that there is no climate change. So if you look at this plot, these 2 plots, last 30-year and the current 30-year plot, which is average rainfall over the period, there is no significant change in both the plots. We were always talking about the mean rainfall every time. But what we have realized later is the number of rainy days have consistently gone down, even though the volume remained the same. The average remaining the same means that the volume remained the same, but the number of rainy days have consistently gone down, which indicates that the intensified rainfall actions have increased. And that is where we are finding a lot of disasters these days. This is the Institute of Climate Change Studies, which got rejuvenated in 2021. Basically to empower Kerala's preparedness for anticipated global consequences of climate change. And that is the vision with which the institute has been started. Well, to give a glimpse of the variability in rainfall, spatial variability of rainfall in Kerala during the Indian summer monsoon, post-monsoon, and the pre-monsoon region. So you can easily visualize how is the spatial variation of rainfall that we are experiencing in Kerala from the northern side to Kerala, the southern side. Primarily, we have extreme rainfall events, or we have rainfall locations where we get more than 65 or 650 mm of rainfall, 65 mm of rainfall, and also we have locations where we get lower amount of rainfall. This is basically the number of rainy days in in terms of percentage of rainy days, and you can see in different seasons of the year that is also highly varying. And the number of rainy days over a period of years, it has come down, and the pattern of rainfall trend, it's now you can see that it is subsequently coming down. The trend, the total amount of rainfall remaining the same, but then there is a trend of rainfall coming down in Kerala. Now, in terms of service, what we have done is after the 2018 flood, we have developed a flood inundation library, primarily taking from creating an ensemble of possible rainfall events because of the spatial variability. And what we have done is for one basin, we have developed it. We developed an ensemble of spatially variable rainfall of different written periods. Then we created the inundation maps accordingly. And now this is kept as a library. Now, when we get a forecast from IMD, we try to simulate and then check whether what is the pattern of possible inundation in the basin and try to get prepared for that. And this is what one of the actions we are doing. And this is flood risk maps for the same basin. What we have developed is flood risk maps primarily to plan for the future, the land use, the planning for the future. Whatever is planned, we cannot go and undo it, but then for future development, we can use these flood risk maps. This has also been developed for different written periods of floods. Now, we also have, with the help of IMD, we have also developed an early warning system. The 21 ensembles, which thanks to Dr. Patnaik and Dr. Pai, who has been giving us this information consistently even today. So we are able to get all these 21 ensemble rainfall forecasts for the next 10 days, try to run it through a hydrological and hydraulic model and try to develop the flood inundation, what is possible. So we were able to validate it during 2020 and it was working fine. And now we are using it as a warning system for, we are not issuing warnings, but then we are using it as preparatory things for the government to develop activities. Now, we had 2018, 19, 20, 21 and 22, we had consistently excess rainfall, which 2018 was a devastating flood, but then the other years were also excess rainfall years in specific months. But then 2023, we are actually we doubt that we are heading towards the drought situation, because the monsoon season, the rainfall were actually deficient in 2 months consistently. And there was a cyclonic depression in the Arabian Sea last 2 weeks, and then couple of rainfalls in the last 2 days or 3 days, which probably would have made up the total amount of rainfall, but that is not going to be useful for the storage. If you look at the long-term changes in mean rainfall and days, primarily if you say northeast monsoon, and 20% of the total rainfall is received during the northeast monsoon. The northeast monsoon, if you look at, it is an increasing trend, but the number of rainy days are again coming down. So probably, unless we improve the storage structure and then the reservoirs, probably we may not be able to store this water, is one concern we have. But then where we require help from IMD is the dry spells in the southwestern monsoon during 2023, this year, has been significantly large. So if these kind of information, somebody was talking about the long-term, the association or the forecast that can be provided to the state. So these kind of information can be given to us well in advance. We can probably plan for our water management and then alert our the farmers. And this is about El Nino and La Nino. If we were finding out if there is a relationship between El Nino and La Nino, La Nino in terms of what is happening in terms of rainfall deviation from the normal values, and we found that there is significant the correlation between El Nino and La Nina. And if you look at here, we do expect that there is going to be a deficit northwest monsoon also. Now here, what is present here is the reservoir storages in Kerala, the major 3 reservoirs. And until 2022, by the end of southwest monsoon, we had almost 75 to 80% full reservoirs. But this year, more or less, it is less than 50%. That means the storage is in reservoirs are very, very less compared to previous years. And we expect that we are going to find it very difficult for the next 3 months or 4 months to utilize the water, unless there is the northeast monsoon is going to be severely good. And even though if it is good, we are going to get only 20% of the total rainfall from the annual rainfall. So we are in a real critical situation now. So I don't want to go into all these observations. So my request to IMD is, the submission from Government of Kerala to IMD is, please give us early warnings about the seasonal forecast, seasonal rainfall pattern, probably if there is a deficit which is expected. Normally what happens is we give, I do get emails from Dr. Pai and Dr. Patnaik, saying that the expected rainfall is normal. But if you can give us little more details to it in a quantitative terms, so probably what could be the rainfall pattern during the next 3 months or 4 months, then we can get prepared for that. Then we will always use that information for disseminating to the farmers and in the other users. That is one point. Second thing is, I understand that IMD is seriously planning for establishing a Doppler weather radar in Kerala, because we are also have started experiencing urban floods these days. Most of our cities are getting flooded these days with intensified rainfall becoming more and more frequent. So I would also request to speed up the action on that. In addition, I would also appreciate the action taken by EMD in establishing more and more rain gauge stations in Kerala, which is now, I think it's 50% of them are in place, and the rest 50%, I guess, by end of this year, they will be taking place. Thank you very much.
Thank you, Dr. Sudhir. Any one question?
Thank you. I'll just add what already IMD has said. We have said the northeast monsoon would be normal. Am I right, Paisa? Northeast monsoon will be normal. And if you see the current scenario with El Nino becoming maturing and IOD positive, Kerala is expected to get good rainfall. That is what the sort of predictions and the background is there. Second is Kerala has We have completed all the AWS installations in Kerala, 85 AWS, and already 15 are there. So 100 AWS are working in Kerala. Probably it is the only state, area-wise and the number-wise, it's the highest number of AWS that we have put in the Kerala. But in case if there's an additional requirement, definitely, we will take up that. There was a promise to the parliament that we'll put AWS 100. Rajan Saab remembers. So we have put that 85 plus 1500 number we have completed. But still, we will try to address, and some of them may not be working. If that is the issue, that also we will address. Thank you, sir.
Thank you.
Thank you, sir. So next presentation by Ms. Kimni Chengsen, Government of Assam. Apart from your weather requirement, the important point is to highlight that related to climate. That is most important, that number of high intensity rainfall is increasing. That point will very well take mind because that is how where we have.
A very good evening to each one of you. I'm really very happy to be here. Grateful that this stakeholder consultation workshop on National Framework of Climate Services in India, this has been organized. And I'm thankful to the government of Assam, Chief Secretary, for nominating me. But at first, as I'm not an expert in the field, and I'm not a scientist, not an expert in any of the sector, so I thought, why am I being sent here? But the name Lavasa and Pune was really attracting me. So I did not say no. Okay, this is a chance for me to visit Lavasa, Pune. So as it is my first time. And from Pune, the drive to Lavasa was really so nice, breathtakingly, beautiful scenery, the wildflowers. I've never seen such beautiful wildflowers, greeting, it's like accompanying us, cheering us throughout the journey. Like that really makes me so happy. I said, I don't know what will they do, what will I gain from the workshop, but at least I get to see the beautiful place of Lavasa. So I'm so very grateful, so thankful. And in fact, I have come here to gain something, to learn something, as I have not much to contribute. Like I said, I'm not an expert. I'm additional secretary in the Department of Science and Technology. So I know something which we have done, some measures taken by the government of Assam to mitigate regarding related to climate mitigation and adaptation, some measures we have taken. So these things I would like to share with you all. Okay. So firstly, as climate change has been taken very seriously by the government of Assam, Science and Technology Department has been renamed as Science, Technology and Climate Change Department in 2021. So this is how serious we are in trying to fight, climate change. And also, a separate Directorate of Climate Change is also underway. And as you know, Assam is always having the problem of floods every year. Since my childhood, I know when I used to have pen pals, so my pen pal asked me, they used to worry ki what happened. Assam's news is always negative, either something insurgency or floods. So they are afraid ki maybe my house is flooded or maybe what had happened. So these are the cause of worry. So what we did, department, Science and Technology Department, we have provided improved chula or say smart stove to the flood affected families. And in various regions of Assam, including the fringe areas of protected areas like Manas Tiger Reserve, Kaziranga National Park, Pobitora Wildlife Sanctuary, and other reserve forest areas. The government has invested in capacity building programs on alternative livelihoods, conservation awareness, and action research to identify as well as assessing climate vulnerable zone. Initiatives such as modern handloom promotion, wild beekeeping, vermicomposting, solar power installation in schools and community halls, solar powered torches for communities, and frontline forest staff for forest patrolling also contribute to reduction of the state's carbon footprint. I have my Dr. Pranjal Barua, please stand. He's accompanying me. He is the one who's working in the field, in Kaziranga and Manas Reserve. So working with the grassroots level. So grateful to him. The Science and Technology Department, Government of Assam, we have also recently launched Chief Minister's Institutional Plantation Program. So where approximately 250,000 saplings were planted. See, we have come across forest, environment and forest department and various department under, doing so much of plantations. But what we do not see is we do not nurture it, or monitoring part is not there. So our small department, what we did is through digital platform, we are monitoring the growth every 3 months. The schools or institutions who has done the plantation will have to upload it, or whether how many saplings have survived. So this is how we are monitoring it. We have just done it last year, and we are doing it in a very religious way. Okay, and recently on 17 September, our Chief Minister has initiated one scheme that is Amrit Briksha Andolan, where 1 crore saplings of locally available commercial plants were planted in order to increase the green cover of the state and boost local economy. This is the work of our Chief Minister. And also, Government of Assam has launched, I should say, our department, Science, Technology and Climate Change Department, we have launched Chief Minister's Climate Resilient Village Fellowship Program. I'm confident that in nowhere in the states of India this program is there. So under this program, what we try to do is we are in the first phase, 44 postgraduate students, we have engaged them to collect vital climate change data within Assam. They are sent to remote villages, remote areas, and these students are actively working to address climate-related problems at the grassroots level, benefiting 44 different villages across the state. And the process for the second phase have been started, where we will engage another 50 more students in 50 villages. And we have Climate Media Fellowship also. And also, in order to build a climate resilient society, our department has catalyzed the establishment of college, environment and climate cells in 40 colleges throughout Assam. And also, eco clubs have been established in 8,000 schools across the state to raise awareness about climate change among students. And Government of Assam has prepared 2 numbers of State Action Plan on Climate Change, ASAPCC 2015-20 and 2021-2030 as a policy document to deal with climate mitigation, adaptation and resilience in the state. Once it is approved, we will willingly share it with you. And for the first time, a green budget has been introduced in this financial year. And also, science, technology, and innovation policy for the next 15 years is also being drafted. And climate change disaster management is one of the thematic group of the policy, as well as other 4 priority sectors emphasized by NFCS. And another one initiative of our government is Mukhyamantri Saura Shakti Prakalpa, that is Chief Minister's Solar Energy Project, which aim at installation of 2,000 megawatt of solar projects, highlighting Assam's dedication to a greener solar energy future. Further, Assam has the floating solar power generation potential of 3,000 megawatt, out of which for 1,000 megawatt floating solar projects, MOU have been signed by the government of Assam. And we have also brought forward electric vehicle policy for phasing out fuel-based vehicles by 2030. Furthermore, commissioning of India's first green hydrogen plant by Oil India Limited underscores Assam's pioneering role in green energy revolution. So addressing climate change requires a multifaceted approach, and all states should play a critical role in driving solutions across various sectors. In Assam and Northeast India, all the weather stations are not working properly, and so that is due to lack of maintenance and support, and for which we need the help of NFCS to pave the way for effective climate information system for climate data collection, analysis, prediction, awareness, and dissemination. We need technical support from NFCS in establishing such networks for the state. We are really hopeful that NFCS will create a common platform relating to climate information system to share data and experiences for better climate services to the stakeholders and communities. We need strong collaboration with NFCS to implement better climate services in Assam and Northeast India. Also, we require advanced climate research laboratory in Assam and Northeast India. The government of Assam has been involved in adaptation and mitigation part. However, we require capital, capacity building, and infrastructure related to climate services. Please don't mind. I have taken more time, I think. Thank you so much. That is all. I hope there is no question. If there is any question, all the experts will answer it for me. Thank you so much.
Thank you, Ms. Changsan. Actually, you have, given a complete list of what government is doing for climate mitigation there in the state, and also you have listed so many things for and also listed so many things for planners for this IMD to provide.
Yeah, when the invitation went to Madam Kim, she called me and told me, Hosalikar, do you want me to come because I don't have this type of background? And I told her that this is not a scientific seminar where people need to present the papers, but maybe we require people in the key position who could drive the climate related programs in the state. And whatever you are doing, that we would like to listen. And you very humbly started that you don't have to say anything, but probably I think all of you will agree that she has maybe the maximum things to share about what climate resilient and mitigation activity that Assam state is doing. We'll be definitely happy to remain connected with you in the further course of time. And whatever automatic weather station point you have raised, definitely this point also I will take. We have a regional office at Guwahati. I will definitely connect you to that office, and definitely we will try to resolve that also. Thank you. Thank you for a very good presentation.
Thank you. Dr. M.M. Ali from Government of Andhra Pradesh.
Yeah. Hello, everybody. I am M.M. Ali representing Andhra Pradesh State Management Authority, Disaster Management Authority. Actually, what we are concerned right now is about the early warning dissemination system, because the moment any incident takes place, then we'll communicate to the concerned department and stakeholders. So as of now, I mean, we are not doing much about the climate forecasting, I mean, dissemination or something like the climate change dissemination. But once the IMD starts giving the climate forecasting type of thing, we'll certainly use it. For example, whenever IMD gives the long range forecast, meetings will be held at the commission and even sometimes at the chief minister level to see what actions we have to take. So similarly, if we can, IMD can give the climate forecast, then we'll try to plan what will be the action to be taken in the future. So now, I mean, I will be showing most of the things in SOC activities. Anyway, rainfall monitoring, other weather forecast, and all those things are there. Coming to the cyclone forecast, cyclone type wind distribution, what I request IMD is already giving scope of uncertainty and the sectors of the wind speed. So if IMD can also as of now, as far as cyclone forecasting is concerned, IMD is providing track uncertainty and the sectors of the wind speeds. So in a similar way, if IMD can also provide which sector will have more rainfall or which sector is likely to have which time and how much rainfall, that will be also useful for us to for planning. And coming to the agro advisories, earlier we were having 13 districts. Andhra Pradesh was having 13 districts. Now they are bifurcated. Even now, IMD is providing agromet related forecast only for the old 13 districts. And if they can be provided for the bifurcated districts also, it will be very useful. And anyway, I will not go into details because I will short of time. What I am talking about the achievements, even you know very well that these temperatures are increasing day by day. Even then, because of the accuracy of the IMD forecast and because of the actions taken by the stakeholders and the collectorate, we can reduce the deaths. In 2017, deaths were about 284, and they have reduced to 3 only in 2023. But in between 2022, 2021, 2022, deaths were 0. Even in 2023, what was informed is heat wave days in our maximum. There are 35, 36 in 2023 since 2014. So even then the heat wave days are increased, but we could reduce the deaths to 3 only. That is because of the support from the stakeholders and then policymakers and then even IMD forecast. And similarly, coming to the cyclones in 2000, lightning, 2018 they were about 137 deaths were there, and they have been reduced to only 49 in the 2023. Now about cyclones, during 2014 to 2017, cyclone deaths were 206, whereas from 2019 to 2023, cyclone deaths have reduced to 118. I have not gone into year-wise bifurcation here because 1 year cyclone may not be matching with other year cyclone. So we have taken period of 4-year period we have taken, and then we have compared. And the state specific disaster lightning, we have state has declared the lightning and boat accidents as a state specific disasters. And we have also established siren alert system where we can communicate the, either in the form of a beep or in a pre-recorded message, we can communicate to all the coastal districts. Right now they are established only at the coastal districts, and we are planning to have for other districts also. And we have also developed in-house dashboards like WebEOC. This is the first of its kind in India. What it says is, suppose where forecast comes from IMD, we'll give the forecast through this WebEOC. It goes to all the districts, and even mandal officers also can see. Advantage of that is they can give the feedback, what type of information they want, what type of support they want. Suppose they want somebody from fire department to cut the trees and all those things, they will inform us, give us the feedback, and also they will tell how severe the conditions are there. So this is one of its first kind. And similarly, we have developed APLAM's dashboard, in-house dashboard, taking lightning alerts from lightning strikes from IIT in Pune. We are giving the alerts, lightning alerts. I don't call it as lightning prediction or forecast. We will give the lightning alerts. And then we have also developed APDMs. It is a consolidated one-stop dashboard where all the sorts of information about the forecasting, and then alerts are given in that. And then API alert is in the process of experimental stage. We have not yet completed that. Now will get the info for giving these alerts. We get information from a lot of organizations. You see the largest list is from IMD. I will not go into details. And we also give this type of forecast we give from IMD. Will give 5-day forecast updated every day, and for both the rainfall and temperature also. And we also take the CWC forecast, where it is a inbuilt dashboard, and if you press on any dark circle there, it will give more details will be given. How much is that dead water level, and how much is the water level, how much is overflow, and all those details will come in that one. So next, yeah, we give the when the forecast comes from CWC, how much water level will be there in particular dam or something like that. We create an inundated map. This is inbuilt software. We can also will provide how much area will be inundated, what are the how many schools are available in that area, and what are the precautions to be taken, how much crop area will be inundated. This information is provided there. And this, of course, once we develop this, it can be used for in the future also. We also give the heat wave forecast. I will skip this. We coordinate between the nodal agencies like IMD, INCOIS, even NGRI, and then CWC. Communicate that information, whatever information we are getting, one we are getting to the line departments, and line department in turn ask us what is the requirement, what type of information they want, what type of help they want, and then we provide that help to them. I already talked about LD1 examination system. I think I have already discussed this earlier, so I'll skip that. We do some analysis on the lightning. I will skip those things because of lack of time. So what we want to do, what I want to present here is we have taken up recently we have taken up 2 slides only. We have recently taken up one project where we want to project what is going to be happen in the meteorological parameters for the up to 2050. So this is one example for temperature. What we have done here is we have taken, CMIPS gives a lot of output. So all the output, if you give to any stakeholder, they cannot use it. They have to get only one output. So what we have done is we have taken few models which are very close to IMD observations, basing upon the RMSE or correlation coefficient. We have taken 4 values. If you see here, and we have applied AN artificial neural network technique. If you compare IMD with the 4 model observations, model forecast, and ANN has given the least RMS error. So in this way we have predicted what will be the temperature in 2050. My last slide is this. And if you see here about the left panel is about for 2023, and the right panel as per this prediction of using ANN and then CMIP model observations. You see here in 2020, of course, temperatures are also slightly increasing, but the area of maximum temperatures is spreading towards north. Thank you very much.
Thank you, Dr. Ali. Any one question? Okay, now I invite from Government of Punjab.
First of all, a very good evening to all who are present here. Before starting with my words, I would like to congratulate this university Christ for holding such a wonderful program in which all of the states highly educated persons are sitting over here and providing such a valuable information. On behalf of Punjab government, myself, Amrinder Singh, being executive engineer from Jalandhar, and my colleague, Mr. Dilpreet Singh from Gurdaspur. Actually, we cannot prepare any type of presentation because at the last moment, we have got the information to be part of this program. By coming here, the point that we have learned that the platform that is needed at present is the climate. because as most people here are aware that Punjab this time has suffered a major damage in the floods. The floods that are mainly contributed, we are talking here, it's only due to the climatic changes that are coming. This is the need of the hour, as we are experienced the floods in the month of July itself. Even in the previous history of Punjab, most of the floods that have occurred that are mainly in the month of September ending. But this time, we were even whole of the Punjab was highly disturbed as the floods have reached before time. That only on 7th July, we have faced the major floods. As most of the rivers coming from the Himachal, Satluj is the main river that is contributing to the Punjab. Satluj carries the discharge of the river Sirsa, Swan, Budki, and Sangraho. We can say, unfortunately or fortunately, rainfall was so heavy that all of the rivers started simultaneously flowing, and the discharge nearly about 3 lakhs passed through the state of Punjab and highly disturbed Jalandhar district, Loiya, and ultimately it goes to the Pakistan. So my point of discussion is seeing such words over here at this platform is this, that we should be now at a stage the climate changes are to be studied at a very high level rate. Monsoon has changed their patterns. It is coming, likewise it is not a normally distributed rainfall that we are expecting. It is a rainfall in some states, it is highly deficient. In Himachal, we all are reading it is extremely heavy monsoon, while in some states are entirely deficient. So like Punjab, I would like to contribute. We are facing the main months that are June, July, August, September, and October. Three crops we are basically growing, Kharif and Rabi. Kharif we mainly cover rice and then wheat crop we are having. Likewise, the contribution that our Punjab government is making at present, that I can say we are having the projects for NHP, National Hydel projects that we all are talking. We are having approximately 555 DWLR stations that are integrated with the WIMS. And all the data that is being delivered by the DWLRs, digital water level recorders, are available on WMIS from the Punjab. Anybody can access that data, easily access. Secondly and lastly, we are highly thankful to the IMD. It's because of IMD only that the floods that were coming, we were able to take the actions well on time. We have the approximately time of 36 hours before it was reaching the Punjab state from Himachal. It was all possible because of the IMD. Even when the first phase of the floods passed, we were regularly in touch with the IMD data that Himachal is having so much rainfall. If they are saying that Himachal is getting, because we used to see the forecast for 5 days. We are planning according to the 5 days forecast that we were having, and we were planning according to that only. And likewise, everybody has said here where 15 seconds are much more. Likewise, we are approximately having, when the water starts from the Himachal, it generally reaches the Jalandhar district or any other districts by 10 hours or 15 hours. And 15 hours, I think we have sufficient time to save the valuable human lives, and that we have saved also. So in the last, I am highly thankful to the Christian University who has offered such a platform, such a brilliant platform, and the brilliant arrangement being made by the university. Thanks all.
Thank you, Mr. Singh. So next, there are two presentations from UP. So first from Vikas Kumar Singh. And second one will be Mr. Chandra Vikas. So after that,
thank to organizers so that UP is attached in last time our discussion regarding the discussion regarding the implementation of information system. First of all, I feel so honored and feel so happy to be here and present the discussion regarding the information system and how state has to assist the information system of the nation. First of all, we have to I have to discuss about the UP. UP has so many achievement in information system. UP has already established ISO, SWIC, FMIC for information system, and then they are working very well. Flood Monitoring Information Center is working so that we have 72 hours or 48 hours as per regarding the reverse alarming system. Because UP has and so much water resources, but they have any of the river is not originating from the UP state. All are either from the Uttarakhand or the Nepal. But today, regarding the discussion on the role of state government in the implementation of NFCS India, first of all, I recognized 2 to 3 things for suggestions. That first of all, we have to identify the dark points or gaps in information system regarding the climate issues. First of all, we identify the stakeholders which are objective or need-based awareness. First of all, we have to aware the people. The thing, 2 major things, agriculture and water resources are so much influenced by this information system of climate. And awareness is most important. Regarding the NFCS and its role and goal, stakeholder, service providers, and especially agriculture and water resources department, their consumers are like farmers and general people, users were of water resources. So we have to organize these type of workshops in region-based, and also the information is the connectivity of information is from the top level to root level, and by other sources, other departments which have so much information. In UP also, all the departments have so much information, but due to a lack of platform, they don't communicate them, and no, we have no fruitful effects. So, because natural resources and calamities cannot be bound with the state, nation and international boundaries. So the information is to be connected regarding the inter-districts, interstate and international. Because I am facing the flood problem in UP. Because ज़्यादातर नदियां जो हमारे यूपी की हैं वो उत्तराखंड और नेपाल से या आती हैं, और कुछ नदियां तो बिहार के थ्रू भी आती हैं। तो ड्यू टू लैक ऑफ इंफॉर्मेशन सडनली बाढ़ जो है आपके तराई क्षेत्र जो उत्तर प्रदेश का है, जैसे बहराइच है, बलरामपुर है, गोरखपुर है, इन एरियाज में ड्यू टू लैक ऑफ इंफॉर्मेशन फॉर नेपाल एंड उत्तराखंड हमें सचेत होने का समय ही नहीं मिलता। एंड विदाउट अलार्मिंग सिस्टम we have lost so many people and faces calamities. So I have a suggestion for interaction with users and service providers as per their regional need and demand based, district level to state level to national level, or national level to international level, as you is working. But a climate, when we deal with the basin, river basin, we flood, we deal with river basin. So in this section, we deals with the climate basin wise interaction level and climate basin wise international level also. International interaction of information is also very important, because the government of Punjab and representative of government of Punjab has said that water is flowing from away from India and Himachal also. So this type of platform of multidisciplinary and multi-layer and multi-dimensional objectives need-based stakeholder is so important, so that information exchange is very useful. And regular this type of workshop is to be organized at regular interval, and so that to mitigate the issues, problems, and mitigate the problems, mitigate the solving the problem of issues. And also another thing I have to add, that the interaction of information level should be micro level to macro level. From grassroots level, that some villagers have more knowledge regarding the flood. So इंफॉर्मेशन का एक्सचेंज जो है ग्रास रूट लेवल से, हम लोगों के यहाँ ऐसा है, FMSC हम लोगों ने गांव में ग्रास रूट लेवल पर विलेजर्स को भी हमने अपना नंबर दे रखा है कि कहाँ कब पानी आ रहा है, आप मुझे चाहो तो इन्फॉर्मेशन दे दो, या मुझे पता चले तो मैं इन्फॉर्मेशन दे दूँ, जिससे वो कैलेमिटीज से पहले वो अवेयर हो जाए और उससे बचत हो सके। दूसरा है कि माइक्रो लेवल से मैक्रो लेवल तक इंटरेक्शन हो हर लेवल पर, डिस्ट्रिक्ट लेवल से, लेकिन वो डिस्ट्रिक्ट लेवल जो हो वो क्लाइमेट बेसिन वाइज हो, नॉट डिस्ट्रिक्ट वाइज। डिस्ट्रिक्ट वाइज ऑल्सो इम्पोर्टेंट, क्योंकि हेडक्वार्टर्स हमारा डिस्ट्रिक्ट पे है, DM वहाँ हमारे बैठते हैं, उनके लेवल पे अगर इंटरेक्शन होगा तो वो हायर लेवल तक, चीफ सेक्रेटरी लेवल तक आएगा, और वो इंफॉर्मेशन ग्रेजुअली एंड ग्रासफुली नीचे जाएगा। हमारा इंटरेक्शन माइक्रो लेवल टू मैक्रो लेवल हो एट द लेवल ऑफ नेशनल लेवल, बट उसका एनालिसिस, उसकी एनालिसिस एंड इट्स इम्प्लीमेंटेशन प्लानिंग मैक्रो लेवल से माइक्रो लेवल को जाए। एंड व्हेन दीज टू वेज मीट टुगेदर, then we solve the problems so drastically. So thank you for this suggestion.
Thank you, Mr. Vikas. Next and last speaker is Mr. Satyaban, again from UP. So please be brief because we are running out of time. before he gets his presentation, I would like to simply add something that we have a very good number of presentations from hill state. Very good to know, because the climate change over hill region not only affects those states but also neighboring states. We have seen other presentations also. Himachal affecting Punjab, Uttarakhand and Nepal affecting Uttar Pradesh, as well as Arunachal Pradesh is affecting flood over Assam and other places. So there is this also highlights the need for national framework for climate services in India. And I would also like to add one more point, because apart from having our own ground observational network, we should also focus on strengthening satellite-based observations, because like Arunachal Pradesh, we can have our own network. But what about China? Because the climate change over those regions, flood, heavy rainfall from those regions also make flood in our own this region, our own country. Similar. Okay, please go ahead with that, and we will make our remarks.
Thank you, sir. I'm Chandrakant, representing state of Uttar Pradesh. I'm basically from the UP State Disaster Management Authority. So, firstly, I give you the brief about the UP. UP is one of the largest state in our India, with the population of almost 23 crores. And we have 75 districts. I think one of the largest in the numbers in all over the state nation. We are facing basically floods, droughts, lightning, and earthquake kind of hazards in the state. Uttar Pradesh is first in the Composite Disaster Vulnerability Index and fourth in flood hazard. We have 40 districts which got flooded every year due to floods. And in case of lightning, we almost face 200 to 300 deaths every year in the lightning incidents. So in the state of Uttar Pradesh, for tackling these kinds of events, we have set up a state emergency operation center. In which we are proposing to establish approximately 2,500 automatic weather stations and automatic rain gauge stations in all over the state. For bifurcation, we have proposing 450 automatic weather stations, and rest of 2,000 is automatic rain gauge stations, which will install in by next May 2024. And in the future communication, we are also in collaboration, working in collaboration with IITM Pune for installation of lightning sensors. As we have told by IITM Pune that they are proposing 5 lightning sensors in the state. And we also propose them to install 3 more lightning sensors in the state. And also our Chief Secretary is in mutual conversation with the Ministry of Earth Sciences for installation of Doppler radar in these 5 Doppler radar in the states, which we are proposing at Varanasi, Aligarh, Azamgarh, Jhansi, and Lucknow. Currently, we have only 2 radars, one in Lucknow and the second is in Varanasi. And the western part is covered by Delhi radar only. So we have more shadow area in this state. To cover that kind of shadow area, we are proposing these kind of frame. Maybe the Ministry of Earth Sciences have taken up this project and proposing for the installation. And for climate kind of things, we have proposing this Climate Action Observatory. This Climate Action Observatory is under EOI stage, in which why we are proposing this Climate Action Observatory, because UP is one of the state which faces flood with respect to with as well as drought in the same time. One of our eastern part is facing flood, and our western part is facing the drought kind of condition at the same time. That's why the prediction of events, maybe it's flooding or lightning or drought, is very difficult for the state of Uttar Pradesh. So this is the objective which we going to achieve by this climate action observatory, to build capacity for the state to predict the upcoming hazards or disasters, and reduce the disasters effect of the state. Because one of the popular state of Uttar Pradesh, if some kind of lightning event in one day, we have approximately 20 to 50 deaths in a day. So that is a very serious issue for the state. So for tackling that, we are start implementing this climate action observatory. तो now सबसे बड़ी हमारे यहाँ पे स्टेट में दिक्कत जो है वो है, we have data, we have information, but we do not able to use that information or data to tackle out the knowledge or wisdom. Because as IMD is issuing the forecast warning for 5 days climate for season, what a state has to do with that kind of warnings is lacking somewhere. Like, so if we are these kind of this is the benefit which we'll get after installation of climate action observatory. I've said this is the main part of this installation of climate action observatory. We are covering these 4 kind of things in that. Firstly, we are going to implement the data lake, because आज के टाइम में डाटा जो है वो सबसे ज़रूरी चीज़ हो गई है, और डाटा का आपस में कम्युनिकेट करना बहुत ज़्यादा ज़रूरी है. और इस समय पूरे स्टेट के पास अपना अपना डाटा है, कोई भी आपस में कम्युनिकेट नहीं करता है. अगर यूपी में बाढ़ आ रही है तो यूपी उत्तराखंड से कम्युनिकेट नहीं कर सकता, क्योंकि उनके डाटा सेट की क्वालिटी कुछ और है, उनकी डाटा सेट की कॉन्फ़िगरेशन कुछ और तरह की है. तो सबसे पहले हमने जो प्रपोज करना है इसमें वो डाटा लेक प्रपोज करना है, जिसमें बड़े बड़े डाटा, चाहे वो जियो स्पेशल डाटा हो, चाहे वो रिमोट सेंसिंग का डाटा हो, चाहे वो रेनफॉल का डाटा हो, वो एक जगह पे आके हमारे पास कोलेट होके एक जगह पे हम उसको कलेक्ट करें. देन उसके बाद हम इससे जो हमारे सेकंड स्टेट होगी वो होगी जियो स्पेशल लैब एस्टेब्लिशमेंट करने की. बिकॉज यूपी एक ऐसी स्टेट है जिसको खुद की एक जियो स्पेशल लैब एस्टेब्लिश करना बहुत ज़रूरी है. वी cannot rely on other stakeholders for little kind of things. For like अगर हमें flood का कोई modeling करनी है तो we have our own tools by which we can do that kind of things. So these are the things which UP is going to propose, and by getting your suggestions, we can implement this climate action observatory in this state. Thank you.
Thank you, Mr. Chandraprakash, and also being so quick and concise. Yeah, okay. Mr. Chandraprakash. Yes.
Actually, IMD is already working with UP state government. What you mentioned about almost 2,500 automatic weather station and rain gauges. There was a high-level meeting between IMD and Chief Secretary UP. And then we agreed that entire technical resources IMD will provide. Entire RFP of the system we have provided. I think tender is also over.
Tender sir हो गया है.
Tender हो गया है, and I think the state is going to get almost 2,500 automatic weather station and rain gauges before next monsoon.
Yes, sir.
That is what is planned. And why I'm telling this example here, because there are many other states who are representatives are here. Maybe certain things we can copy paste. Like, IMD can use its entire technical resources, entire technical support for monitoring, installation, and other aspect, and the budgeting part can be handled by them. And we have also ensured one more point here, that whatever data goes to is generated from the 2,500 rain gauge or AWS system, one input directly will come to IMD server at Pune. So what will happen, it is a win-to-win situation for them also and for us also. So that this type of rain gauge network will be readily available by next monsoon. And also he has talked about the radars. That also I think some discussion is going on for additional radars, where again state government is going to tender is already floated. Thank you, Surajji. So maybe we can think in this way also. And I'm not very sure about that CRO, what you're talking, but maybe sometimes we can discuss that also. Thank you.
Sir, one more request. We are also requesting for lightning sensor in the state. Sir.
Thank you. Thank you. I thank all the speakers for giving such a nice presentation and summary. And I would like to invite Dr. AVM Tyagi.
I'm thankful to all the speakers from the states, and I'm good response from the IMD. So we have to work in a collaborative mode to achieve the basic requirements of the NFCS. Observation is one of them, very important, and also the various existing products which are available, how it can be used by the states, and the states requirements which are coming up. I'm sure it will be taken care of by the NFCS and the IMD. So thank you so much. We are running behind the schedule, so but it has been a good inputs from the states. Thank you.
Thank you so much, everyone. Thank you, Air Vice Marshal and former DG IMD, Dr. Ajit Tyagi, and Scientist G, Space Application Center, Ahmedabad, Dr. Pradeep Thaplayar, to chair and co-chair this session. Thank you so much. Now I invite Dr. Satyaban B, Ratna, Scientist IMD Pune, to explain about the breakout session, which is our next session. Thank you.
Good evening, everyone. We know it is already late, but this is an equally important session for which we all are waiting. And actually, this is a breakout session. All the participants are divided into 5 groups based upon the 5 pillars of GFCS. That is observation and modeling, research, modeling and prediction. 3rd, climate services in information system. 4th, user interface platform, and 5th, capacity development. In this, all these 5 groups, there are a moderator, group coordinator, and rapporteur. And for the point of discussion remains same, because all these breakout discussions what happening today, there will be a presentation, or the conclusions of the breakout session will be presented tomorrow, which will be coordinated by our group coordinator and rapporteurs. So due to that reason, the points of discussion remain same for all the discussions, because they will discuss about the key stakeholders in the country, current status, major gaps and capacity needs, links with other GFCS pillar as listed above, and a recommendation on near-term and long-term actions to pursue related aspects on the NFCS. So I am announcing the names of each group based upon our understanding. But if you feel that other groups may fit, you may please switch to the other group. So the group 1, observation and modeling, they will sit right away in this. It is both limited. Yeah. So the observation and the group 1 is observation and monitoring. They will sit right away in this room. Moderator is Dr. J.V. Thomas. Group coordinator Dr. Sijo Zakaria. Rapporteur is Mr. Sudarshan Patro. In this, the team members are Dr. K.P. Sudhir, Srimati Kimnei, Dr. Pradeep Thaplayar, Dr. S.I. Laskar, Sri Narendra Kumar, Sri Charan Singh, Sri H. Warzari, Sri Rajashree Bothale, Sri S. Dr. Balachandran, Sri S.G. Kamble, and Sri Animesh Das. This is for group 1. And group 2, research, modeling and prediction, that is in the coffee hall where we are having tea and coffee. Moderator is Dr. Surya Rao, group coordinator Dr. O.P. Srijit, a rapporteur Dr. Sudeep. In this team, Dr. Rajivan sir, Dr. Saji Mohanda sir, Engineer Tana Tage, Dr. Bhoop Singh, Sri Khwarmalong, Dr. A.K. Sahai, Dr. Becky Thomas, Mr. Kalpesh, Dr. Gunwati, Mr. Vijay Thomas, Dr. Vijay Lakshmi, Dr. Anshul Saxena, Dr. Jayant Mahajan, and Dr. Bandana Bhagat. Group 3, Climate Services Information System, that will be in the ground floor. It is close to this the venue for this cultural program. Moderator Dr. Pulak Goa Thakurta, and coordinator Dr. Rajiv, and rapporteur Dr. Asa. In this team, Dr. Ajit Tyagi sir, Dr. Sinan Nijar, Dr. M.M. Ali, Sri Sarthak Saurabh Mahapatra, Captain Ramanathan, Mr. Mahendra, Dr. Sanjeev Adhyavadya sir, Ranju Madan madam, Rupa Kumar Kolli, Dr. V.K. Soni. In the group 4, moderator is Dr. D.S. Pai, and the coordinator is Dr. K. Niranjan Kumar from NCMWF. Rapporteur is Dr. Deepya. In this, Dr. Jainath, Sri Pranjal, Dr. Pooja Rana, Miss Anjali Marar, Miss Nidhi Jamwal, Srimati Puspa, Dr. N. Subhas, Dr. Avyan Tiwari, Dr. P. Sil from NIV, Mr. Nitin Vasi, Sri D.S. Chaskar, Sri Vikas Kumar Yadav, Dr. Maj, Sri Amarinder Singh, Sri Dilpreet Singh. And the group 5, which is the 5th group, group 4 in the same hall, but in the 2 corner. That is in ground floor 1015 room number. So group 3 and 4 will be in the same room in the 2 corner of the room. And the group 5, it is a IV hall in the ground floor. There is another IV hall. The moderator is Dr. Aakash Shrivastava. Group coordinator is Dr. D.R. Patnaik, and rapporteur is Mr. Ranjan Fukan. In this team, Dr. Sandan Kumar Bal, Dr. Anshul Agarwal, Dr. B. Mukhopadhyay, Sri A.K. Bhattacharya, Mr. Suresh Ram, Dr. Goutam Das, Sri Raj Mudlayar, and Dr. Gyan Tripathi. Sorry for announcing the late. We could have planned and displayed all the list, but some members, another thing, those names who for whom I have missed the announcement, you may please join the group which is closer to your interest. Sorry if we missed your name. Sir, this will now this is within 30 minutes we will try to finish due to the late of time. Sorry for the inconvenience. Yeah, by 6:45 we will try to close, sir. 6:45, yeah.